as well. And remember, I always look at these for the first time in detail when I record them, so I don't rush through them. You know, when you're so familiar with something, you're going to rush through it, but that's not the purpose of the video. So we're not rushing. And so we're going to paint some stuff too. And the good thing about this, if like I will be doing, if I'm doing the takeoff for the finishes, then I'm also doing the takeoff really for construction cleaning, which is good because I have a client where I need the construction cleaning takeoff totals because, you know, for the finishes, they put them in, everything's still dusty and everything. So the final or construction cleaning has to go through and clean basically the same surfaces, the same linear feet, you know, and that's how that's priced too. It's like how many square feet of flooring are you mopping, or mirrors are you cleaning, or storefront glass glazing are you cleaning? You know, you multiply that by 2, you know. So when you do the takeoff for the finishes, it kind of helps you out because you're doing the takeoff for the final cleaning too. And so this is the plan view for the floor finish plan. And you know, what we'll need is the plan view for, you know, to get our linear measurements, right? But we need to know how many square feet of FRP, right? We need the height of the walls. And so we'll typically look at the interior elevations, or if the heights are all 9 feet or whatever, we'll look at that. Or worst case scenario, we can look at the reflective ceiling plan, because let's go to that real quick. Because the reflecting ceiling plan is the purpose is to give us the ceiling height. And so, you know, worst case scenario, we can assume that the height of the finish on the wall is 6 inches above the ceiling height. Worst case scenario, if you don't have interior elevations, because you do want to get as close measurements for your wall paint. You know, there may be a portion of the wall, like in bathrooms, where it's tile 7 feet and then painting the remaining 2.5 feet or whatever. So you always want to have interior elevations, and this one does. So here's the interior elevations, and so yeah, it's a 10-foot height. So we guessed that pretty well. And so what's this? And what is that? I don't know what that is. And so sometimes the interior elevations aren't the best. It says open beyond. Open beyond. I don't know what this is. But okay. And so we can take our FRP totals really, and we just do the whole wall, and we have to paint the doors. And so we know the door square footage is this times 2. And then we also have to paint the frames. And so you have to measure the frames times 2. So, and then the wall base one here, and I don't know what 3 is. Let's see what 3 is. Floor sinks. Okay, we don't have to worry about that. So that's in the floor. They're trying to show that. That's okay. That's not cute. All right, and then 8 conduit. Okay. So, for our FRP, everything has to be to scale. And I know all my plans are to scale, so I'm not really worrying about checking it. But you are supposed to check if you have because this is 10 feet, right? So, let's get our dimension tool, like our ruler, from hash mark right in the center to hash mark in the center. Yep, 10 feet. So I know my plans are to scale. And so now I can just use the interior elevations. FRP. FRP. But we won't include the door, which we actually could, but we're not. And see now, this is the wall base. I like to be accurate, so I'm not going to include that. And we won't include the door. We'll give it a little extra for that. And so that wall is 146 square feet. So we do that for the whole thing. And then, of course, we have our cost book. Let's see how much FRP is. All right. That's ugly. Let's take my name off of there. That's ugly. Take the name off? Okay. Where is our search? Where did it go? Let's bring that up here. FRP paneling. So, here we go. Here we go. So, that's the typical almond or white $1.13 a square foot. Let's get that off of there. FRP wall and ceiling paneling, fiberglass reinforced plastic, textured 0.09 of an inch thick, class C, flame spread. Oh, that's the flame spread is the class C. So we'd have to look if that is what they want for our project. It may be class A. If it's kitchen, it may be a higher rating. Who knows? But this is what the cost book is telling us the price is for this one. Spread 24-inch by 48 panels, includes fasteners, adhesives, and a 5% waste. So for that is what's included in the $1.13. So, and that's the man hour total, meaning that's how much of a man hour it takes to install one unit. One unit's 1 square foot. So we do all. If we have 1,000, then we say it takes what 1, 2, 3 zeros, right? So we move 3 zeros to the right. It would take 32 hours, right? 32 man hours. So what, you would have a couple folks doing it, so it'd take you a day. You knock it out in less than a day, right? Da-da. Okay, so let's go back. Excuse me. I always got to cough. It's like, why can't you cough before you start recording, ding dong? I can't, because I'm always recording. All right, so we do that for that. And then, these are windows, right? That represents windows. And so we might have to paint the window frame. So we want to designate window frames from door frames. Okay, and then the wall base, I'm going to go back to the floor finish plan for the wall base, right? And then the doors, I just know how many doors. And then the wall base, let me make sure this is to scale. And again, when we do this for the finishes, we're basically doing it for the final cleaning too, because we have to wipe down, clean down, all this stuff. So now we know all of the FRP is 10 feet. So I can measure, let's just do it this way. FRP. It's all FRP. But we can go through the door and then we can delete however many square feet the door is, right? Because we know it's all FRP. And then if the wall bases are different, now we'll do that separately because the wall base doesn't go through here, right? Wall base doesn't go through the door. But see, you got to make sure too that you measure both sides, right? Measure both sides of that door for the FRP. And then it's all FRP. FRP. Da, 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 da. And we just gonna do this. Probably corner guards that go over there, but that's okay. We want to make sure. So let's go from here and back all the way up, and then we'll look at the section view if we wanted to. It's typical, whatever, 2 over A 5.2. Let's go look at that. 2 over A 5.2. Because you always want to look at your stuff. 5.2, what page are we on? 5.2. 5.2. All right. So it's just telling us about, I don't know which one I looked at. Okay. Conduit, floor base, FRP. And we got this here. And then we have a sealant. So we know how our at our floor, what it's supposed to look like. And then at the ceiling, of course, yeah, we typically go 6 inches above. All right. So yeah, that's good for that. And floor finish plan. So I need to do, I mean, they even have FRP in the bathroom. So, and so altogether we have 146 linear feet. So times 10, because we know it's pretty much all 10 feet. 1,460 square feet of FRP. And then basically, let's see, wall base 1. Is it all wall base 1? Because we could really subtract this length. Is it all wall base 1? Yeah. So we know wall base 1 is the same length minus, oops, look, boop, boop. Da, da, da. Almost forgot that. Let's add this. And then we really know that wall base 1 is the same length as the FRP minus 2 times the door, right? And that door. So let's just call this deduct WB1. And then we good. We saved us some time. So we'll go from like here to here, do actual lengths from here to here, and then here to here, and everything else is wall base 1. Probably just do also at windows. We'll just give it the benefit of the doubt. Just say on the estimate we've included wall base 1 at the windows. All right, so we deduct basically 9.5 feet. So 10 feet we'll deduct. And then we know wall base 1. And then the doors are painted. And we know we have 1, 2, and we just look at the door schedule really. And we know the amount of that caulking in between is the same length as the wall base. Pretty simple. Oh, and then the sealed concrete, because the whole floor is sealed concrete. Let's see. SC1. I think that's everything. Right? SC1. Oh, yeah. SC1. SC1. So that'll be real easy. Yeah, everything's SC1. So we just say concrete area or floor. Let's say floor, because we do a lot of takeoffs. It's like concrete. What is this? The foundation? What are you talking about? Cover. That way we really know we're not talking about the foundation. But what I will is I'm just going to include all the walls. Well, no, I won't. Because it's always fun to do this. So we won't include the walls, right? Ooh, let's see if it'll not mess me up. Watch. Here we go. Sometimes it does its own thing. Let's go back. Tighten it up a little bit. Watch my perfect wall. Bam. Because we don't want to include that. Because we are experts. New section. And let's take care of that old bathroom. Or is the bathroom? No, bathroom's concrete too. They're not really spending a lot here. There we go. Bam. All right. So we know our area, which is our area of the ceiling. If it's all acoustical. Let's look at our reflective ceiling, because that's a finish too, right? That's a finish. We need to know our reflective ceiling plan from our, if we have any gypsum board, which we don't. So our 2x2, I'm sorry, 2x4 ACT is the same as our floor, pretty much. Our concrete floor, which is 604 square feet. So that's the same square footage. You might give or take the, for the lights and for the supply grills and the return grills. We don't care about that, because they still have to adjust it. So anytime it's less than 2,500 square feet, they charge a little more anyway because of all of these that have to be adjusted for the size of the building. So same thing. All right, so let me see. I think we got everything for our four finishes only. Our paint, right? Let's go to our, where are we? Let's go to the interior elevation. Ta-da. All right, so we call this door area, and then times two. All right, because we have to do both sides of the door. So, I mean, we could just, because we have two doors, we don't have to do it, but I like to show the kids. All right. New section. Where's that other door at? Here it is. Here's my friend, the door. All right. All right. And they say I shouldn't go longer than 10 minutes on these things because you guys get bored. But this is, you can't get bored when you're learning. All right, kids? All right, so let me stop that. And then our door frame. So we're just going to say times 4, right? Because 1 on the other side is 2. This one, 3, 4. So, I mean, we already know it's the height times 2 plus like 3 feet, whatever the width of the door, but let's just measure it. And we'll call it door frame times 4. Remember that. But then if we have like a zillion, then we'll have a different procedure to do this. We only have 2. Okay, that's close enough. So that's what? 17 feet usually. All right, 16.9 feet. So 17 times 4, because you price when you paint, right? The labor to paint something that's per linear foot, because that's how you paint that. It's a different labor rate than when we're painting something that's obviously a larger area. It takes more precision, so the labor rate on painting anything that's linear like that is more. So we always want to separate when we paint the wall paint, if we were painting the walls, we're not, from the ceiling paint, because ceilings you have to go up higher. So of course the labor is going to be more for that. And for linear, that's a higher labor rate. So I think we got everything covered for this one. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please give me your comments below and enter and subscribe to enter. I like giving away stuff. I also have a nonprofit, so giving's in my bones. We every month starting the 15th of October, we're going to give away a $100 gift certificate for Starbucks. I'm going to be giving away some free construction training of your choice to all of our subscribers by entering, and if you so choose, or somebody you know. And for companies that listen, we will be giving away $1,000 in free estimating credits for any of the trades that you see us teaching about. So thanks a lot for joining, and I will see you next time. Start. All right. So we are going to first complete the floor plan, because we are going to complete a cleaning estimate for a client. And also we are bidding on this ourselves, so we are always looking for all of the trades: framing, painting, drywall, in this case concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so let me make sure we have everything set before we start. And the first thing we always want to look at is the scale, and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation, actually, because this is pretty much easier to do, we're going to look at all of the call outs, detailed call outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first See, we have here, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening, because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load bearing walls, from our storefront window walls, because the wall portion is going to be totally different than if there are no openings or if it's not the storefront. And so we've already, so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront. Storefront walls. Because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there. Because too, we're going to do this for final cleaning, and the final cleaning is going to really have to clean both sides of the windows. And so that's good for that too. Looks like these are also some kind of window. It's a drive-through most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right, because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors, because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4 over A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation, typical, so all the way around. 5. EFIS system, typical, and 7. Pre-finished metal coping at, so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that. 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls, because they are different at different heights, because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist, 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer is going to do that. And let's see, I mean, we need some, let's see, we got to have some more details as far as the walls. So that's the storefront area, all of that window. And so final cleaning, we know we're going to clean both sides of that, so that's easy. And then there's some other drive-through window. And so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale 1/4, because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window, and if it's not, it's okay, we'll deduct it. And you know what, we're going to go through all of that is going to be window, because we got to clean it off anyway. And this is our exterior elevations, and so that appears to be window. We got to clean the door anyway, and all of this is times 2, and then we get this little window, because we got to clean both sides. And so we'll make sure we have 4, it's like 2 elevations, no, that's 3 elevations. Make sure we have all the exterior elevations, so we can make sure we have all as many square feet of window. And you know what, we're going to include that whole thing, because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other, one more page that has just a, no, that's the building sections, so that's okay. So okay, and so we have that, we have the framing, roof plan. We're going, oh, parapet cap. So now we're the roofer, and we need to know, we need a couple of things for the roofer. First, we gotta scale it, and we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. And we do all your estimates too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do too. So we have the total square feet. But what we want to also do, remember this is a share. And so we're going to deduct roof openings, because, oops, our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, oh, we're a little off, but that's okay. And so roofer, with the roofer, and so we just finished what the framer needs real quick, right? And hood below, this is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet. But because my tool gave, I did point by point for each of these squares. See how that square is 28 linear feet? That square is same thing, should be right, same 28 linear feet. So I don't have to do the linear feet, I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43, so that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird how they price it, so I'm just going to do that just for the heck of it, so I'll know, just in case they need it. Oh, look, forgot that. Look at that. Openings, deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top, so linear is going to be off. Or look, bam. Yep. Let's start over. I don't know if I did that on the other ones, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacy should have done. All right, and another thing we need to get. We know we've got roof drains, so we're gonna need the roof drain. We're gonna need the flashing for the roof drain and overflow drain, and then we're gonna need the perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. Alright, so what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see here all of our walls. So for our framer, what are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Rough carpentry, that's a 6-inch bottom plate, or 2 of them. Well, you can always measure and make sure. That might be a little. Oh, that's about the same. Is it the same? We'll look on the foundation, but we know that storefront, height, tube, wood stud walls with that insulation, vapor barrier on inside face of wall, refer to structural for stud spacing. For structural for stud spacing? Okay. EFA system over waterproofing over exterior sheathing. Alright, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our window top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member, it's the header. Below the window, it's from the framing, kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. Alright, so, and this is interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A 421. Let's do that. Because when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, oh my God, I'm so glad. Almost thought I didn't turn the mic on. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over a 413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet or whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over A401. So whatever I see at 4 over A401, I mean pretty much all of the exterior walls are this construction. So I go to 4 over A401. I go to 4 over A401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over A401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, da 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 da. Oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over A413, now I get more specifics. 1. Now I know how my wall is built, because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else, and I'll know it's the same wall. What's the and it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. We'll see what this is when we get there. It might be this afternoon's presentation. Girder truss. And let's see what we got. Oh, feet prefabricated truss by others is this distance. Now that's what I like. Is when I have a set of plans that show these things. Okay, so when it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here, and then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up now. Yeah, they're breaking it up. We got arrows. There we do. Okay. So here we go. Let's start again. Because like I said, never look at this until I look at this with you. All right, so from arrow to arrow, we have this type of truss. 1 or 2 ply
prefab trusses by others at the 32s. Da, 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 da. Okay. And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. 1 or 2 ply prefab. Da, 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 da. Then we got another set of arrows from here to here, and we look for the description. So when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch. Oh, wait. Yeah. Feet? No. Heck no. What's wrong with me? 32 inch. One. 32 inch. Another one. 32 inch. Another one. Da 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 da. All the way through. Okay? So if you want to know how many, because you can't, I mean, I guess you can. I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches. Divide by 32. Either way, the first way is so much more nerdy and special. All right. So we always going to look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay. And usually with fabricated metals, the last digit on like W 84 by 115, the 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down number 2s, wall number 6. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls, and we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our post, all right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, are 15, 16 foot. So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade. We'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16th vertical and horizontal. That's nice. So number 4 goes this way and that way, so you do it the same way. If the number 4s are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction for the how many linear feet of how many linear feet of number 4. All right. What else? Because our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade or wipe it down or buff it or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one, but from here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer, is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. S200, 7 and 6. Oh, look at the beautiful stem wall there you got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. It's a 6 inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete. But then concrete is in cubic yards, right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate, I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got it when they talk about that. We've got also the waterproofing, okay, exterior footing, all the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So I don't know. We don't want to spend a lot on our stuff here. We just do that. and let the pros figure it out. All right, shear walls. Here we've got our steel. God, I can't even think. I just said it. Our structural steel headers, posts, beams, plans. So we don't have a construction defect. Okay, so this is typical base plate, concrete wall connection, HSS column. Okay, so 2 times da 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 with hex nuts, just 2. It don't say per side. Da, 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 okay. Alright, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? Alright, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall, or continuous footer, stem wall, and we got the hooks here, and then we also have individuals running the whole perimeter, right? This is a section view, so we cut it and then we broke it apart, and this is what the interior construction. So this is what we use for our detail material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that. See my foundation. I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers. See, so when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections, because you want to go back and look at each of these, because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with da 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 da. Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S201. 201. 9. All right. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, what, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall, because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24s. And this is a continuous, right? So it goes all the way through the slab. And this these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah, so however long the slab is, that's how long that continuous is, which is this. I like that. So when you can go from what? Plan view to section view, and the section view will take you to detail view. You'll make sure you have a good thing. All right, so we're going to take a break, and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel even. I don't even see that we have the panel. I don't even see the panel. So like just put the lights in. There's no panel. Let's see. The junction box, lights. Yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will. To make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo, civil set, utility plan. So that would be our power coming through. Water. Where's power? Water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm gonna look. Sewer, grease, trash, existing, cap, this, that, and something else. No? Do we have a electrical site plan? Other than, okay, no. So we just, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So yeah, we'd have to get more details. Oh, there we go. Yeah, shell, of course. We just had it floating out in the middle of nowhere, but it's going to be somewhere. And we have to look on I'm sure it's shown on the utility plan. We'll find it before the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle. That's going right there. Next to it, I think that's a hotel. That's coming up later. So, yeah. We've got everything. The civil set. Yep, 23. Right? That's what in the pickup window. And then we're going to do site demo this afternoon. We've got some site demo. We knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yep, it's going to be beautiful. And we got some concrete, site concrete now, other than the foundation, right? So the site concrete is going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want, and that's the only way I can do it. Now they'll sell you $1 zillion program that'll take all of this and claim they're doing it, but nope, I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon. But right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to, I don't think they'll have to wipe down the exterior. Other than, oh look, we left out windows. That's why you don't, come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday, I don't think. Alright, And so the framer has what they need. And all of this is that parapet wall. I'm assuming that I did get the roofer. Let's see. Fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. Because right, valleys are lead us to water flows from the valley. Might be some parapet walls. I mean, some crickets in here, but it doesn't really say specifically. And that is another opening for our roof thingy, so we can get on the roof. And that's where our ladder is on the other side. Alright, so the roof is good. And what's 8? Let's see what 8 is. Canopy, okay, we don't care about that. We're not going to install that. They have a vendor. Alright, so we have our floor plan. And let's go to, because we got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra. Let's scale that. 3/4 equals 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was 8.5 feet, right? Well, no, not the parapet wall, not the no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension. Because we want the additional, and we'll add that too. Because it's got to, they say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there. Extra 5 feet. So an extra 5 feet times 411. So that's a lot of extra TPO that you don't want to mess up or forget about. Alright. I think we got it. I think everything. Insulation, we're going to go up the, let's just do this. Insulation. 14 feet. Say 14.5 feet times 411. Right? That's the perimeter of the building. So we got pretty much everybody's takeoff. Just have to do more in terms of the foundation. Or let's go, where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's foundation? Where is it at? Okay, no. Another thing, framer needs to know all of our doors, so we only have 3. And then the storefront, that frame really is questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're gonna take a quick break until 11 a.m. to let it all sink in. We'll be right back. Okie dokie. We're going to get started again. We had to take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing. So we won't break down the individual pieces of, say, like the foundation until, we're ready to win and do the work and get an actual pricing. Foundation assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree. That's how they base, either putting it in or taking it out. Okay, so that's important to know, and if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side. This is probably. So we'll saw cut that. Include the price for a demo for saw cutting this, because this is really attached to something. Just like maybe this is. I don't know. But what's the scale? On these plans, scale's in a funny place. Here we go. 1 inch. Oops. Cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. And in the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced because that's how we price it. It's priced different if it's reinforced. So we're going to go like this, this. Let me go down. There we go. Oh, come on, don't fail me. let's see, 1 and 2, 1 and 2. Yeah. Okay, so there's a lot of protect. So we just going with what we see, remove, and see. That's a big tree. Those are two big trees, huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. All right. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Reveal an 8-inch sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Given to. Not our problem. Protect. Now the protect part, we can do some protect. We're going to the specifications on how they mean protect, and we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels, probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. All right, let's go back. Let's get this one. All right, so what do we say that was? The panels are 16, 17 is curb and gutter. Okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. And we'll just 17. Alright, and panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. If those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. Let's see, 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. There's a separate one. I guess you just gotta go out there and see if you find some boulders, because they're not marked. So wherever the boulders are, get rid of them. That's extra. all those are things to note, but nothing to really, you know, be able to determine because they're not shown this or anything. So that's like removing a tree, depending on the size. So that's that one. All right, so we go all the way down. The striping plan, really, we just now they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a 3 to 5 foot sidewalk. So let's see, we're going to do it both ways this afternoon when we come back together. So we are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right, so scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 foot, not even 6 foot. I go by 6 feet because it's closer, but then you got to make sure they're all 6 feet. See, that's 6 feet. D, now that don't look 6 feet. See, that's 5 feet. 6 feet, what's that? Is that a special? That's a special kind. That's a curve right there. So, can we use all 6 feet? Or just measure how many linear feet? You know what? I'm going to use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk, instead of doing it by the square foot, because we're going to do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're going to just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's patio area. I'm gonna make that different. And do we do all D though? Yeah. All right. So that's the sidewalk, and then C was parking pavement. We're gonna do that by square foot. We'll call that parking, and then we'll go by cost book wise what it tells us. So we're just going to include all of that because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Ooh. Ooh. Going to Nilly Willy. Yeah, let's just cut it off halfway right here. Cut it. Because I like to be as precise as possible. Alright, let's cut it off right here. this and the small little curve. Let's go. Let me just go. We're gonna add that. Very like surgery. Forgot I'm recording. Like, hey, it's still quiet. Except for the clicks. Alright, there we go. See. Let's see. Said that. Yeah, then we gotta come through and do the more annoying curves because we're a little bit. Ooh, look at me. Look at me. Alright, see? Alright, so striping plan. Why don't you call it the concrete plan? The heck? See, they broke it up in phases, but we don't care. Let's hope we're not asked. Alright, we got some arrows, so we do those separately, but in the meantime, what is B? Sidewalk. No. Did I say what? I said B. Drive aisle pavement. 5 inches. Then 9.5. 9.5. Da da da. We'll look at the specification, but I mean, we could go on, right? And what's G? We'll do G. Let's just know what it is. We got 5 minutes for this session. Oh, good. No. Landscape. That's good. That's where the flowers are going. Flowers, flowers. What's M? Bike racks. That's nice. Let's see. It's going to be flowers. Okay. Because that's still in this area and not in this area that we didn't include in the sidewalk. And the C right here is a little thicker. Right there. So we're going to say that's probably a, let's see. You don't have to guess. Well, what's this one? 4-inch. Okay, well that's the smaller one. Let's delete that one. We said they were all inch feet, not inches. So let's do this. This is still our 6-foot concrete. Up until we get to there. Then it's a 4-foot. 4-foot sidewalk. From here, right there, let's go over a little bit. From there to there. Okay, and then yeah, we'll fill all that in while you're gone. And then A, we'll fill that in while you're gone. And then G is the landscape. It's A. Oh, good. Existing. We don't need to fill that in. And so that should also mean we're not striping that. Let's see. Yeah, no. We're going to say we're not because it's existing. So we are going to always exclude existing striping. Alright. Stop right, so that is the Monday live edition of What the Heck is Stacy Doing? All right, so this is our shell. All right, so when we come back, we're going to complete the little pieces of the takeoff we didn't do, and more importantly, the pricing. So if you have any questions between now and 2 p.m. Pacific time, make sure to email me at education@sfjohnsonconsulting.com, and I'll see you this afternoon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I have a little information I wanted to give to our small GCs and large DCs so they can get ready for 2023. There's a new class we were given. I'm not sure how old this is, but I think it's awesome. If you've ever been to a live construction site, it's a very dangerous situation going on there most of the time. And I could understand that because when everything is active, everything is moving, it's hard to be able to make sure all of the damage and the hazards are actively where they're supposed to, right? But it's really hard to do. And so without a plan, it's even more difficult. So OSHA has a class that we are going to be presenting. It's a 4-hour class, though, and we will present it in 1-hour segments, and it's called Design for Construction Safety. So again, basically, the architects, engineers, they build a set of plans for us to put everything together, but they don't really put into mind or have into mind in their design how we should stay safe, right? So they have pretty much no involvement in the actual construction process, right? So what we're trying to do is give a course that gives a couple of course objectives, and one is to be able to identify the factors that contribute to construction industries and fatalities on site, right? General industry, right? We do things in a static, pretty much in one building. Things never change. We're just walking back and forth. But with construction, scopes of work change, equipment comes and goes, and of course, if you're in construction, you know what I'm talking about. And so this class helps the project managers, helps the construction people, helps the owner not be sued, because this is an active thing that we're doing here, and we're teaching you to identify the factors. We also explain and analyze how worksite hazards happen, okay? We discuss the hierarchy of controls for construction hazards, and that's very important. And then last but not least, we provide a methodology and with examples, okay? And design features to show you, again, to keep your site very safe. So if you go to our website, we have some information where you can sign up. This is a class. It is $4.99 per company. You can invite as many of your people as you'd like. So if you go to Safety Lane over here on the right side, the other left on the right, you're going to go down to Design for Construction Safety. Enter here, and then you'll be taken there. And the objectives again, why it's needed, what we go over, methodology, kind of give some information what the class is all about. And if you choose to sign up, please do so here. You can choose your own day and time. So for instance, what we ask is you pick the same time. So the class is available from 10 a.m. to 2 p.m. Pacific time. And so pick the same time, but you can pick different days. And it's just first come, first serve. And we're trying to fill up that class and the OSHA class. Now, if you so choose to take this class, you will get OSHA 10 for free. Okay, so keep that in mind too, which you want to be all wrapped up for your safety for 2023. Okay, so if you have any questions, please email me at education@sfjohnsonconsulting.com. Stay safe and let us help you do so. Have a good rest of your week, and I hope to talk to you soon.
Hey everybody, I just want to share a quick little video here on our painting estimating that we are doing for our AutoZone. And if you are looking to join a company that will do your estimating, work 1099, please visit our website at sfjohnsonconsulting.com. But in the meantime, let's look at this beautiful AutoZone. See all the pretty colors? Well, with the takeoff software we use, takeoff meaning measurements, it just turns it whatever color. Okay, and so when you do the paint estimate, you want to make sure you are always looking at the interior elevation. So I'm going to cut off the bulbs, the lights, and then we can see clearer. See here when you have the interior elevations, good ones will tell you, okay, number 4, white paint. And so what we typically want to do, because if we're going to actually paint this, oh, we have our corner guards going up too high. Okay, because we did the corner guards too, and they only go up this high, not that high. Very important. And something told me to look at that, but I didn't. So we have to adjust that. Because they're like $15 and something a linear foot for these things. So you got to make sure you're doing 8 feet, 6 feet instead of 12 feet, right? I got to fix that. But I don't think I sent that yet. So just thinking out loud. All right. So paint estimate. So what we're going to do, because we do have a good interior elevation, it's the 4 walls and the bathroom. So this is real easy as far as a paint estimate. And so we have to make sure we're to scale. And our scale, 1/8 = 1. And we can tell it's very good set of plans. And so all we did was go from the sweeping arms, right? I mean, it's the whole thing until you come across another set of sweeping arms, and then it may be a different color. Like we only mean from here to here because we're naming something different here. So we want to make sure, and what I did is do the stripe first and then fill in all the others. And so really easy. That was we had 2 different kind of paint on for the columns, where it was a certain color up to a point, up to 8 feet 7 inches, it said, and then the remainder was a different color. And so that's what that is. Then we did the remainder, that's a different color. And so to save time, because this is a column like in the middle of the floor, we know columns have 4 sides, right? And so we just do this times 4. So we did them all, but then we say times 4, then we know we did all 4 sides. Save yourself some time. And then the white paint, and then we just normally will exclude the openings, but we didn't here. We're like, okay, waste a little bit. It's just a mistake, but we could take it off and redo it and exclude the openings. All right, so that was the white paint. And then we had the other paint, which was the orange paint. And we got the red paint, even though, right, we could have recolored it, but who cares? You're just trying to do the takeoff. You're not trying to make it look like that. And then Shazam, you have the full takeoff. And then the bathroom, we only had to do the bathroom ceiling. And so that was separate. But then we had to do the second floor deck. And usually the X means it's open, right? So it's an opening there. So we have to paint the deck. And so that ended up being 21,428 square feet. And then we had to add the bathroom ceiling. And so in the final analysis, let's see, paint estimate. Let's see. Let's make it bigger. Where's the make it bigger? Here we go. Paint estimate. How much are we going to try to get paid from this? Oh, the other way. Come on. We're going to try to get plus or minus 30 G's for painting. And so how we break down a good painting estimate, the labor, and then we know that we're going to have one primer and 2 finish coats. And so that's the labor for that. So basically, all of that, that's the labor for all 3 coats per type of whatever we're painting. So the labor, and then we add the material separately. And we add a little overhead and profit, primer, and we did by the gallon. You could do by 5 gallon, be cheaper. And then bam, you have a good painting estimate. So if you need any assistance with any estimates or would like to learn how to do this yourself, please let me know. Otherwise, tell me what you think about it. Make sure you give me your thoughts, like it, and make sure if this is your first time that you subscribe. I'm the owner of SF Johnson Consulting, and I pretty much started as just some background. I don't ever talk about myself, but I was a construction defect litigation adjuster, and then over time determined to never work for anyone but myself. I took my brains and some good vibes, and I learned how to do just about everything any contractor needs in construction. So whether you are trying to learn, get your OSHA certification, learn how to do the measurements or the takeoffs or complete estimates, or just anything related to construction, I'm almost certain we can help you. Thanks for joining, and I will see you next time. Hey everybody, this is Stacy with SF Johnson Consulting and Construction Services. We are going to go over our next step in this project and the estimates that we'll be producing. And now this is our floor plan. And on our floor plan, a lot of things are here. And basically what we're going to be doing, they're all existing walls, so we need to measure it out because we need to, it's wall number 1, so we need to look and see what it tells us to do for that. And then there's another wall number 2, so we're going to measure that. And of course, from the floor plan, we can measure how many linear feet, but then we have to find a section view to determine the height of the wall, because of course we need to measure in terms of square feet. And so we're going to do what's easy first. We have a little legend up here, gives us an idea. So that's trenching. Then this cable in the floor, new skirting. I'm like, skirting, I have to look that up. And the partition and bubbles, right, means that we have changed the plans, and then we look at number 2 to see what the change is, and that triangle 2 should be somewhere on the plans. Triangle 2, the new date was just on the 12th. And let's see. Here we go. Supply and drain pipes under labs shall be insulated or otherwise configured to protect against contact. Okay. That's the revision. Okay, so but the first thing I'm going to do is make sure we set the scale. What is that? 3/8. So yeah, we'll have a part 2 of all of these. Did a demo already, and then we'll have a part 2 of the pricing and the Excel spreadsheet probably Sunday. It is Saturday, October 22nd. Didn't this month go by so fast? My goodness. All right, so what are we doing? What did I do? Okay, so trenching. Let's do that first. So that's a Let's do that. We got to get more detail on the trench, but let's do that first. And where else did I see it? Over here. Okay, this is pretty easy as far as the takeoff, so we won't take forever. All right, and then we have to do that wall number 1, and then we're going to take a look at what wall number 2 is, what wall number 1, wall number 2. And so we're just going to call it wall 1 and measure the length. And so that's here. And it does include these two. And then usually I'll go halfway through the door, right? Because I'm measuring the full length of the wall, but the wall isn't full length. Or I could just not go through it at all. Now this is the bathroom. It doesn't have that in the bathroom. So yeah, the bathroom is going to stay as is. And I'm going to go halfway through that door. Everywhere I see the 1. Both sides are halfway through the door. That's a 2. It's 1. And 1. And just all the way where we see the 1. Oop, kind of crooked, but that's okay. And what we got in here? There's something else going on in here. Yeah, that cladding. So we'll do, that's different than these. So we'll do that. Assume it's this too. And that. I don't know what's going on there. We'll take a look. We'll add that later. Alright. I think we got all of the 1. And then now we're going to do wall 2. So like I said, this one's pretty easy, and I believe we're putting new. Then we'll go to the ceiling plan. That's wall 2. And we'll take a look and see what wall 2 is. There's nothing going on in there. Da 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 da. New skirting. Okay, now as far as the flooring, now what we're going to do is floor F2 bathroom. Might as well get that knocked out. F2 bathroom floor, because we're doing the finishes too. And then if we do every corner, it'll do all of the, oh, we can't because we're not going through. We can't do, unless we want to do waste, because if we do every point, dot, 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 then we'll do the perimeter. So the full perimeter is 29.25 feet, but we won't be putting wall base here, so we can't use that. Or we can say that, subtract. Let's see, deduct door for wall bathroom wall base. That way we just deduct that, and then that's the bathroom wall base. Okay, that. And what we got on this floor, yeah, that's F2. That's F2B2. F2B2, same thing here. So we could do the same thing here. It's the same. So I'm just going to add to that because it's the same type of flooring, and then I can deduct that door opening length also for the wall base. Well, actually two. Well, remember that when I go to do the estimate, I'll just subtract it at that time. So it's 60 feet, 60.5 feet perimeter minus that opening for the wall base. Okay. And now got the walls. And now let's see ceramic tile. Oh, good. Owner supplies the tile. We just install it. That's nice. Skirting, I gotta look at that. Area B1 and area B1, whatever B1 is. But we're gonna do the tile because when we're gonna stop here too. It says here where the floor. Right here is where we stop the floor tile. All right, that's gonna be nice for the tile. That's gonna be a good amount. Floor tile's not cheap. The tile is cheap. The installation ain't cheap. All right, let's go here and we go here, and then we're gonna go. Let's go back up here to there, and then we come here and all the way across. Here. It's all floor tile. I'm not sure we're gonna have it. Those look like maybe we may not have it under whatever our fixtures are, but I mean it'd be waste. We could figure that part out later, but probably we will. All right, so that's the flooring. It says the sales area is that. Yep, look at me. Look at us. Okay, F1, B1, P1. So I guess the walls are painted P1. Okay, so if I did the perimeter, then I know that time the 10 feet for our paint. So we probably got about what? The linear feet of the 124, give or take, because I did every point. You can see the points I did. If you do all the points, then this tool will calculate your linear, so your perimeter. And if I say it's a 10-foot wall, then I've already have my paint. If it's all P1, which it appears it is. So that's the floor, that's the base, that's the walls. And I also have 124 linear feet of the wall base. So that made that easy. All right, so let's go to the ceiling, see what we got to do for that, which basically the ceiling we got to replace. Let's do that. 24 by 24. Replace 24 by 24 access panel. So takeoff is just making sure you count for everything on the plan and don't add what you don't see. All right, so it looks like we got new jib here with that hole, right? But it's waste. And I believe our hole got some speakers we'll have to account for, but I believe the new ceiling. New drywall. There we go. All right, so we're just going to redo this area only. Let's make sure it's to scale. And then our next one will probably be the electrical, because we need to just knock out the specialty trades as fast as possible. And let's do sales ceiling, and we know it's jip. Okay, remember we got a part two where we're going to get the pricing from the cost book and figure out how many man hours it's going to take. And really, the man hours is what it is when we determine this. But it's all about how many humans you have to do the work, how long it's going to take. It could take you 40 man hours if you got 5 folks. It's knocked out, right? Because each person can do 8 hours, supposedly. So you determine how many people you need based on the job you have to do and then how fast you need to do it. All right, so I think we got new, existing, so we just have to paint. Let's just do that because we know we got to paint the ceiling. So we just add paint, existing, trying to knock out all the takeoffs. Existing bathroom. All right, so we knock that out. And let's see. I think this is open ceiling. Yeah, I think that's open. I don't think we have to worry about that. It should. Oh, wait, wooden panels. Wait, hold on a minute. Back here, wooden panels? Oh, okay. Or just right here. I'm confused. I think just right here. It's wooden panels. Well, it tells me how many square feet it is. So let's just do, because it doesn't have it. I think this is the back of the house. I guess it's all the back of the house. Let's see. If it's 160 square feet, then it's everything. So we got the wooden ceiling panels, new jib for there. And then we have existing lights, existing. Let's see. Yeah, the cladding, we have another plan. We'll do that separately for that. And let's see, our section view, because we need to know SK1. So A212, we need to know the height of that wall, right? So we need to get the section views because we did the length. And that's not the one we want. Let's see. Where is it? That's for the door we want for the building. Let's see. Come on, where are you? I don't know. That's too far. All right, let's see. Oh, we'll use the demo section. It's just as good. All right, so that's the bathroom. So our height of our wall, 3/8. So let's do the scale. So we'll know, okay, it's already done. So we know our wall height. We'll call it wall height. That's probably what I was looking for. So we know when we're doing our prepping our existing walls, it's 11 feet 4 inches. Basically all the walls. All right, so that's everything that we could possibly do in terms of the takeoff. We'll have a separate video for the storefront there. It's a little more complicated, and I want to point out a lot of different things. So, yeah, and then the fixtures, the furniture. We need to probably determine mirror because we have to clean the mirrors. So we already know how long it's going to take us to clean because that's the only reason why we need that. We're not going to do an estimate to install, though. That's a great scope of work, installing the fixtures. That's good. If you can do that, you got to be a really good handy person. But oh, we got a floor mat. Let's measure that because we'll have to install that. So glad I looked at that. Anything related to the drywall framing and the finishes, pretty much, I'm gonna put in one video. Because you're with the looking at the set. If you know you need it, you might as well just go ahead and do the measurement. All right, because we have to install that. In terms of the flooring, that would be something they would probably want the flooring person to make sure they put set in place. So we're doing the flooring. All right, so I think that's it for this floor plan. We had to do some trenching. Right, let's cut that off. Had to do some trenching and basically the tile and then the wall base. Pretty simple. And then we're just prepping the existing walls to receive new paint. So if you have any questions, make sure you email me at education@sfjohnsonconsulting.com. Our next video will be on this storefront. Like I said, that plan for that is a little crazy. So I want to point out all the details. That'll be uploaded probably Sunday. It is Saturday. A little later than it should be. But you know what? I can only do these when it's nice and quiet. So it's pretty nice and quiet around here at late. So floor plan, did some trenching, existing walls, and we did all of the ceiling. We have a new ceiling, new paint. It's a pretty simple, really easy actually renovation. Good money with really simple work. So if you have any questions, email me at education@sfjohnsonconsulting.com and let me know what you think about the video, and please subscribe, and I will see you on the next video. Like I said, it'd probably be the storefront. Then we're going to work through all the mechanical, electrical, and plumbing because I have to submit this by the 24th, and it's just a matter of time. So hope you enjoy, and I'll see you soon. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are going to review our painting estimate. This is the same project we were working on for the demo framing drywall. Now we're going to do the paint. And so what we're looking at here is the reflective ceiling plan, because that's going to show us or help us. We will use this plan to determine how many square feet of ceiling we have to paint. And let's see if I printed out everything. Probably not for this one. For some reason this isn't printing. So we're just going to write it out. And now that I've mastered pause on the recorder, that's what we're going to do. All right, so we're going to put together this painting estimate. And when we think about a painting estimate, we think about the ceiling paint, wall paint, door paint, door trim, because that's a different labor rate for trim as opposed to a straight area. And when we think about the doors, We have the labor for the doors that we got from the cost book, but if we go by square feet, typical door is what, 3 by 7, and then you have to do both sides. And well, they say a door has 6 sides, and so we just go by the cost book, and we'll go over that. Door trim, so ceiling, walls, door trim, and then it had some other wall trim on this one. And so we did the takeoff already. What we're looking at is the ceiling, and so I think all of the ceiling was painted P1 or whatever, but we'll look at it. And so we have this. Let's take this pan hand off so we can do our square feet. So the main ceiling was 7'8". We'll just say 7'8". And then we had the back of the house, which is, we'll say that's plus 160. What was that? 8. We always round up. And then the bathroom was 52. We're not going to round that up. Okay, so we've got 788 plus 168 plus 52. We have 1,008 for that one. All right, and now for the walls, we use the interior elevations, which was real easy. So we have back of the house, and so what it should give you, right? A room has 4 sides, so this is cutting. It's not the best of interior elevation, but I know that's what they want you to use because it's telling you the paint color, for the walls. And so this is the interior. And so for the back of the house and the bathroom is P3. And for the main showroom area was a P1. So that's that one. And then the other side of the building, and this is the storefront. We did that separately. And that's the back of the house. And then the other part of the back of the house. And then we got that. And then we didn't include the door. And then this is the back of the house. The full measure of the back of the house. And so they give you the elevations. It's kind of funky, but that's what we're going to use. And so for this is for the wall paint. And then so for the doors, we're just going to use, I think we had 2 doors. That's all we had was 2 doors. All right, so let's go to the main estimating tab and do all of our paints. See, we did everything. We're going to come back and do a miscellaneous for flooring and wall base. So right here we're just doing, see, we had to paint the awning frame, so that's the additional trim. So we're just going to put, I think I did that, awning frame right here. It's 13 feet. And didn't I say times 2? No, we'll just say 13 feet. And then the storefront base had a storefront base. When you have a bad set of plans, it takes forever. Storefront base was, did I just see it? 37 square feet. And that's the trim, cladding, vinyl, paint. Here we go. P1 we had all together from the interior elevations. So that would be the wall. P1 is, because I like to break it down, because when we win, we have to actually buy each of the different paints, right? And then P3, I believe the ceiling was P1. P3 is 870, 875 square feet. And then the ceiling, which was also P1, I did that already. It's 1,080. So we'll add that to P1. I mean 1,008. 15, 6, 0, 2,065. Okay. Let's see. Let's make sure we have it all. And then we have 2 doors. We had the additional trim. And remember, when we do these cost estimates based on nothing, we just do the best we can. And then once we win, we go back and with a fine tooth comb and fix everything. All right, so let's go back to, but what I want to show you the most is how we determine how much paint we need. So let's get the estimate. Here it is, all filled in, ready to go. Today's not the 17th, it's actually the 27th. All right, so we said we had wall paint of, so this is our labor, and we are going to, it's assumed 3 coats. So that's our man hour unit. This is actually times 3. Okay, so this is the labor times 3. Right, because we have to do a primer and 2 finish coats. But how do I know this? Because I have a cost book that tells me that. I'm not just guessing. Okay, so, and the cost books are based on industry standard, just like when you are equated to when you go to the mechanic, right? They look in the book and they say it's going to take an hour and a half, even though it takes them like 30 minutes. But they still, according to the standard, are able to charge you an hour and a half. Same thing here. So we just go by industry standards when it comes to the man hour unit. So you got to make sure you have a good cost book and not your uncle. He's not a cost book. All right. So that's why we win. All right. Walls. So we said we had, how many walls? Oh, okay. We said we had, I did that with the paint. So all the walls together is 1057. That was P1 wall. And then plus P3 wall was 875. Yeah. So that's 1932. Okay. So that's 1932. That's square feet. It's a tiny job, right? And then the ceiling is that. We don't have a deck. So let's take the, we always reuse estimates from the previous one. And we had 2 doors. And wall trim, we had, that was that. Oh, wait. I didn't have that. This was this wall trim. Where did it go? Storefront. This one. No, this one. This wall trim. Around the windows. The window trim. So that would be 135 feet. Yeah, that's 135 feet for that window trim. So let's go back. I said wall, but it's window. because trim, as you can see, has a different labor rate than walls, or than walls, 0.15. Okay, so I said 135 linear feet. That knocks it up pretty wide, and then that base was 37 square feet, and door frames. We have 2 door frames. Oh, so it's 21 feet, 21 linear feet per door. Yeah, because it's 7 and 7 is 14, right? Both sides. And then the top is 3. Is that what I said? Yeah. 14, 17 per door. Both sides. That's 34. Then you have 2 doors. That's 68. Right? Do it again. Both sides, 7 and 7 for the sides. That's 14. Plus 3 for the top. That's 17. Do both sides. That's 34. And then we have 2 doors. That's 68. Okay, now we are going to do, let's see, ceiling will break we'll break everything down. So primer is everything, right? So we have to prime everything. We even have the primer. We just put the primer for everything. Now for the 2 doors, right? It's 3 by 7, 21. So a door is 42 square feet. And I have 2 doors, so that's 84 square feet for the 2 doors. Okay, so now we have to see how much primer, and we assume always with our paint, and we could go a little lower for custom homes or whatever, but for commercial, we assume that 1 gallon gives us 400 square feet. Okay, for the purpose of our estimates. And so for primer, let's get the old handy dandy calculator. We have to 1932 plus 1008 plus, what did I say for the doors? 84 plus 84 plus, we just do the linears as if they're square feet, because you gotta, you're going around them, you give yourself a little extra. Plus, I don't know if I did plus already, I might have to do this again. Plus 135 plus 37, then plus 68. So that's 3,264. Let's do it again. 1932 plus 1,008 plus the doors, which was 84, plus 135 plus 37 plus 68, 3,264. So for primer, right, divide by 400. Make sure I wrote that down so I don't mess it up. So I messed it up. 3,264 divided by 400. So 8.16. So for primer, we're just going to say we need 9. And for the walls, right, we have the walls. So for the walls, it's different, right? We're going to say, because we need 2 of those, right? For the primer, we only needed 1 coat, but for everything else, we need 2 coats. And so if we do for these walls, we need 2 coats, which is 19. So we're going to do them separately. So for the walls, we have walls here, 1932, right? 1932, but we really got to multiply everything by 2. when it comes to paint, right? Because we need two coats. All right, so 1932 plus what else says walls? Wall base, 37. That makes it easy for us. Walls, walls, walls. Okay, so we have 1932 plus 37 equals times 2, right? Because we have to do two coats. Equals 3938 divided by 400. Because we're looking for how many gallons of paint we have to buy. And that's 9.8, so let's just say we need 10 gallons. Now, ceiling, and we're going to fix this because there is no deck. And we didn't do any prep, but we always assume the prep is done in our demo bid because we bid everything, so we don't put prep here. And I have to make sure when I say all, exclude all not indicated above. Oh, good, I did. Prep is not included. Very good. All right, so ceiling, same thing applies, right? We have 2016, because that's all of our ceiling, right? Double the 1,008. Okay, and divide by 400. That's 5.04, so we're going to be on the cheap side and just say 5. And then our doors, right? Now, we can do door frames, but we said the doors are 84. 84 plus, and then we can do the trim too for the window trim all together. So 84, 135, and we did wall base with something else in 68. So we add those 3, 135 plus 84 plus 68 equals 287 times 2 equals 574 divided by 400. Right, we're gonna get two gallons for that. Just have a little extra, and we always want to add a lift and protection, and that is it. $4,202.25. We've added 5% overhead, 10% profit. Let's put that over here. Fix it, make it look all pretty. And we always spell check, automatically saves. But for this one, let's make it a little, oh no, we don't want to make it too small. Okay. And then we save it in a PDF. So to do this, we have to take the auto save off. File, save as. We go down here. PDF. We do it the old-fashioned way. And there it is. Nope, we got to make it smaller, you see. It didn't do it. It cut it off right there. So let's do it. We want to make it pretty. I think all of that'll fit. There we go. Make that a little smaller too. Save it because it's not auto saving. And then, because we want to make sure if they print it, you don't want that. They're like, let's throw that in the trash. They don't know how to format an Excel spreadsheet. Okay, good. There we go. All beautiful. All right, so that is we did the takeoff, I think on another page or in another video. I'm not quite sure. But now this is the estimate. And remember this is all. So we'll come back and do an estimate for finishes. That wall paint, somehow they paint that gray for some reason. And for your paint, always, oh, we'll do a final cleaning one too. That's what that's for. So for your paint, you always want to look for your ceiling paint. It's always going to be your reflective ceiling plan, and then a good set of plans is going to give you interior elevations. Even this is a bad set of plans, and it gives me interior elevations. So you can measure accurately after you know that the plans are to scale, and you can accurately measure your heights, everything. And we just assume that we're going to paint behind all of the fixtures. We're not going to deduct that. But what we did deduct is, I probably have to go put it back because you can't really tell from here, is wall base. If the cabinetry has its own wall base, or we use the wall base that it tells us for the flooring. But from here, see how there's nothing, you can't really, it's just a bad set of plans. Well, that looks like something there, but then there's nothing there. It's like, okay, well then there's something there. And if you're a good estimator, all these things will concern you because you have to do accurate takeoff. So, but then you just, hey, let them know in writing what you didn't include in the estimate or what you did. So, all right, if you have any questions, make sure you contact us at education@sfjohnsonconsulting.com. Give me your thoughts on the presentation, and please make sure to subscribe. See you next time. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and let's talk about finishes. So our finishes are anything that goes in and on, I like to say the project, but anything that goes on the project or in the building after the main structural components have been constructed. And so drywalls are finished, and that's the most odd finish, I think. Roofing materials are finished, and all the floor components are finishes. And so we want to go over this set of construction documents for the Brunswick location, because some of the finishes, every set of plans, it's not great. And so, just want to note some of the inconsistencies in the plans. And so the finish contractors will always want to look at the interior elevations and the finish plan. And so in the finish schedule, of course, let's look at the finish schedule. And so the finish schedule is going to give us each of the rooms and tell us the floor finishes and the floor and the base, and then all of the walls, north, south, east, west, and then the ceiling, and then any remarks. And so we can basically, been doing this forever, so I know I need to do, after I've done 3 of these, pretty much the same thing. Everything is sealed concrete, which I've chosen as epoxy. And there are some things that are not clear, and so you have to make assumptions, but then note the assumptions in the estimate, or just exclude what isn't clear. So the finish schedule, and so we go to the finish plan where we're going to make all of the measurements. And so we start here where we do all of the measurements for the bases. Pretty much everything was a rubber base, except for, I don't know why we did that different, except for the bathrooms, pretty much. And maybe I was doing some other, let me see, what is that blue for? Oh, closet paint. Okay, and so too, if you're ever confused about, because here you can only do how many linear feet closet paint, but if you don't know the height, usually the reflective ceiling plan will give you the heights of the ceilings in every room. And let me see if I can find that real quick. a good reflective ceiling plan. We'll give you the finish, which is, we can tell by the finish, this is very few painted ceilings. So we know that the ceiling, even if there was no way to determine the height from anything else, if there were like no section views or whatever, just go to the reflective ceiling plan, and then that's going to tell you the height of the ceiling. So you figure you're going to paint the ceiling to the height, right? You're going to paint the wall to the height of the ceiling. And so you have to go through and do each thing individually, because the height of the ceiling in the IT room is 9 feet. But then the restroom, we know we can exclude that, because that is, I think that is, we don't have to worry about that as far as the ceiling component, because everything here is acoustical ceiling tile. But as far as the paint, I believe the bathrooms are all tile, and I believe that, but they give us interior elevation views for the bathroom, so we don't have to guess. But usually you have about 3 to 4 feet of wall that needs to be painted above any bathroom, where they're like 7 feet of, if it's a 9 foot, it's probably 6.5 feet of tile, and the rest is paint. But this one's pretty good because we get some interior elevation markers. But again, if you can't determine the height of the wall for your paint, if it is painted, you can always go to the reflective ceiling plan. Kind of got off on that one, kind of. So, 2 finishes. You're going to look at your door schedule, because you need to know, and I specifically marked which doors I'm staining as opposed to the doors that I'm painting. So if you're the finished person, interior elevations, exterior elevations, the door schedule. And then if you are to paint the window frames, you can use this to measure the lengths. So that's good. Okay, so let's go back to finish schedule. So here's everything that we're going to do per room, and then all of the marks are given to us here. RB's a rubber base, ACT, and all of ours is 2x2. So you know what each thing is. Carpet tile, we measure that by square yards instead of square feet. So you have to convert once you do the measurement, divide by 9, all of that. And so did all the measurements. So the epoxy was this area, all the concrete. Then we had the ceramic tile, was all of that area. And then we had carpet tile and the luxury vinyl over here, and plywood. Now, plywood is all of here, but it didn't tell us that we're doing anything to the plywood, so we just measured it. Because the plywood is just the flooring, it didn't say we had to stain it, anything. So there's absolutely nothing included for that, including, but we did include the rubber base for that area. So the rubber base is included, but as far as the flooring, we didn't include anything, because the plywood is just what the regular floor is. Okay, and so that's that part. So that's all the interior, and then we always want to go back. So here, the interior elevations is going to give us all of what's on the wall based on the wall finish. Interior elevation 401. If we look at 13, it's the finishes on this wall. 12 finishes along this wall. 14, and so on and so forth. So if is for future reference, if you're looking at the finish schedule and there's a room like this room with no interior elevation, that I'll exclude it, because that probably means there's nothing that's going to be done. But then you go to the finish schedule, and that is the mezzanine, and I believe they don't even give this a name, so we don't even know what that is. So is it a good
set of plans saying just ignore it, or is it a bad set of plans? We had to do something, but it didn't tell us what to do. So I just left that alone. Only gave it the base, no finishes on the plywood floor. Okay, and so you got the doors. You got to see how many you have to paint, and then you want to look at your exterior elevations. And so here's the outside of the building. So you kind of want to know, okay, is there a finish I need to be aware of? So quickly, I know that the metal panel for this building is excluded as far as what we need to do. So we've excluded that. Brick veneer, new paint. So we would give that a square footage for we have to paint the brick. So everywhere we saw new paint, we measured that and we applied that to the estimate. New lights, that be on the electrical. You don't have to, it's just pointing it out. Canopy, roof, existing, so nothing here. But we did set a cost to paint the gutter systems, all existing and all new. And yeah, so, but everything here was marked. See C's and D's and Y's, but in the areas that there were no marks, we did not apply any kind of finish. We didn't put anything as far, so all of this, there is no cost for painting, for anything other than the doors, so that should be noted. Okay, because there were no marks here, assumed, it may be by mistake, but everything here is excluded. If the mark isn't there, then we just excluded it because it's too confusing to try to figure out, okay, is this the same as this? No, because the texture, see, it's a different type of finish, so that's not the same. And that's the roof, it's not the wall. And so yeah, all that gray has been excluded in terms of, is there any paint, any kind of finish, any cleaning, anything. So it's just better safe than sorry, because that would really increase the cost for not really sure if we're doing anything. Then it can be clarified later. But everything that is marked, there is a cost. These are all the downspouts and all the gutters. And so in terms of finishes, you know, you want to look at the finish schedule, which we did. Look at the finish plan, interior, exterior elevations, do your measurements, and match it up. And then let's see. This is it for this location. Yes. So at the end of the day, these are our totals. All of our subcontractor prices, so that includes material, but we can break it down into individual painting as we've done before in a couple of videos, but this is a subcontractor price. That's why there's no labor. This includes material and labor in that one price per square foot. And then the other items for the finishes, so we added the coffee bar and placing chairs and the refrigerator and a couple of other things, the bathroom grab bars and all of that. And then the end of the day, before overhead profit, not too bad. So if you have any questions, please email me directly at education@sfjohnsonconsulting.com. Tell me what you think. And this is the last video for today, which is the 14th of November. But for today, the remainder of the week, there'll be a ton more to go over each of the takeoffs and the estimates to clarify anything and to give you tips and hopefully help you become an excellent estimator.
Never rush anything. That's what I've learned over these years. But give me your thoughts, and I will see you on the next video. Hey everyone, this is Stacy, of course, with SF Johnson Consulting and Construction Services, and I just wanted to go over something really quickly that is kind of abstract and it's difficult for a lot of people, but it's important that you kind of get it right if you want to get your material takeoff correct. So we're looking at a reflective ceiling plan that shows us all the new ceiling finishes, and this one has quite a few section views. Okay, so when you see anything like this, you're going to assume that it's some kind of soffit, right? Some exterior it's late. Some wall that's extending down from the roof joist or from the ceiling. And so you want to make sure you account for that. And so the first thing you do is basically what I do is that we know that we have two of these. So we have a section view 4/A111, which accounts for this length, right? That length. A section view gives you a section of a wall, right? So this is the sections of the wall extending from the ceiling. So it's understood that this section and this section, well, it's right here. Okay, I would understand that whatever I see for this length is going to be the same here, but they did put the section views. Just the purple made me miss it. Okay, and so basically the section view or the length for 4/A111 is all of this. Okay, which I think we have as, where is it? Somewhere up here. What is that? 408 24.3. Yeah, 24.3 linear feet. But not this. So it's just this, this, and that. That seems a little short. Oh no, that's 14 right there. So 5 and 5, yeah, that's about right. All right, so that 24 feet for that section view, and then so we have the length and then the area that accounts for it. Same thing here, we have a 3/A111. We have the area that's outlined in the green, and then it's also going to have a length, right, which is, that length is, there better be extension. Let's turn off all the bubbles and make sure we have we have that one. Make sure we have the other length accounted for. Okay, good. All right, so that length is the red basically, which is 4/A11, which is 24.3. Okay, so now we have to look at the section views, because it's telling our framer that, okay, this is the area, but then there's some portion that's down that we need to account for. So 3/A111 is right here. And so for the soffit, basically, we have, this is the area that we've already accounted for. But then we also need to account for this length and that length. And usually it's about 6 inches above the ceiling. So that's probably like a foot, right? Foot. And so for this length, if I had to, which I do have to do, determine a square foot, right? Square is length times height. Well, each one of these is a foot. It's about a foot. That's 6 inches. So 3 feet. Because we have to count for that above the ceiling. So that's a 1.5 feet and another 1.5 feet. 1.5 feet and 1.5 feet is 3 feet. And so the additional square feet for this soffit, which is 3 over A111 is 3 feet times whatever our length for that was, which is that. That's how many square feet of additional framing or drywall and framing. I mean, you can think of this in terms of, because we've already accounted for that. So you can think in terms of this is the framing. Now, the framing most probably extends to and I'm doing this takeoff specifically just for the drywall. The framing most likely extends because of this right here tells you that they're only breaking off a portion of that, so we can see for the drywall, and so it probably extends to the roof joist. So you have to be able to determine the length of these, because it's basically, if you had to break it down, right, we have a flat area, which is this for the drywall, and then it's in terms of studs, we have whatever this length times 2 times the length of the whole section is how many square feet of framing, if you want to do it separately, and then the drywall is just this. Okay, same thing for both sections. And the other one, now if we had to do this one, we already did the flat section, but the additional vertical is it's to scale. Okay, so we could figure that out. Okay, but again, this part's going to go, this is it's going to go all the way to most likely the ceiling joist. Okay, so you have to look at a different view to determine what's the height from here to the ceiling joist. Probably 6 feet, but take a look. Depends on a lot of stuff, but there should be a building section view, and we won't go over that right now. Okay, so that is very important when you're looking at the reflective ceiling plan. Just like the floor plan has section views, the ceiling plan has section views too, so you have to be able to go to those to determine your additional material. Right, so any questions, please email us at education@sfjohnsonconsulting.com. Let me know what you think, and make sure to subscribe, and we will see you next time. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I thought I would take a quick break on the estimating, just a small break, to talk about some safety issues related to our concrete and masonry standard, which is 29 CFR 1926 subpart Q, which are the OSHA standards related to any the work that you're doing when you're performing the work, or any concrete or masonry work, and some of the standards. And what we always like to do is, first of all, what are the hazards that are possible when you're performing the scope of work? So I've outlined about 8 of those, and they're really easy to take care of. So one of the hazards are chemical burns. So if you are, and I saw a lot of video yesterday where we're mixing the concrete, or we're even pouring it, or from the dump truck, or whatever, and nobody's wearing gloves, and they're just putting their hands all in the concrete. So proper PE, right, gloves, and then you may pop that in your eye, so eye protection and hand and body protection. So the proper PPE would solve that problem. Most importantly, the damage or injury from the silica dust, so respiratory irritations and illnesses, and that is the biggest one when it relates to concrete and cutting the concrete. And the standards that have changed, I believe in 16 or effective in 18, where you have to use a water feature when you're cutting the concrete. You just can't let the silica dust just go all everywhere because that affects the worker and the community and everybody. So 3 injuries from improper lifting. So our ergonomics standards would apply. Move smarter, not harder. There's an ergonomics class that I think we have on video too for you to look over, and what are the standards and what are the things that you should think about. And ergonomics is the way that we move our body, right? And so depending on what you do, you move your body in certain ways that could injure yourself. So form blowout, that's number 4. What is that? That is concrete's pretty heavy, and if the form work isn't properly placed and secured, the forms blow out, they break, and the concrete goes everywhere. I saw a nice one yesterday, but at that point you're just running around trying to scoop up all the concrete so it doesn't harden wherever it blew out. And so you can have injuries from improper lifting on that. You can have respiratory problems, chemical burns, all of that from the blowout. And then that's kind of stupid and funny at the same time. Injuries from falling objects, of course. If you're doing platforms, slabs above grade, you have to worry about objects falling as well as you falling. So the proper fall protection training, as well as proper struck by identification, knowing when there's a possibility of a struck by or caught in between. And so those are all things that, if you are taking this OSHA concrete masonry class, you've already taken the focus for the struck by, electrical, falls, and caught in between. So you've already taken that, so you'll be familiar with the ways to protect yourself from falls. And then lastly, the vehicle accidents, especially with the when we're dropping the concrete, right, just straight out of the chute, we're backing up the vehicle, we run over somebody, or the mechanism we use to pour the concrete isn't secure and it breaks off and stuff goes everywhere. So there are, of course, OSHA standards related to motor vehicles. And last but not least, goes kind of with when you're cutting the concrete, you want to make sure you have protection for your ears, protection from noise. So I want to just quickly show this. We have a couple videos, but one is the silica dust is the one that's most important. So I'm just going to show it on this video, and I'll mute myself, and then we'll wrap it up.
Crystalline silica is one of Earth's most common minerals. It is found in stone, brick, rock, concrete, block, mortar, asphalt, and sand. Using power tools on these materials for tasks such as cutting or grinding can release tiny particles of silica into the air. These tiny particles are known as respirable crystalline silica. Workers who breathe in respirable crystalline silica can develop diseases that can be life-altering or deadly.
Traditionally, on construction sites, silica with grinding and cutting produces a lot of dust. It gets into the workers' lungs.
Exposure to respirable crystalline silica can cause silicosis, a disease that permanently scars the lungs. It can also cause lung cancer, kidney disease, or chronic obstructive pulmonary disease, also known as COPD. The chances of developing these diseases increase with higher and longer durations of exposure.
What we're looking at on the left is a normal lung. You can see that the lung tissue on either side of the heart is dark and black, and that means it's full of air. And the X-ray on the right, you can see those white scars throughout the lungs on both sides. That's all scar tissue. Is from a patient with advanced silicosis.
Without protection, workers who are exposed to very high levels of respirable crystalline silica during activities such as abrasive blasting with sand can develop silicosis within a period of months to a few years. Workers usually do not develop signs of silicosis until after they have been exposed for 10 years or more. Once silicosis symptoms, such as shortness of breath, appear, the symptoms can get worse over time, even after the worker stops working with silica.
Usually people who develop silicosis have been very healthy, vigorous people, and they find after years of the disease that they're short of breath, that they can't go very far, they can't walk very far, they can't climb the stairs. They may even be short of breath just sitting still. I continue to see new cases of silicosis, and yet there is still no treatment. So I would like to see prevention of silicosis so that this disease is eliminated from our hospitals and our health clinics.
Silica disease can be prevented by controlling exposure to silica dust. Water can be used to wet the dust and prevent it from getting into the air. Vacuums can be used to remove the dust at the point where it is made.
We stir up a lot of dust, so we try to prevent as much of it getting in the air as possible. So we use these vacuums. While we're working on cutting the joints out, we create a lot of dust, which we collect in the vacuums inside these bags. Much rather have it in this bag than I would inside my lungs.
Once I tried the new things, it worked well, because at the end of the day, I went home without silica dust in my lungs. I went home clean at the end of the day, and I got used to it.
Gary Sasse's family business is stone carving. His father and his grandfather both died of silicosis.
I believe that our industry here has worked hard to bring in new technology that does help with the silicosis problem. I also believe that there's also room for more education for the workers themselves to understand the critical reasons why they have to be very careful in this industry.
In today's climate, we stress to our customers safety, financial stability, company stability. We remind our men we want them to go home same shape or better shape than when they showed up at work that morning.
OSHA's rule for respirable crystalline silica requires employers to protect workers from silica dust to prevent them from developing disease. Silica-related diseases can be prevented if proper controls are used to reduce workers' exposure to dust. More information on OSHA's requirements to protect workers exposed to respirable crystalline silica can be found at www.osha.gov/silica. For information.
All right. So, most definitely, that is our biggest issue when you're tuck pointing, you're cutting that. Yeah, you need to have either the vacuum system or the water feature system to keep that from going in your lungs. And whether they're cutting concrete, shaving down the sidewalks, you see that all the time. So definitely that is the biggest hazard when we talk about concrete and working with concrete is that silica dust. And a mask doesn't work unless it is like a scuba type thing where you're taking in all new fresh air. Okay, so if you do this for a living, like I said, it doesn't show up for 10 years, and then you're pretty much counting your days after that. And one other thing I wanted to go over is when you're working on masonry walls, when you brick walls and you're building brick walls or CMU walls, there's a standard that there needs to be a limited access zone around that wall. So if I'm putting up a wall, the access zone has to extend from the wall. The height of the wall plus 4 feet. So if you're building a 8-foot wall, your access zone, you have to extend out or close out that 8 plus 4, 12 feet outward from the wall, where you limit access where people can't walk. Okay, so that's another really important standard when it comes to our concrete masonry, just in terms of avoiding violations, right? We want to avoid violations. And, you can't avoid a violation violation if you're sitting there in a cloud of silica dust and you're cutting the concrete. You're pretty much done. Okay, so you want to be able to avoid violations, limited work zones, proper PPE, all that good stuff. And two, this is just one part of your what would be your OSHA 10, OSHA 30 training. So just wanted to give you a little heads up on, what you would study and, really what's the most important. They have standards for slab lift operations, limited access zones, type of equipment, the standards for the equipment. So again, you can get all of this directly from the OSHA website, even if you are not getting your certification, just so you'll know. Or please do, or you should. Your employer should make sure you're certified if you're doing this for a living, and it's a requirement that you have a training program. So if you have any questions in regards to this or any other issue, please let me know at education@sfjohnsonconsulting.com, and also please let me know what you think and subscribe and all that good stuff. And I will see you at the next safety video. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I'm going to be presenting in this video the basics of the finishes. So we're going to go over various finishes and what plans you need to look at and what you need to consider when that is your trade. So the finishes are everything that goes in and on the building once the building's been constructed, from paint to flooring to even the roof finish. And so it's important, if you are doing if your scope of work is paint or brick or any kind of wall covering or wall finish, that you do have a good set of elevation views. And the elevation view is the view as if you're standing in front of it live, and like we're outside and this is the exterior elevation. So it's as if we're outside this building looking at it. And it's going to give you, of course, a finished schedule of ABC, and this is through Z of the different finishes. And so to make your life real easy, if you are the painter, you're going to look for new paint. And then, okay, that lets me know I have to determine the square footage of everything that's B, C, D, where else? We're going to paint the doors. We can do that separate. Then we have to remove some mold, okay? And so basically, everything is marked. And so use a good digitized software, and then you can get your measurements very accurate, which is important for competitive bidding, right? You have to make sure that all of your numbers are, to be competitive. A good start is to have very accurate takeoff numbers, meaning your measurements. And so you want to always have a good digitized software that you can use to determine areas or linears or segments, portions of lines, or whatever. Okay, and two, sometimes you have sets of plans that aren't clear. Like if you notice here, this gray area, I don't have anything colored in, which means, this tells me either there's a mistake on the plans and I'll let the GC know a while back, or there's nothing that we need to do to this gray area. You see that everything is either noted, or I know, this is a new garage door, so I know that's going to be painted because it's set on the door schedule. But as far as this area, this is noted, right? But that's just the roof. L is just the roof, and there's nothing to be done to the roof, so that's why that's not colored. But it's important when you have a set of plans, if you are the painter and you get something like this, and you either exclude this area or give them a call and say, hey, am I supposed to paint the south elevation any particular color because it's not marked, as opposed to this being marked. Those are marked. Everything is marked except for this gray area. So we assume there's nothing to be done to that because this is an existing building that's really just having an addition added on. So that makes sense that we wouldn't be doing anything to this. But then we're painting the downspouts and all of the gutters. Okay, so make sure you just don't assume when you get a set of plans. Never add more than what you see, and ask questions. Okay, so that's the exterior elevation. So finishes is important to get elevation views, especially like if you're the painter. That's the only way to get a good visual, so you can get good measurements. And then we want to also look at the finish schedule, so we know each of the rooms. In the event we don't have good elevations, at least we know, okay, well, we're going to have carpet, I believe, on the floor, rubber wall base, paint one, everything. All 4 walls in all of the rooms appear to be painted the same color, paint one. And then all of the ceilings appear to be acoustical ceiling tile. That's a finish. Paint's a finish. All of these are finishes. That's why it's called the finish schedule. All right. And so we pretty much know what everything is going to be. A lot of things aren't going to be done. The shop area, there's nothing. Sealed concrete on the floor. No wall base. So you get a good idea. And then they're finished plans. So from the finished plans, right, you get the plan view, which is the view from above. So now you can do all of your wall bases and all of your floors, the different floors. You can get some good measurements. And then the last thing to do is to have your interior elevations for the inside. So now you can get your wall measurements very accurately, and there's no questioning for whether it's tile or paint excuse me, or the trim. All right, and you can had to put it on hold real quick, hopefully it doesn't show. My grandkids gave me a cough over Thanksgiving, and it's just been crazy. Okay, so interior elevations give you a good idea of all of your areas. Can be very accurate. Set your scale and then begin to make your measurements depending on what you got. And then here we know this is glass, so we're not painting the glass, so we didn't include that. Okay, so interior elevations, exterior elevations for all your wall finishes is vital, so you can get good measurements. And two, from your floor plan, actually, let's go to, also reflective ceiling. If you're doing the acoustical ceiling tile, gotta look at that too. Let's take all the bubbles. Okay, so ceiling, am I the ACT person? I have 2x2 acoustical ceiling tile. Just get the area, and then the IT room is gyp. All right, so we have to paint that, so we always have to look at the reflective ceiling. Okay, in order to see what ceiling components we need to measure. And last but not least, we go to the interior elevations. I can never find them in the row. Equipment, elevations, exterior elevations, and then the interior elevations. Again, go to those, get all your interior measurements, and then really you want to go to your door schedule if you have to paint the doors and the frames. Okay, Okay, so finishes, right? I mean, it's just for finishes, paint. So really, any wall paint, wall finishes, elevation views, reflective ceiling plan. Got to come to your door schedule to see if it's stained or painted for the door or nothing. Okay, interior elevations inside. Your finish schedules tell you the finishes on in each of the rooms, on each of the surfaces. Then you go to your plans to do your plan view measurements, wall bases, floor tiles. And then you have to go to your interior to get the walls, right? Because this is an interior elevation marker. So this says that page IN 401, image 14 is going to show you everything on that wall, and that's how we make those are where the interior elevation views come from, using the interior elevation markers. So you know on each wall, depending on where the arrow's pointed, what's going on each one of those walls, and then you could take those measurements. So you know if each room pretty much has a interior elevation marker, your interior elevations are covered, except for see that this room doesn't have one. So we just go to the reflective ceiling plan or the finish plan for the IT room. See if it even has anything on it. Paint, okay. So what we need to determine then, what's the height of the wall in the IT room, because we don't have an interior elevation. So how we do that is we go to the reflective ceiling plan, because the job of the reflective ceiling plan is to tell us the height of the ceiling, which basically is the wall, right? And the finish on the ceiling. Here, this symbol, this format, pretty much this design indicates drywall. Okay, so even though we didn't have an interior elevation marker on that finish plan, you go to the reflective ceiling plan, and that is the height of the ceiling. So if you have to paint it, you figure you're going to paint to the ceiling, and give it a couple inches if you want. Okay, so and then our other finish really is our roof and what we need to look at, and this is our new roof. So what the roof is going to give you the flat area, of course, and if you have a good measuring tool, your scope of your roof can be taken into account, because the steeper the slope, right, the more material is going to be to cover that slope. And then of course you have to look at all of your section views to see where that's going to lead us, or does that show us something in terms of our roof finish. And we know that these are all of our downspouts as part of the roof. So the painter and the roofer needs information about the downspouts, but the roofer doesn't paint the downspouts. Right, so the roofer needs to look at all of these. So 2 over A102. A102, where are we? Oh wait, we're already here. 2. Okay, so for the roofer, they need to say, okay, this is my scope of work. Anything else I need to know? This is a type of roof. And then this 2, this doesn't, that's the existing roof. So that's here at this connection. So that's nothing I need to know about. And then this one, 6 over A302. Let's just look at that because it is off the roof. A302, 6. Yes, we need to know now. This is our roof. We need to look at both of these, because it is a detailed call out that encompasses our roof. So that may tell us we have a scope of work within these call outs. So 13A 501, this is 501, I think, right? No. So 13 and 14, 501. 13, and 14. 13, where is it? See, I already worked on it. So for my roofer, no, nothing more than a roof, because this is the fascia. That's not the roofer. That's not the roofer. That's not the roofer. That's not the roofer. 13, 14. Metal channel. Yes, the roofer. Yeah. Or, well, if it's like flashing, yeah. Or it's structural. I have to see. No, that's structural. I think I did that for the structural. So roofer, no. Okay, so you have to make sure you follow your call outs, whether you know it's for you or not. But if it encompasses your scope of work, you gotta follow it. Alright, so finishes. Now let's look at an actual estimate. So new finishes, this is all the floor. Tile, square feet, cost book, and most crucial is the man-hour unit, cost unit, out of the cost book, because it tells you the accurate amount of man-hours it takes for each line item. Okay, so you have to make sure you get a good material cost, okay? But the things that will probably, either help you win or not is how accurate are you when you say how long it takes you to do your scope of work. Tile work is very time consuming, very expensive too. But, how are you determining how much time it takes? That's all you need to ask yourself. Are you doing it by guesswork? Are you using some kind of standard based on construction? Right? That's the difference between a winning bid and one that's just thrown in the trash, I'm telling you. All right, so paint, how we have it here, and I'm going to come through with a separate painting estimate, but this is a subcontractor price. So this incorporates material and labor per square foot, but I'll come through and do a small video again for a painting estimate that breaks down each of the tile, walls, ceilings, railing, concrete, and then I think I did it before. That's probably already on there. And then how we determine how many 5-gallon or gallon buckets of paint we use, and I think I already have that on there actually. But this is a subcontractor price. And then miscellaneous stuff. This is miscellaneous finishes, the coffee bar, and they had a bunch of extra stuff I just added for them, the bathroom accessories. Okay, so that's what it looks like if you want to be a winner. And then, you can play with your labor rate based on your city and state, and all that good stuff. But if you have any questions related to this, the basics of finishes, we kind of threw all the finishes there all together. Email me at education@sfjohnsonconsulting.com. Let me know what you think, and I will see you at the next video. And if you haven't subscribed, why not? Come on, please do. Tell your friends, and I will talk to you very, very soon. Couple of definitions here, and what is electrocution? And it is the result when a person is exposed to a lethal amount of electrical energy. And so as far as OSHA is concerned, we've broken those down into a number of different hazards, and just want to go over each and just some basic stuff. Remember, if you are a subscriber, we are going to have our OSHA certification for our subscribers beginning in January, meeting an hour plus a little every Saturday in the afternoon. And if you attend,
I got to make sure you attend, you are there, you sign on, all that good stuff. And then this will be part of your training too. This is part of the focus or fatal for falls, struck bys, electrocution, caught in between. And those are, the things that we study. So burns, electrocution, shocks, arc, flash, blast, fires, and explosions. And one of the terms that they use for electrical is to be safe. And each of the letters in be safe stands for something. And so the burns are the most common shock-related injuries, okay, from electricity, one of the three types. So there are three types of burns: electrical, arc flash, and thermal contact. Electrocution is the E. It can be fatal. It means it can kill you. Electrocution results when a human is exposed to a lethal amount of electricity, which you can be if you're messing around up high and you're not within a approved distance from power lines. I mean, you could kill yourself. So many people have. Shocks result when the body becomes a part of the electrical circuit, and we've all done that once or twice in our life. Being dumb and listening to my brother, right? You do stupid stuff. Arc flash blast. And arc flash is a sudden release of electrical energy through the air. Okay, when a high voltage gap exists, you don't want to be there. Okay, fire. Okay, we, electricians set stuff on fire when they don't use the proper wiring or breakers or whatever. So these are all things. And then, of course, explosions. And then, there's some statistics. Okay, 9% of 1,200 pretty much deaths based on these things that we've spoken about. Okay, and so the type of hazards that you just want to be, if you're in this field, okay, power lines, that's the biggest thing. Okay, and so OSHA states that you have to be anywhere from 15 to 25 feet, 10 to 25 feet away, depending on the voltage of that power line, okay? And so if you're working in those kinds of conditions, right, you have to have a specialized hat, helmet, gloves, everything when you're dealing with those kinds of situations. But yeah, that is the biggest and the most profound hazard when we come in contact with power lines as the electrician. Okay, and now second, energized sources. So that's why it's so important to understand the lockout, tag out procedures, and when it is okay to approach a piece of equipment and make sure things are de-energized before you work on them. Okay, and proper use of extension cords on the job site. These are the three most considered hazards for the electrician. But again, please subscribe so you can be a part of our full OSHA training. Okay, our full training. And these are just some basic things. If you're in the field, hey, these are some things you need to be watching out for. Distances you need to make sure you are mindful of. And let's just watch this cute little OSHA video.
Job with over 700 fatalities just in the year 2000. In the U.S., hundreds of construction workers die every year while on the job, with over 700 fatalities just in the year 2011. The third leading cause of these deaths is electrocution. Electrocutions cause 1 of every 10 construction worker deaths, with nearly 70 deaths in 2011. But these deaths can be prevented. The video you're about to see shows how quickly contact with overhead power lines can result result in the electrocution of a worker. The video will also show what employers must do to ensure that the work can be done more safely. Employers have a responsibility to provide a safe workplace and protect workers against possible hazards. You'll see that training workers, pre-job planning, and taking the right precautions save lives. Please be advised, the scenes you're about to see deal with deaths at construction sites and may be disturbing to some people. All scenes are based on actual events. Two construction workers were replacing a section of pipe in a trench next to a road. They were using a crane to unload the pipe from a truck and place it on the ground close to the trench. While one worker operated the crane, another worker was on the ground to help direct the pipe toward the ground near the trench. The worker directing the pipe had one hand on the tag line, which was attached to the rigging used to lift the load. As the crane operator began to move the pipe, the crane's boom contacted an overhead power line. The electrical current traveled through the boom, down the load line, along the tag line, and reached the worker. He died instantly. Let's look at the events leading up to this tragic incident and see how it could have been prevented. The worksite did not have many of the required controls in place to protect workers from overhead power line hazards. For instance, before the work started, the employer had not set up the required clearance distance to keep the crane a safe distance from the overhead power line. Let's take a look at the same work area, this time with proper precautions in place. All workers are trained. This includes the crane operator being certified and the rigger and spotter fully qualified. Because the line is live or energized, the employer has taken steps to keep a safe distance from the power line. The foreman obtained the voltage of the overhead power line from the utility company. Based on the voltage, he determined the minimum required distance of the crane from the power line. A pre-job safety planning meeting was held. Flags are set up to show the boundary that must not be crossed. A non-conductive tag line is used to control the movement of the pipes. The truck is no longer directly below the power line. And a spotter is on site with a two-way radio to communicate with the operator. Higher voltage lines will require greater minimum safe distances and additional precautions than those shown here. Now, as the pipe is moved, the boom remains a safe distance from the power lines, and the worker safely guides the pipe towards the ground near the trench. This video shows one of several options employers can use to keep workers safe when operating cranes near power lines. Not all work sites are the same, and the precautions could be different than those shown here. Construction deaths from electrocutions are preventable. The precautions shown here save workers' lives. Follow safe crane operation requirements on the job. It could be the difference between life and death. If you'd like more information, contact OSHA at www.osha.gov or 1-800-321.
Make sure you sign up, make sure you subscribe, sign up with us so you can attend our certified training. OSHA 10 is what we're offering for all of our subscribers. It is a live class. You do have to be live with us when we perform the class. It'll be on Saturdays in the afternoon. I think it's 2 to 1 or 12 or something. I forget. Pacific time. And, sign up. If you do this work, not only if you're an electrician, right, from this video, you can just get caught up and get electrocuted. So we don't want that to happen. Knowledge is power, and we hope that you will join us. And remember, Sunday on the 4th of December, tomorrow, we will have live music all day, music for contractors all day. So while you're cleaning your truck, cleaning your tools, getting all your vest all clean, cleaning your fingernails, you can be listening to some kickback. So have a good rest of the evening. I will see you on Sunday. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I hope you had a wonderful Thanksgiving. It is Sunday the 27th, and it's basically Christmas, right? But yeah, so today we're going to talk about framing and the basics of framing. And we are also, I don't know if you've had an opportunity to listen to previous video where I will be offering you our certification for all of our subscribers. We have the Basics of Plan Reading certification, which is actually 10 videos you have to watch, plus one, plus all of the views videos in order to take the test, which we'll send you, are actually quizzes, which we'll send you, and then the final. And if you pass, we will mail you or email you our certification saying you qualify now, based on you being able to pass the test. And my tests are not easy, and so what we're going to be offering now and look forward in the lineup is the basics of what we're doing now, where, say for instance, you want the basics of structural estimating. There are certain portions that are in a structural set, and so we will be going over all of those points in detail with an accompanying quiz. And you take the quiz, you pass. There'll be about 4 or so per subject matter, but you do have to be a subscriber, and you do have to sign up at our website, sfjohnsonconsulting.com. But those are coming, and just look for those soon. So now we're just going to do a quick overview of the basics of framing, and we're talking about the architectural set framing, not structural framing. And what we're looking at here is an existing facility that had a renovation to some, existing stuff. So when we have the existing building, but we're also going to build some new partitions within it, which is what this is. We pan in and we see the call out. So basically this is the existing. And when we have existing, you need to take good attention to the demolition plan, if there is one, because in the demo plan, it'll tell you to do da-da-da and then prep for new paint. If it says that in the demo plan, then you can exclude it and then add it in the architectural set framing plan, because basically you'll have to prep walls and finish the drywall. Okay, so it really depends on how you want to break it down. With this one that we did, we put the prep of all new walls, because it was prep new walls, prep floors, prep for everything we demoed. So we put that all in the demo estimate. So it's really up to you how you want to do it. Okay, so what we have outlined here is all the existing walls, and then we have another existing walls and existing, and see they kind of show you what's existing, which is in gray. So these are all walls that are there. We knocked out a few, and then they're building. I don't know if this was existing, but if it is, it's gray, so we're just going to add it too, because these are walls that we need to prep if they're existing. And then all this would be new, but not the exterior wall, right? This exterior wall. So basically, they just build new partitions where we'll go to A over A 401 to look at all the new walls. And so when we talk about framing, we need to know what kind of new walls we're framing, right? They'll give us, they'll name them, they'll tell us P5, P4, P4A, P3, P3A, P2, P2A, all the way down. So we see the A portion is a 6, and we're all doing metal, right? Because if they were wood, it'd be 2 by 2 times 4, 2 times 6. Excuse me, that's my Thanksgiving cold my grandkids gave me. And so let's see, here's all our new walls. Okay, so you just need to keep in mind the height. Okay, so when you're doing your framing, you need to look at a section view to try to determine the height of your walls. You use your plan
we use this to determine the length, but we don't know the height of the wall. And so we have to be able to look at a section view somewhere to tell us the height of the wall, because we need that when we're talking about framing. But a lot of the typical height of a wall, excuse me, would be 10 feet. But where else you get the height of the wall is the reflective ceiling plan. It should. Yeah. It gives you, it doesn't give you the height of the wall, it gives you the height of the ceiling. Okay, so let me take that off. So, in your reflective ceiling plan, which is something also the framer needs to look at, because you may have some soffits or some, let's take all that off. You may have some soffits or some ceiling drywall you need to install. Okay, and so this is what this is. Okay, so I'm jumping ahead. So the floor plan is going to give it the existing walls. You can go through openings or don't go through openings and go through your door and window schedule and determine this area so you can deduct it from your framing. Or just go through all of them, all of the openings, which we didn't do here, and consider it waste. It's really up to you. Okay, so here we got all of our existing walls. Then we had a few new P4, P2A, P5. Okay, so that's P5 and it's 10 foot high, so that was easy. And P4 on this. P4. Did it light up? Oh, over here. P4 on our equipment platform. P2A. Okay, so we had a few new walls on this, but our main one is our main walls are at the call out. Okay, so we'll go to the call out, and here are all of our P1, and we go through all the openings. Unless they're larger or wider than 16 feet, we just go through them. P1, P1A, P1. There's lots of P1s. Okay, so that was that call out from the floor plan. Right? Okay, so now we've added existing and then the call out from the floor plan. Not a lot of new walls. Okay. Framing, architectural set framing. In the enlarged office. Okay, now be mindful too that the framer also has to look at the reflective ceiling plan. Oh, let's take a look at the section views too, because you want to kind of determine the height of your walls. So it's like, if I didn't know. Okay, I know I have at least a 10-foot height on the basic wall. And this is at our exterior. Okay. So let's go back to framer needs to make sure they go to the reflective ceiling plan and see if we have any ceiling framing that needs or ceiling drywall, which is the case. And these two have section views, right? Because these are soffits, which are walls that come down from the ceiling. So what do we need? We need to know how far down and how they're built, right? So we have 4 over A1111 to give us that section view. And I believe that's here. And here we go, 3 and 4. Okay, so we have the flat area that we see on the plan.
And then we know that we have an additional little wall segment extending up 6 inches above the ceiling for that. And then this other one is, here's our flat area shown on the plan, and then we have basically two, and it's like, well, where does that continue up to? We're going to assume it's going to go to the roof joist or braced, to the roof joist. So, we have to see, okay, roof joist is where? This about 10 feet. So roof joist probably 16 feet. So this is probably going to be 6 feet high. Okay, so that's why you need those section views. Okay, in order to determine. Okay, so that's our second component that the on the framer's agenda. And then the framer needs to look at all of the door frames. Okay, so typically the framer is going to install all of the hollow metal. Here are the frames. We have some existing, and we have some hollow metal. Typical size on commercial is 3x7, but 6x7, then that's a double door. And storefronts are usually, you'll see manufacturer, whatever, storefronts, or in our case, it's overhead doors that are, and they come with their own frames and all that stuff, so you don't really have to be concerned, but you may want to either exclude it or give them a cost to install it, one of the two. The frame, but the installer of the overhead door manufacturer most likely does all of that. Okay, so the framing, A-plan framing, the floor plans, all the new walls, ceiling, reflective ceiling plan, all of the new ceiling and soffits, all of the new door frames. We don't really worry about window frames because those usually come with the windows. But as the framer, we're going to make sure the opening is there. That's the rough carpentry kind of thing, not so much us that we worry about in terms of framing. Okay, and that's pretty much it. Okay, for the framer. So now we're going to look at the estimate. And no, let's go back and look at the partitions. I'm going too far. Here we go. All right, so all the new walls, insulation on some, drywall just on one side, top track, short wall, whatever. Drywall on one side, and then some acoustical sealant, top and bottom on one side. Same thing here. Drywall on one side, no acoustical sealant, but at the bottom. And here we have drywall on both sides, bat insulation, and acoustical sealant, top and bottom. And so what do we do as far as totals? The framing is the length times the height. The insulation is length times the height. Drywall in this case is 2 times the length times the height, right? Because we have drywall on both sides. And the ceiling is 4 times the length of whatever this length of this wall. Okay, so those are just things you have to, some walls are attached to the bottom of the roof deck, some are not, and then braced. Okay, so the main concern is what's the height of the roof. Because you know these walls will probably go up 10 feet, 12 feet. So you need a good section view. What's my height? So I'll know what the height of the bracing is, 6 feet, 8 feet. Okay, and so then we get to our estimate, and all of those partitions, we break it down. The framing, the bracing, the drywall on one side or on two sides, one on each side, so we say that times 2, and then the level 5 finish, and the sealant, and every different type of wall. And I give them a section view if it applies or whatever. Okay. Dun, 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 dun. Very complicated, but you know, as an estimator, you're supposed to look at your picture, and everything in your picture should be boom, boom, boom. Now, this from your measurements, cost book, whatever your base rate for a framer, right? And our totals cost book based on what I'm doing. Okay, and all the way down. Okay, so any questions on this framing? And remember, sign up for that so you can get your certification through me. And you already know you're going to be the best at everything you do. You don't name a company after yourself and end up lousy. Okay, don't ever do that. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please sign up. Please give me your thoughts. Please like. Please tell your friends. And I will see you at the next video. Thanks a lot. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services. And today I just want to give some detail on an HVAC project and how we should be doing the very detailed takeoff in order to, and I see a mistake right there, in order to make sure you have everything included in it. And so let's start from the beginning. And so with HVAC, we have either rectangular ductwork or we have spiral ductwork, which is represented like this. So the first thing we're always going to do is just write out, measure the lengths of each of the different kind. And so in this project, we had an 8-inch, we had 6-inch, and a 4-inch. And so we just made those measurements based on that. And then I always start in one area and just work my way all the way around until I get to the end. And then it's easy to tell if you've missed something. So the next step would be, after I do the spiral lengths, I'll do the rectangular lengths, or whichever one you want to do first. But just to knock that out. And so, of course, you're going to have a lot more of the rectangular ductwork. So you just have to name it what it is and follow the lengths and measure however long it is. Okay, so that is step 2. Step 3 or 4, however you want to do it from this part, this end, but then I'll go with all of the 45s and the 90s. So this is a 20 by 10 90 with veins, they call that. And so we counted all of that. So whatever had a 90, so this is a 14 by 14 90. And this is a 10 by 12 90, and all of the others. Okay, so that would be another step. Then we'll go to, I don't know what I did in order, but just don't miss it. So do the 90s. Now things like this, we look at the notes, and it is the supply and return grills, diagonal, supply grill, X. They go up to the rooftop unit. And so for this, I'll always have a 90 because it's going to have to turn up or down or whatever. So I'll just assume we have a 90 plus 6 to 10 feet of whatever size ductwork that is. And so for this, it's kind of like, okay, is it the 14 by 14 or 14 by 10? But I think we used the 14 by 10. I don't know. I'm not sure. But the rooftop unit itself is going to tell you the size of the ductwork. So if you don't have it here on the plans, you should be able to look at the mechanical equipment schedule or something on a takeoff or a section view or something like that. And it should be able to tell us the size of the supply and return. It should be somewhere probably on a section view, and if not, then you put what you need to put, tell the contractor what size you chose, and go from there. And so it's the same thing as here. Okay, so we're going to go with, and you see how it's a 14 by 14, 14 by 12 here, so make sure you don't make a mistake. Now, all the other little things that you should take into account when you're doing an HVAC estimate, like these things. Okay, so this is, and now we look at this and we see that there is a portion of some ductwork, plus this is a representation of the spiral flexible ductwork. So you don't have to worry about a 90 for that because it's flexible, so it automatically turns and you can attach it to your supply grill. But these are the branch components we need to account for in the material quantities, where this would be something like a cost book would say a 14 by 14 with a whatever size branch. And that's what this would be, and we'd have an additional cost for that, just like we have an additional cost for the 90. So it's the lengths, the 90s, these little things, and transitions, where we go from one size ductwork to another, where we have something like that. Let's see. Right here, and it's dotted. So here we went from a 14 by 14 to a 10 by 12. So we want to account for material cost for that reducer and whatever your cost book calls it. And we got to fix that. We're missing one right there. But I wanted to make sure I gave you a video of this in detail, not only for the client, but for you to know this is how detailed you need to do an HVAC takeoff for material quantities. Now we're not finished. So we have the spiral ductwork, and the spiral ductwork comes in the size of, it comes in different sizes. So 6, 8, 10, 12, 14, 16. So you have to account for, is it an 8? Is it an 8? Is it a 4? Is it a 10? Is it a 16? So make sure you note for the size of the flexible ductwork. And here, like something like this, it wasn't noted. It's a mistake on the plans. And so we just assume it's just like this one, that it's an 8-inch. And we'll give it 3 feet per dot, because specs, you can't use more than 3 feet. So we're going to give it a 3 feet length. That's why we only counted it. We only made dots because each dot is going to be times 3 feet that size. And what else? So for the take, and then the grills, of course. And so they had different, and this one, and you'll find it's true in a lot of them where they'll be the same size grill, but the neck size is different, and that's how you price it, really, is on the size of the neck. So this neck size could be 8, 6, 4, like this one. Like this one has a neck size of 8, I'm assuming, right, because it's going to be the size of the ductwork. So we made it that size. That's an 8-inch. And like these right here, this would be a 6-inch, CD1 6-inch, CD1 8-inch. So that refers to the neck size or the size that the ductwork is going to connect to. And as far as the detail takeoff, I think that's it. So again, to recap all of your lengths, and you see that you have 2 different types of ductwork, spiral and rectangular. So all the lengths, all the 90s, all the branches, all of the spiral ductwork, all the transitions. Where is that? Where is it at? All the transitions and all the grills. And then we have a couple things that's not completely finished. What is that? A 4-inch flex. That's a 4-inch flex. And then we have to fix one more. That right there. Okay, and so if you look over here, it's everything that we counted, added, all the links, and now we'll take this and get the cost book for our cost per linear foot or cost each, and add the equipment, right? You never have to worry about counting equipment because you're always going to have the equipment schedule, and it will tell you if it doesn't say existing, it's a new unit. And then the grills and the sizes. So, and then that's all they give you here, right? Is 24 by 24, 12 by 12. But when you look in the cost book, it's going to ask you that size based on a neck size. That's why, you don't want to do your work twice. Just note that when you do the takeoff. If it's the same grill and you see it's connected to different neck size ductwork, then yeah, definitely break it down even more detail. Okay, so if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, give me your comments and make sure to subscribe and even join a class if you'd like. And I will talk to you next time. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and in this video we're going to discuss the basics of plumbing estimating and what we need to consider and what we need to look at if we're going to be an estimator that handles specifically plumbing, and what comes first, second, and third. Okay, so this is the cover sheet for the plumbing set, and it's going to give us all of our plumbing fixtures, everything that we're going to be installing, and it will give us the size of the hot water, cold water, and the sanitary pipe sizes and the vent size. And so that's important when it comes to your rough ends. And so we know that if we're going to install plumbing equipment for the very first time, we need to add to our estimate what's called the rough end cost. And that is the additional cost to install the hot water, cold water, and sanitary systems to that piece of plumbing equipment for the very first time. So you always have to consider that, in addition to your plumbing fixtures themselves. And so if you have a good cost book, it's going to give you the cost per type of fixture, and of course the man-hour units that it's going to take you to install that. So please never forget that. And it's specific to only new construction. If you have a renovation, it doesn't apply. So if you're going to just take one water closet out and install it with another in a renovation, that would not apply. So roughing costs only apply to new construction. And so here are your fixtures, and then all your typical symbols. We're going to replace a water heater, so this is a good idea of all the things that you're going to have to find the prices for. And as we know, just like for the electrical set, there are two plans. There's one for the sanitary system, a sanitary and vent system, and then there's another one for the water, gas, and whatever other systems that are appropriate to this type of building, and this what these people are doing inside the building. Because this is our set of auto repair shops. There is for the plumbing set, we'll have a compressed air and a gas line as well. Okay, so this is the sanitary system. Of course, we have to have a good tool that was going to measure linear feet, because our piping is in linear feet. And so if you have a good cost book too, you don't have to really consider angles and reinforcements, because all of that is considered in the price. If you do the assembly price for plumbing for that type and size, it's going to include all of the supports, any angles that it assumes you need, supports you need, because based on industry standards, it has to be supported at certain lengths or whatever. And so if you have a good cost book, that'll help you eliminate having to do this and the small little things, especially if you bid a lot. right? And so always, 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 when we bid a lot, we're going to use a cost book. We're going to use a very good digitized software to make our measurements. But if we win, right? If we win, then we go back and we do a very good detailed overview of what we've done to make sure that price is appropriate. If it's more than 30 days, you have to look at the material cost again to make sure it's the same and that kind of stuff. So, okay, so the plumbing plan, we take all of our linear measurements, and don't worry about the fixtures because we're going to use this riser diagram to count all of our fixtures. Okay, so we use all the plans to measure our linears. So that's sanitary and vent, and then the other plan is for all of the cold water, hot water, piping. Okay, running to the same fixtures, of course. And so we just have to have a good tool to measure linear. And then this one has gas line. And so, same thing, just linears and compressed air. Now, when you have something like this is a 1/2 inch compressed air line. And for this one, they wanted us to use black steel. So, and then a control, but this indicates we don't know where the end of the line's going to be. And so in that case, you have to give them something. And so what I did is just give them to the end of the building. It's got to be somewhere within the building. At least you give a good allowance, and then you let them know that as well. Okay. And so now the riser diagrams. You use the riser diagrams to determine the vertical measure of pipe because pipes go up and down, right? And your plan only shows you the horizontal measures of the pipe. That at certain location the pipes are going up and down. And so that's what the riser diagram helps you determine the size and going up. So rule of thumb I always use is typically 10 feet per going up. So 10 feet, 10 feet, 10 feet, 10, you know what I'm saying? So, that's how you determine it. That's why I put a dot on each one. So 2-inch vent, and every time I see that, okay, so I know I've added 20 of them. Well, I know that's 200 feet of 2-inch vent vertically. And if you have a good cost book, it will give you a different cost for a horizontal assembly price as opposed to a vertical assembly price. So you want to look out for that too. But the other thing is you can use the riser diagrams to count all of your plumbing equipment and be very accurate as opposed to, I always like using it from the riser diagram. And remember, you're going to have different risers. So you have a gas riser, you have a sanitary riser. It's typically going to be the same things that you're counting, so you don't have to count it twice, but look in the water plan, like if there's a water heater, that's not really sanitary, so it wouldn't be on the sanitary riser, it would be more on the water riser. So things like that you need to look out for. Or if it's an oil interceptor, which is a sanitary system type thing, it would only be on the sanitary riser and not on the water riser. So those are kind of little things you need to look out for. But other than that, you could just use one of the risers to do all of your equipment, your plumbing equipment counts, and all of your vent to roofs. Okay, so shoot. And then there's a gas riser. And see, all of these measures are on your plan. The horizontal measures are all on the plan, so you don't have to measure that. Riser diagrams are just to show you where the vertical measure up and down is. So when you put your estimate together, this is basically what we do, and of course we love detail. So all of the horizontal work, and it says PVC, but it's not. I mean, sanitary is PVC. The water is copper. Okay, so that's all the horizontal measures of pipe and how many linear feet. And then this is the vertical measure of pipe and how many linear feet. And then, of course, all of the fixtures, right? The cost and then the rough ends that apply. And then, of course, we're always going to add a cost to connect the existing waste, vent, water to the new service. And then the vent to roofs, and then all that little stuff. And you want to check your specifications because you most likely have to have insulation for the pipe. Okay? And testing the system, especially with plumbing. Okay, so you want to break it down in very good detail. Okay, if you'd like to take a class with us, let us know. We'd love to show you how to do. And basically what we do is start with very simple projects and then work our way up to hotels. So you know what to do in each event and how to determine, again, just each of the measures, how to determine up and down the walls and the rough end costs. Those are things that are important that you have to make sure you include. That's not necessarily on the plans, right? So you know you have to include that, and then testing and flushing the system. So if you have any questions, please let me know at education@sfjohnsonconsulting.com. Let me know what you think of the video, and please keep your eye out for the next one. Talk to you soon. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services, and today we are going to discuss the basics of electrical estimating and what we need to kind of our methodology when we are putting together our electrical estimate, how to break it down, how to make it easy for you, because electrical has to be the most time consuming and can be the most difficult trade to do an estimate for. You have to make sure you pay good attention to detail. All the symbols look alike, but they are not and tend not to be. You'll find a lot of mistakes. And so the biggest thing about producing the electrical estimate is that you have to have a good counting tool. So you have to have a tool that will assist you in counting and help you in not making mistakes. Okay, and so when we think about the basics of our electrical estimate, we know that the electrical set, if it does not have a site plan, right, will have two plans. It'll have the power plan and it'll have the lighting plan. The power plan is everything in the building that needs power, and it tends to be the most difficult of the two plans. And the lighting plan is the plan where all the lights are and how they're controlled. And then the third thing that makes completing an electrical estimate really difficult is determining your wire and conduit totals for branch circuitry for your power plan. If it's not already noted on the plan, sometimes they'll note it on the construction docs, so you just follow the lines where they lead you, but in a lot of cases they're not shown, especially for the lighting plan. And so you have to make sure you kind of understand, you do understand the symbols on the lighting plan, and that can somewhat assist you in determining a route to draw your lines for your wire and your conduit. For your single line diagram, it's pretty simple because the panels are where they are on the plan, and they go to a particular other panel, and that is where it is. And so it's easy to be accurate with those totals. But again, when you're doing the wire and conduit totals, you're not going to get the exact same number as the electrician, or 10 electricians that are doing the same things not going to get the same number. But what you want to do is make a good effort to represent the branch circuitry and the lighting based on the plans in the best way you can. And in the neatest way you can, because if you're an electrician, you're not just going to throw the wire all over the ceiling. You're probably going to run it, everything that's going to one panel, you'll probably be running that all together somehow, and gathering it all together on one side of the building. And if another panel is in the middle of the building, then you're going to run and route everything towards that way. So that kind of helps too. Okay. And so you need a good counting tool, and you need a good segment tool to measure lines and lengths. Okay, and so we'll look at an actual estimate to show you what you want to think about when you are doing your getting your estimate together. Now, this is the way I represent it, and I've completed electrical estimates, only God knows how many, and electricians like the format because it's very clear. It tells them everything they need to know, and if they know their trade, which they do, they can determine if the numbers that you're giving them is kind of crazy or not, or overboard. Okay, and so you got to think, okay, number 12 wire, you're going to have always a lot more of that. Because why? Because most of the power components run with 3 number 12s. And so you'll run one length for the conduit, but you got to times that by 3 if we're talking about the home runs. Okay, and so, yeah, so the way we break it down, we have a section for our wire and our conduit. So all of the wire, for even including for the single line, and then MC cable. Most of the branch circuitry can be run with MC cable, where all of the home runs, of course, have to be number 12. Or if it's a particular type of mechanical equipment, it's going to tell you you need 3 number 10s and a number 6, or vice versa, or whatever. And you'll know from that. Okay, and so we break that down, all the wire, all of the conduit totals by length, and of course we use a cost book to give us the material cost for the wire and the conduit. Now, rest assured that if you use a cost book that's very accurate like we do, we use Craftsman, well, our material cost for the wire and the conduit is going to be 5% within local pricing. So not 5% within what your supplier is going to charge you. Okay, so that's a thing to think about too. So if you want to make sure you put the cost of what your supplier is going to charge you, you're always going to tweak these numbers, because the supplier's not going to give you his cost, right? They're probably going to mark it up 2 or 3 times the cost per linear foot. And so you have to keep that in mind. Just go by your material suppliers as far as the material cost. But again, if you have a good cost book, you're always going to use the man-hour totals from the cost book, because that will make you way more competitive and in line with industry standard, because these numbers come from the industry standard, meaning it equates to, if you go to the mechanic, right, you need an alternator. I'm old. I don't think you need alternators unless you got a bucket, which is okay because buckets are nice. The book will tell you how long it's going to take the mechanic, right? Well, same thing for the construction industry. Construction industry knows how long it's going to take to do absolutely everything. And so that's per unit. So it takes 0.017 of a man hour to install 1 linear foot. So it does the math, and it's 15.73 linear foot. You want to always do something like this. You want to always get it from a cost book. You're always going to win, especially if you bid a lot. And I'm always going to lose clients because I'm always telling them my secrets. But that's okay, because when you never lose, right? So use a cost book, because you want to be accurate. You don't want to go by, I've been doing this for 30 years. It's going to cost this much, because you could be shorting yourself. And you could be overcharging the client, and you won't win. And so by using a cost book, you're in line with industry standard. You can, test the waters, send out, if you've been to 3 GCs, send them all the lowest, or send each one, tweak it a little, every estimate, whatever, but always try to go by industry standard, okay? You'll always be guaranteed to be really close in the competitive portion. And then your material costs, you just got to make sure don't go with one supplier, right? There's suppliers all over the country. You can send your stuff to 8 of them, right? And just go with the lowest. Most of them are free shipping, all that stuff. So that's something to always think about as a electrician, and the estimator is supposed to give good tips too. So, All right, so counts. You got to make sure you have everything, all your wiring devices, everything from our power plan basically is on here. All your junction boxes for your TV outlets, for your phone outlets, don't forget those. Plus, it's always going to say 3/4 inch conduit to the ceiling. So make sure you know how high the ceiling is. It could be 10 feet, it could be 16 feet, it could be 12 feet, whatever. So you want to make sure you have all that. And then all of everything basically in the switchgear portion for me is everything in the single line diagram and all of the disconnects that and all of the breakers. Okay, and so you get these numbers by counting the breaker panel, and I've got this many of that, good counting tool. And then cost book will give you a pretty good for all of your disconnects and all of your breakers and stuff. You can go by the cost book. They give you a pretty good, it's up to a point. You see where I have zeros. So up to a point, sometimes your material, you want to go with your, and I mean for the electrician, you always want to go with your supplier, especially nowadays and since COVID and stuff. And so I leave all these zeros, but I do the man-hour totals, and all that comes from a cost book. And again, the cost book is what the industry says. You can do it in less time. And most people say, oh, it's giving me 15 hours. I can do it in. Okay, well, that's great. But adjust it, right? Put 7 hours. Then you'll be even more competitive. But this is what the cost book says. So I'm not trying to cheat you from the cost book. You can cheat yourself after you know what it should be. All right? So, and then all of our lights, right? Counting tool. Really good counting tool. And again, you're going to get your lighting package depending on the type of, if it's like an Applebee's or Cheesecake Factory, they have a supplier. You call them, they'll give you the material cost for all the lighting package, and you just fill in the blank afterwards. But of course, we give everything an hour for the lighting. And you can be even more detailed than that, because most things don't take an hour. Unless it's a track light, then we give 0.25 of an hour for that. And then bottom line, we have the permits. You got to add that. Trenching, if it applies to your site, if you have a site lighting, because some of my electricians have to be responsible for the trenching of the underground, power, whatever. So you want to have that. Switchgear package costs, fire package. Some high voltage electricians do that too. And then the lighting package, fill all in the blanks. And this is our number minus overhead and profit, and fill that in. But you go to our set. So this one happens to have a site plan. And so, straightforward, this is probably doing too much. They may go zoop, zoop, well, from here to that, who knows? But I don't know. But I do the most, I'm not saying that, I don't think that's conservative. But, this may be, in the real scheme of things, if they have to trench that, they may not trench it again to go there. They may just go back here and then go like that. Who knows? But for the purpose of our estimate, every estimator has to figure out that same thing. So we're going to give it the most leeway. Okay? In terms of, so we know this is underground. We know that's PVC because it's site, right? So we don't have to think twice about that. And we know that it's 3 number 10s and a 3/4 inch PVC. Home run 2, position number 3 in panel C. So the panels where I took it from here, and then once I get into the building, I add whatever additional wherever the panel is in the building. And you got to account for it coming up, right? PVC, 2 EMT, or rigid, or whatever. So just add like 10%. Nothing that's mind-boggling. Especially for initial estimate, because you want to bid as much as you can now. But once you win what they consider you, you want to go back with a fine-tooth comb and say, okay, is everything covered? Now, I made everything not covered, so this is our power plan, and these are all of our quads and all of our everything. Duplex, right? Phone and data. So I know that's a duplex junction box as opposed to a simplex or a single one. Let's see. Fill in everything. This had a lot of bubbles. Okay, so good counting tools is critical. Now, when it comes to your branch circuit, right, you got to look at where everything is connected. These are both going to position 27, panel E, so I can say these are connected here, and they're probably home run to that position, right, because they're quads, so yeah. Okay, same thing here. I can run it here, branch circuit, and then I'm going to run an imaginary home run to wherever E is as far as running the wire. Okay, let me see where I have my power wire. Do I have it? I might have done it on a different page. Okay, no, there it is. See? So things I know that are going together to the same position on the panel. Okay, I'm going to run those all together, and then I'm going to home run that from that end somewhere to wherever the, here's relocated C, and where's E? So normally they'll put everything like close. Yeah, here's E. Panel A, E, and B, and C, and then the disconnects. Okay, so all we can do is make the lines from where the plans say the stuff is. Okay, and we're giving it a good representation. We got some underground, so that's going to be PVC, and then we have to transition it up through the new partition. This is a floor box. It shows it on the table, but chances are it's in the floor where the contacts are anyway. Okay, and so you have to do all of that. Okay, and all your lights. And the same thing with the lights. You know that they're going to E6, every other one. E6, all of these are going to E6, so you want to maybe put a little more diagonal, add 10 or 20%, because you got to, you want to give a good representation if it's not already given, because we know these two are going to the same place and then going to that, and they're all going to be connected, so you want to do your best to give it a good representation of how the electrician may run the wire. And then I think we added like 10 or 15, 25%. Okay, and that the electrician, will be able to determine if that's a good number, and then we give them the takeoff. It's like, hey, should we be doubling this? Because the person that does the work doesn't know exactly how you should do it. Okay, CT cabinet. Now we had to determine for our power how far, because the main distribution panel. And let's go to. We had a good counting tool, okay? Good counting tool, because you have to count all your breakers. And where's the single line? I think it was maybe in the beginning. So yeah, you got to look at the single line and say, okay, where is the single line? Single line, where are you? Okay, well, we're just going to keep it moving. I don't know. Where is it? Did I check there already? Of course, no, I did not. Okay, so mechanical equipment, you want to make sure you know any of the home runs, basically, that are not all just number 12, and you want to pull that out, make sure you know where that is and run it to the proper, So you'll have all of the wire configurations, number 8s, number 10s. So everything's not always 3 number 12s, depending on the piece of equipment. So that's why they give you that. You got to make sure you pull that out. Go back to the power plan, figure out where that piece of equipment is, and do your linear measure to the panel that it should be, and then say, okay, it's 3 times that distance, and then 1 times that distance for the number 10, and then a 1-inch conduit. Okay, so then for the single line, right, for all of the feeders, you have to physically go to the power plant. We saw that the main distribution panel was on the outside of the building. In relation to panel A, you got to find it. So we look here and we say the main distribution panel is connected to A, to B, to C, and to D. And then it looks like B and E are connected. And I got to figure out all of the physical distances for all of the power feeders to know the exact lengths, right? So I say, okay, where's the main distribution panel? We just saw it right here. So from there to all of the panels, pretty much. So we had to let's see. There we go. Oh, there already. Main distribution panel. Let me take it out. There we go. Main distribution to A and B is that one. Main distribution to D. Take it out. Is that one. Main distribution to C. Take it out and put it back. Is that one. So now I know those actual links. Plus add like 10 feet. Okay, so the basics of electrical estimating is having a real good counting tool and practicing on your conduit links. Now, you may look up and get some plans that already have all the lines drawn and you just follow those, but when you don't, just know when it's the power plan, this is telling you that these two outlets are going to the same position in the panel, so the power feeder I can use for that can run together. Same with this, same with that. And these can run together. E25, oh, we did. And then at some point, we're going to imaginary run it to the appropriate panel for the home run, which we did. And we did that already. Okay, so that's the only tricky part. Good counting tool. Count all your devices, run all your wire, and pay good attention to your single line, because this is where the money is at. So you have to know, make sure you really measure very well those lengths, because those higher wires are very expensive as opposed to number 12. So you want to be very accurate in your measurements. Okay, and then you have a beautiful estimate all broken down in the way you want, but the way we know our electricians like is all the wire and conduit, all the wire and devices, then everything in the single line and the disconnects. Then we go to the lighting plan and then any additional items. Okay, so we would love to teach your class one-on-one. We teach for only $100 a month. We will design a plan for you where we'll meet once or twice a week. You'll have tests and you'll get certified. But if you have any questions, please send me an email at education@sfjohnsonconsulting.com. Let me know what you think, and please look out for the next presentation. Have a good one. Hey everyone, this is Stacy again, and I want to now go over the very last of the structural sets for our 3 projects, and this is the middle one, and this is the second one, the second largest. And so they pretty much have, in this case, we have some columns now that we have to install, vertical members, and we have pad footings that the columns sit on. And pretty much they are 2.5 by 2.5 by 1 foot and 4 inches deep. This is the reinforcement, and so any good cost book's going to give you the cost per pad for that size or approximately that size, and then you'll adjust the cost book price based on what it says and what it gives you and what your specifications ask for. And so you may have to run, the specs may say 4 number 4s. Okay, well, you might take the cost book price and then add an additional run of a number 4. So just know any cost book you use, and I was asked which one we use Craftsman cost book. There are a ton of them out there, and they all do the same thing. So the main thing is to use the one that you're most comfortable with, and know that it's not the Bible, but it gives you a good reference for which to build your material list and to get a pretty decent cost. And what I like it for the best is for our man-hour totals, because we go by what the construction industry says, and what it says is what we do. And so that's why all of our estimates are always very tight, bare bone, and our clients usually do really well. The only thing they have to do, they can verify the material cost on their own, but what we like is that we can verify that these labor rates are within industry standard. It's not something that, my uncle did it for 40 years, and so he knows how long it takes to install a column pad. Like, okay, well, and you have to imagine there are not very many women in this industry doing this, so I always have to hear that a lot. But, hey, I just go by the books, and we do very well. I would recommend going by the books, okay? And so that's the final estimate for this middle one. We ended up at, well, that right there. For the paint booth, I believe, is like an 8-inch concrete with the reinforcement. So it's pretty thick up there. So that was the structural for that one. Okay, let's go back to. So here are all the structural components, and remember, here's another W-beam, W8 by 18, how we by 11 3/8, and then the bottom plate. Bottom plates. What we need for here. That is just the third dimension of the lintel, and then how do we measure? Based on how many pounds, right? So we know how many linear feet we have, and then times it by 18, that's how many pounds, and then that's how you price it, is by the pound. And bearing plates, and so let's look at the foundation, this first thing. And so we had, remember this is a renovation, so we had to cut the slab and then build that out. And then our new paint booth, that's the 8 thick concrete, and then the 5-inch thickness, and then all of the column pads, and C1 are the columns, and then the column pads, and all the section views that go with them, and all that good stuff. And so what we do, we mark it out, get how many, the area for the new concrete, the area for the new paint booth, and then how many linear feet. It's just like all the other ones. This one is from the first project. Instead of doing 2, now we're only doing 1 for this one. And we have some trench drains. So let's look at really quickly A over S201. That's the trench drain section view. 201. The other 201. All right, so A. So what do we have to do here? Start from, well, the length of it, expansion joints. Gotta add that. The trench drain itself, which is in the plumbing set, we'd add that in the plumbing plan. And then basically the rebar. Okay, so same way you put it at the 16s, right? How many linear feet? I think it's 22 linear feet. So you can say this plus that, plus whatever, add all that together. So that's what you're going to place every 16 inches, right? So we do that. And then the column reinforcements, how they sit in the column pads. Okay. And then we had to, in a portion of this foundation, drill some holes, and all of that through our slab. See, let's go back to the, let's see where that came from. see, yeah, right here. Okay, so yeah, we had to drill holes every however many feet in both directions. So let's go back to that. See over 201. That's 201C. Yeah. So drill 2-inch in diameter holes at the 4 feet each way. So each way, same. So with this it was kind of crazy. So, just go through every 4 feet each way. We just visually went through it. And then how long is that? It's about an inch. We can scale it out. Then we know how many linear feet of hole we have to drill, because, and I think it came up to like 2 feet altogether for, in total. Because you got to know how many. Then we had to do the compaction, and then the slab number 4s. And here's when we're talking about where it tells you how long it is. So it's a number 4 rebar, but it's going to be 2 feet 4 inches every 24 inches. So again, you know how many linear feet of that you have. Change it into inches, divide by 24. And whatever that number is their number of placements, and then so that's your multiplier, and then you say that number times 2 feet 4 inches is how many linear feet of number 4 rebar you need. Okay, because a good estimator, you got to be able to do your material quantities, and that's all this is. Material quantity is easier to put together than the cost estimate. You got to do all the extra stuff with the cost estimate. Material quantities, you can just boop, 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 knock it out. Okay, so same here. We had a new awning, and so just look very closely. Good set of plans, and then your imagination, right? 1/2 by the square plate, so we need 2 square plates, right? And then for these we figure 4 different locations. Go back and check that. It's like we do so many of the same one. I'm like, oh, did I do that one right? I was like, I'm thinking about the other one. So yeah, material quantity. So 4 locations, because you're going to have this on both sides of the awning, and each of the locations going to have 4 screws. So you're going to have 16 of those. And I think this is an existing wall. Yeah, it's existing. So you got to include the cost to drill those holes for that to fit in. Okay, so all those kinds of things. All right, and I think that's going to be it. Oh, this is our, let's go back to, because it was very interesting. That's our foundation, but here is our roof framing. We didn't go over that. So what's happening with our renovation for the roof is these are exterior elevation views looking this way. Well, basically, these are all the lintels, which is, again, the metal header. Instead of wood headers, the lintels are metal. Some bracing had to be taken out. Like the other video, we had to do what it said there, took care of that. But this is overhead doors being installed, so they needed the metal header basically to hold the framing for the overhead window installation. And then some other stuff going on here. So let's go to 1A 301. It's right here. Right here. Okay, so they only show us one time, but it's all of the 4 that we saw. So again, this is a C-beam, C8 by 18.75. What's that mean? It holds 18.75 pounds of weight per linear feet. So we know how many linear feet times the weight. We can figure out how many linear feet and figure out the price, because we price again those by the pound. All right, so that is the middle project that came up to at $115,000 for the structural components, structural set. And shoot, that's it. So we have videos for all three. And remember, we're going to go over, once we review all the videos, there's going to be a lot still coming up for each of the scopes of work for each of the three projects. Then we're going to add everything up based on the square foot of the project, the different prices, and then we can go forward and start to create for each of the trades, see, which is going to be the fun part, creating a work schedule, a work breakdown schedule for each trade. And what you have to start to think about, especially if you're an estimator and you don't actually do the work, but you know how it's done. That's what a good estimator is. You don't do the work, but you know how it's done, and you can visualize it being done. And so the work breakdown schedule, you'll be able to see, okay, what would the framer do first? You lay out the bottom plates or whatever. You have to determine what comes first, second, third, in order to create the proper work breakdown schedule for each trade. So now you can create your budget for each day, whatever. And so that's what we're going to be doing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Hope you enjoyed this video. Let me know what you think. And please subscribe if you haven't already. And I'll talk to you very soon. Hello, everyone. This is Stacy with SF Johnson Consulting and Construction Services, and I hope you had a very enjoyable and safe Thanksgiving holiday. I just wanted to leave some information here on a new program that we're starting for only YouTube subscribers, that there are some certifications that we can offer you based on you reviewing all of our study videos, because when we have a class, a lot of the live classes incorporate everything that you see on all of our videos. And so the first class certification we'll offer is the basics of plan reading. And so what you have to do is review each of the 10 videos associated with that, and we will have begin a new playlist of the basics of plan reading class, so you'll know which of the videos we're talking about. So we'll have that uploaded by the first or the last Monday, the Monday coming up, and you can begin. But what you'll do first is go to our website, which is sfjohnsonconsulting.com. Scroll down and you'll see the YouTube logo, and YouTube students sign in here. And what you'll do is you'll give us, basically it gives you the instruction on how you perform your duties in order to get the certification. But here's the form that you complete to let us know that you're interested. And on our channel, on our YouTube page, we will have a playlist of, and it'll be called Plan Reading Basic Certification. And all of the videos related to any of these classes will be highlighted as YouTube certification. And so after you review each of the 10, now for the basics of plan reading, we have 10 videos that you have to complete. And each of the videos has a quiz that goes with it. And when you successfully pass the quiz, you go on to passing the final. And when you successfully pass the final, we will send you, mail you, or email you, whatever you prefer, our company certification saying that you've, made all the necessary requirements and you do understand this information. And if you do need additional time once you sign up, and this is for subscribers only, we will give you an hour of office hours where you can ask questions. You just sign up for that as well, and there'll be a form for you to sign up for that. Or you can use this form. So again, our first offering is the basics of plan reading. There are 10 videos to watch. Each of the videos has a quiz. So what you'll do is let us know here saying, I'm ready for quiz number 1, which is cover sheet, and all the basics of what's important to the cover sheet. And there are 10. And so when you pass all 10, again, you have to pass final, and then you get a certification saying, and we've been in business now, this is our 14th year. A lot of certifications come through this place, and the best thing about it, you will have experience that you can grow with if you do choose to enter the construction field, or if you already in it, this will be great for you. All right, so again, go to our website, sfjohnsonconsulting.com. Scroll down to the left, or right, I'm sorry, the other left, the right. YouTube students, you have to be a subscriber, we'll confirm, and then you can begin your journey in getting a certification. If you have any additional questions, you can use this form, or you can email me at education@sfjohnsonconsulting.com. And we begin this program as soon as you begin. So as soon as you let us know. But thanks a lot. And we hope to certify at least 200 people before the end of the year. So this is our first set, basics of plan reading, and then we'll be working our way through specific trades and the basics of estimating for framers, for da-da-da-da-da. And then we do have videos for all of that. That's coming up soon. So thanks a lot, and I hope to have you in class real soon. Talk to you later. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and now let's talk about framing and drywall. So what we have here is this is actually our smallest of the projects that we had to do. This is number 3, and the way that they broke this out, I don't know if you can look, but I'll get close, where they have a call out. So the broken line is the call out, and so we're going to go to a different page in order to see the layout for that framing. We're actually going to go to image number 1 on page A401 for all of the new walls for this area. But in the meantime, some walls are here, so we went ahead and measured P1, and we always go through the openings, go through all the doors and windows unless it's bigger than 16 feet. Okay, so that's wall P1, and then we had our other wall here, our firewall P3. Okay, and then we had P6, which was a 10-foot high masonry wall right there, and P5, which is one side drywall over there, 10 feet high, P6 and P5. Okay, so now we'll go to the call out. And of course we have to do the ceiling too, but we're going to jump to the call out. All right, and so all the different colors, and what do we have? So we just go through, and then we measure the desk for our finishes, go through all of the, now right here, this desk has to be sitting on something. And so what we did is we just priced all of the reception desks, because they all have reception desks separately, so it's like $1,700 or something. So that would include the base, the top, the everything. Okay, so we didn't include in some of them, like here, P4, in the very first project we did, it told us that these walls were 3.5 feet high. So we knew for all the other ones that they were 3.5 feet high. And again, it's not clear here, but the very first set, the bigger set, said that these are the walls at the workstations. And so this height, we've assumed them to be 3 feet 6 inches high for all of the workstations. So, we just did all the measurements, and we have the takeoff, right? So P1A, P1, okay, and then this was not clear at all. So this was completely excluded from any of the estimates, because where is that? So there's a couple of ways to try to find this, if it is not a mistake, or if there's any way to get clarification. Otherwise, it just needs to be, which we did, is excluded completely. And here too, we will have to go back and add it, but there's nothing on the plan. Even if we looked
here at 1/A301. I mean, if we go back there, where are we? Let's go back here. Well, this is in 99% of the time cases. That's why this is going to have to be, and again, this was not included in this drywall estimate or framing. And you see, and it's weird because this is a CMU wall in the building, and the building plans are of the architectural set of the A plans. So that tells us that this whole section is inside. Okay, so this, I mean, they need to give us more information. This section view, you're assuming that it's for the opening for the door, and that's all we used it for, is for the opening of the door. Even if you go to the exterior elevations to try to get clarification on fill in the openings, at least for, because again, this is a call out. Let's go back to the floor plan. Always go back too far. Okay, so remember, this is the call out. This is the exterior. And so there should be some indication on the exterior elevations at 4/A201 where this is, and where the other one was, where this is. I mean, and again, it was excluded from the estimate. So let's go to the exterior elevations and see if it's even shown there. Oh, going too far. Where's the exterior elevations? A401. Where are the exterior elevations? Where are you? Here we go. All right, so that would have been that CMU wall fill-in. It was the one near the front door. Don't see it anywhere noted here. And then I said, okay, well, what's that? Maybe it's on B. Let's read B. And then nowhere else is it noted on the exterior walls that there is a CMU portion that needs to be filled in. We had some on the building number 1 or 2 where we had to fill in the door that we had demoed, but again, that's why that's not included in B, is not fill in wall. Existing concrete masonry unit. Existing. Okay, and so very confusing. So we go back to that plan because that's it's not there. Okay, it's not there. So I'm thinking they may have mixed up 2 different sets of plans. I don't know. Sometimes I put, if I'm reusing a sheet, sometimes I leave the old address even though it's the name of the same project. So again, for the GC and for the student, this wasn't included because there's no indication that there should be a section view here telling us about the reinforcement for the CMU wall, all that good stuff. Nothing like that. So it's been excluded, and then when they want to give it to me or whatever, then we can do that. All right, so all the new walls. Okay, so now let's go to the partitions. And I think we have the estimate. All right, so there's our new CMU wall where we have priced it per linear foot. Cost book information, 100%. And we had a 4-inch hollow metal panel at the sink. We had to put that in now P5, P1, P1A, P4. You see how we broke down the framing, the drywall,
if it had sound bats, and then the finish of the drywall per CSF is 100 square feet, right? So that's 100 material and labor. And look at this one. And then normally, you know, we want to let the GC know based on what we see in the plans, what the height of the wall is, plus the height of the bracing, and price it all like that. Same thing, break it down. So let's look at the plans and how we look at the partition. So P3 was a 6. This is the firewall. That's the big wall that separated where they do most of the work. That was this one. Okay. So that's easy. And then again, how we lay it out on the estimate. Okay, so the math is important, right? Especially, let's do it for P3. Just so you can see. Now, that's the framing. That's the drywall. See, we have 3 on each side, and it's 40 cents per square foot. But we said the total square foot times 6. That's the drywall. But we're only finishing 2 sides, right? So let's go back to the misspelled word partition. So, right, we're only finishing that side and that side, but there's 6, right? So in terms of the finish and the level 5 and all of that, okay, go back. So we go back here, right, 6, but we say 2 times that gave us 30, whatever, 16, 56 times 2. So it'd be 34 CSFs for the finishing. And then the sound bats are the same as the total square foot of the framing. And then it had fire seal on top and bottom, both sides. So that would be the length times 4. All right, 79 times 4. All right, so, you know, you do that for every one. And then we have to do our area. And then our soffits, right? Our walls coming down from the ceiling. We went over a video specifically, I think it was this project, showing how we had 2 different types of soffits at section view 3 over A111 and 4 A111. One was 7 feet. The other one was 25 feet. I don't know, one of the two. Or 18 feet. No, 18 feet and 24 feet. And so we go into that, and we go to the, right, so the soffits are here. 4, A1, 11, 111, A11, so that was that length. And then this one was this length, so we broke up the soffits for, we calculate the area, and then we also calculate the section view material quantities for the drywall and the framing. So we have to look at 1 over A301. No, that was for the front door. That didn't give us info about this. No, we have to look at 4 over A111, which is here. And now we see that the soffit, that's the area part, but then we have to count for this up and then this area as well. Okay, and so that would be what? I mean, just give it 2 feet, you'd be good. Okay, for that times the length, so that's how many square feet. And then the 3 one is this one, so you have to count for. So if this is 6 inches, we already did this on the other video, so I'm not going to go over it again. The video last night, I think it's entitled Special Ceiling Drywall or something. But yeah, so you got to include that. And then what's also included in your framing, oh, nope, structural framing. We'll come back with another video for that one. You also include all of your door frames that are new. And here I just did, if I had to paint or stain a door or whatever. But then all of your, so your door and frame schedule is going to give you your door information, the type of door, the height and the width of the door, and then also your frame information, and maybe your hardware too or whatever. But a lot of this is existing for the smaller projects, so I knew I needed, and use it commercial. You're always going to see HMs or aluminum, hollow metal. We had a few wood doors for, I think, one of the other ones, like two wood frames. But typically in commercial, it's a hollow metal frame. And just count them up in the typical size of 3 by 7. And then if it's 6 by 7, it's probably a double door. We have one of those, I think, yeah. Hollow metal. Okay, so that's the framer scope of work too. And so, let's look at the estimate again. So we have the soffits, and then, oh, yeah, 1/A301. Okay, so keep in mind upper wall, lower wall. But again, the whole point of being able to be a great estimator is to be extremely, and make sure you're accounting for everything. So 1/A301, let's go to that real quick. 1. So this is the wall that didn't tell us anything about the extra CMU, but upper portion, lower. And so what we have to do, so we have the section view, I think it was like 24 linear feet of all of this. So what does that mean? You have 24 linear feet times whatever. So 24 linear feet of that, 24 linear feet of that, 24 linear feet of this, 24 linear feet of that, 24 linear feet times the height for that framing, insulation, that's what everything is on that. And then the lower, and as we can tell, this is outside because that's an awning. This is inside. And see, inside at the lower, you have drywall you got to consider on the inside, plus all of that. And so, go back to the estimate. Upper and then lower had more stuff because it had a drywall plus the framing. Okay, and so yeah, you gotta account for all of that. And then our windows, and what we did, this one, they should all be, that's each, but that should be a linear foot, because cost book for commercial glass is that much per linear foot. So we have 5 and then 8 linear feet of window, and then all of our doors, all of our frames, and then drywall framing before. Pretty much the cost, give or take what the GC wants to mark up the material or whatever. Okay, so that's it for this is project number 3. So this is the smallest of the drywall framing components, the smallest of the projects. And if you have any questions, email me at education@sfjohnsonconsulting.com. Otherwise, we have so many more to come. And I will talk to you soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I want to invite you to join us either with our service that we have at $199 a month, or take this class. It is $179 per session, and there are 16 sessions. So this is law and business. Well, actually it's 16 hours, it's 8 sessions, because this is, if you want to take your contractor's license to be, to get your license in law and business, which is a license you can get. We assist our clients, and this is one that I'm very excited about because I'm going to law school, and law is awesome. And so we teach this class. This is a 16-hour class. We meet 8 times 8 weeks for 2 hours per week, and this is what you would study. We would go over business organization, so for you as a business, and also for how projects are organized in a business way. So what's involved in, I go over even more stuff, which is the delivery systems for construction projects, as well as what is involved in project management. Okay, so we go over that, and we cover business finance, so cash management principles, how to do a construction budget and budgeting principles and planning. We go over the taxes, how to apply those, and financial reporting. So make sure you know how to report every quarter and every year. Next, we cover the employment requirements. So employment regulations, evaluations of employees, because in some states that's very important, and in particular here in California, and record keeping, very important, and also how to complete payroll and what you need for that, and what's the best way to go about that, and what you need to do by law, that kind of stuff. And remember, this is law and business, so these are all the legal aspects related to business. Okay, so next would be this is all issues specific to contractors too. Okay, so also bonds, insurance, and liens. So we go over bonds, how they work, what that's all about, workers' compensation, liens and remedies, and other insurance related items. Okay, 5 is the contract requirements and evaluation. So bidding, how to review requests for information, knowing all about addendums, what the legal requirements are for paying addendums, that kind of stuff. Cost controls, contracts, and payments. So we go over also, in addition to what's here, we go over the AIA contracts, so you know all the different types and all the wording and all the family types and all that kind of stuff. And 6. So there's 8 parts for law and business. So 6, licensing requirements. So your business license, your contractor's license, and activity regulations. And 7 is safety. Of course, we know what that is. Training and reporting for safety, the general safety, hazardous materials, that kind of stuff. That's part of the safety training for law and business. And last but not least is public works. So understanding everything about prevailing wage, bonding requirements, and insurance requirements in the setting of working for the state or for public entities. So if you're interested, that class is every Tuesday beginning the 8th of November, and 10 a.m. to noon every Tuesday for the next 8 weeks. It's $99 per session, or if you're on our $1.99 a month, which is a steal, you're invited under that program. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I hope to see you next Tuesday, the 8th. Vote and then come to class. All right. Thanks a lot, and I'll see you next time.
Hey guys and ladies, this is Stacy with SF Johnson Consulting and Construction Services, and we are starting a new little series here where we are showing our clients how to obtain different business certifications. And so if you go to our website, we have a link now, get your business certification for 2023. We click on the link, and there are a series of different certifications that you can obtain for your business. Minority owned,
disabled, a lot of different, and a lot of the certifications are related to being a woman-owned, minority-owned, a disabled person. Your business is in a particular area, and all of the certifications pretty much are tailored towards disadvantaged groups, which are women and minorities. And in this case, depending on where your business is, it's just a whole list of different certifications. So we are going to go over how you and what you have to do to obtain the certification. And the first one we're going to start with that seems to be the easiest is the Department of Transportation. And if you have a certification with them, it assists you in a lot of ways. So let's go to first the site, the national site, the U.S. Department of Transportation, Disadvantaged Business Enterprise. And you know what? I hadn't even played this for myself. So I'm going to play this really quickly and see what it's all about and why we would want to. And then the first one we're going to review is this one and what we need to do.
The U.S. Department of Transportation's Disadvantaged Business Enterprise Program.
The Department of Transportation distributes substantial federal funds to finance transportation projects initiated by state and local governments, public transit authorities, and airport entities. The DOT is responsible for ensuring that all business enterprises have a fair opportunity to compete for federally funded transportation contracts. The Disadvantaged Business Enterprise (DBE) program is the DOT's strongest tool for creating a level playing field. The DBE program began in 1980 as a minority and women's business enterprise program. The program was established under the authority of Title VI of the Civil Rights Act of 1964, which prohibits racial, ethnic, and national origin discrimination, and other statutes prohibiting gender discrimination that apply to DOT financial assistance programs. Congress has reauthorized the DBE program several times since its inception. Most recently, Congress established a continued need for the DBE program in the Moving Ahead for Progress in the 21st Century Act. As a condition of receiving federal financial assistance, recipients of funds from the Federal Highway Administration, Federal Aviation Administration, and Federal Transit Administration are required to follow the DBE program regulations located in 49 CFR, Parts 26 and 23. The Departmental Office of Civil Rights coordinates the Department's oversight of the program. These three operating administrations, FHWA, FAA, and FTA, are primarily responsible for overseeing the day-to-day administration of the program by recipients, providing training and technical assistance, and enforcing compliance. The DBE program remedies ongoing discrimination and the continuing effects of past discrimination in federally assisted transportation contracting markets nationwide. The day-to-day administration of the DBE program is carried out by recipients of federal funds at the state and local level. This includes approximating how much participation is expected from DBEs by setting an annual overall DBE goal that represents the level of participation anticipated absent the effects of present and past discrimination. Recipients must set an overall goal for DBE participation and monitor results to foster non-discriminatory environments and ensure that DBEs have an equal opportunity to compete fairly. The DBE program isn't a quota or set-aside program. Instead, it's based on narrowly tailored goals and participation by prime contractors, subcontractors, and agency partners. Certification of eligible firms is a key component of the DBE program. But what is a DBE? A disadvantaged business enterprise is a for-profit small business. At least 51% of the business is owned by one or more individuals who are both socially and economically disadvantaged. and the management and daily business operations are controlled by one or more of the socially and economically disadvantaged business owners. Firms meeting the eligibility standards can contact state departments of transportation or state DBE liaison and certification officers for instructions on how to apply for DBE certification. Each state has a unified certification program, UCP, to ensure certification decisions are honored by all recipients in that state. There's also a streamlined interstate certification process for existing DBEs wishing to participate in other states. A firm must be certified to be counted toward a DBE goal. To find out more about the DBE program, how to apply to the program, and other useful contacts, visit the DOT website.
All right, so that's pretty straightforward. Okay, and so we're going to have all of the links on our website to the national site. We're having technical issues here. Here we go. There we go. We'll have a link to our site from our site. This is our site. From our site to this first one, we're going to go over the Department of Transportation. And so that's pretty simple. You know, it will help a lot of people like me that are women-owned, minority-owned firms to, it's not easy to get in. You have to make sure all your I's are dotted and your T's are crossed, but it is a way to help you build your business. And it's nice. Okay, so that's their website. So you can get all the information. We'll lead you from our link. And then here also we'll have on the website are all of the state agencies. Try to make it a little bigger. And I called a few, some of the numbers, this is I got 2022 April. It was the update that I got. And I called a few of these numbers, and some numbers don't exist. But I can imagine since COVID, the phone numbers may not exist, because my main thing was to see if there is a fee you have to pay. And because these are government agencies, I'm almost certain there is no fee you have to pay, but there are other certifications that will go over that there is a fee depending on the agency. Some of the other choices do require a fee, but that's why I wanted to start with this one, because there is no fee associated with it. And again, if the Department of Transportation, why do you get it, right? Because the Department of Transportation has a need, hires people to do all types of things, right? Contractors in all areas. And so maybe even for me, they could hire me to teach OSHA, right? They could hire me to teach OSHA. So they have a lot of different needs for what they do. And so if you are someone that does something that the Department of Transportation needs, you could apply for the status, and that way, when they have those projects that require disadvantaged business participation, you'll be in the running to be able to bid. And it said it's not a set aside. Set asides mean, because you are, in some states have set asides, and that's nice. If you are a minority or woman-owned or whatever owned business, you automatically get the project. You don't have to bid or whatever. Those are set asides just for those particular classifications. But in all cases, especially in construction, it's very useful to have these additional business certifications. And again, this is just one of the many that you can have. So if you go to our website, you can look through
And then you can also let us know if you want us to assist you in completing any of the certifications. We would love to, but the Department of Transportation is going to be our first one because, again, it is the easiest. So everything is here for you to go through. If you choose to do that on your own, it's very easy. Or if you want us to assist you, please let us know. We'd be more than happy. All right. So that is our first form. We'll go over all the other ones, but that is the Department of Transportation Business Certification for disadvantaged businesses. And 2, you have to make sure you qualify. There is a what is the definition? Okay, let's try to move this over a little bit. Okay, so we have to, it does not exceed 1.32 million. Okay, so if you don't, DBEs are for-profit small business concerns where socially and economically disadvantaged individuals own at least 51% interest and also control management. See, and back in the good days when when this was first created, they want to say that a disadvantaged business was always one owned by a woman, right? But the thing is, the woman has to know, like me, the woman has to actually do the business and have control of management and the daily operations. Okay. And so it's not a good thing to say it's a woman-owned business and the woman is the wife and really has no clue on what goes on the day-to-day, because you'll get caught and it's not a good thing. All right. So African Americans, Hispanics, Native Americans, Asian Pacific, and subcontinent Asian Americans and women are presumed to be socially and economically disadvantaged. Other individuals can also qualify as socially and economically disadvantaged on a case-by-case basis. So, that's why I love America, and that's why we can't mess it up. Okay. Requirements for DBE participation: to participate in the program, a small business owned and controlled by a socially and economically disadvantaged individual must receive the certification. So in order to, of course, get into the programs or, get into the projects, you have to have the certification. Yeah, I'm a African American. I make less than 1.232 million a year. Yeah, but no, you have to go through the paperwork. Okay. So I would say it's a good thing. And again, if you need our assistance, we'd be more than happy to help you. So any questions, email us at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next certification.
Hello, this is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this video discussion, we will be going over the RFIs, or the request for information, the best practices for contractors, and what you should be looking for and how to organize them and navigate through them. So what is a request for information? Well, by definition, the request for information, this refers to a solicitation of details or additional information about an aspect of the project. Usually it's sent by one party when they need critical information to proceed or to make a decision. And the goals of the request for information, actually, what are the common reasons why we send the request for information? Sometimes when we're missing or have incomplete information, of course, and just from personal experience, most of the times the plans are not to detail or they have many, many mistakes. And anytime that you recognize that there is a mistake, definitely send through a request for information. So if there's any missing information or any of the information appears incorrect, I would request, additional information. Common reasons also
the plans or the details may be changed because of a design flaw. And again, this one that you probably would find yourself. They could be changed for material availability or for cost or for some other reason. So there's a variety of reasons for the request for information. Also, updates may be made to the plans based on new or previously unavailable information and change requested by owners, designers, or contractors. So those are some of the common reasons for requests for information. But from the day-to-day process, it's because something is not clear on the plans. And I also always recommend that if something in the smallest, slightest event seems unclear, request more information. Next, some of the goals for the request for information. Well, the goal for the request is to, or the ideal of it is to formalize the request for information for changes to the plans. So the request actually, again, formalizes the information so we can change the plans. Documents concerned about the materials or cost estimates. So that's what the goal of the request for information. It documents concerns about materials or cost estimates. It shares information and highlights changes to all key players in the project. And all of this helps the project progress smoothly and limits legal and financial liability for groups that stick to the process using formal requests for information. So it's always, everything definitely needs to be in writing. So that is really the goal. Again, to formalize the request for the information so all the parties receive it. It documents the concerns and it helps to move the project along. And if there are any changes as a result of the request for information, that has to be documented as well. So let's go over some general best practices for the request for information. So anytime you're seeking information, always ask for one thing at a time. So don't make it a multiple request unless they say it's okay to, then that's fine. Use a specialized form or standardized form and note the time frame in the contract, and that's important. Every contract should have a time frame as to when or how long it will take to get the answers back for the request for information, so make sure you review the contract. Store all requests for information in a centralized database so you'll have them available. Keep a record of delivery of all requests for information. And note the construction schedule or budget may be changed based on the response from the request for information. So again, note that the construction schedule or budget may be changed as a response to the request for information. And create a permanent request for information audit trail so you'll know the days you receive them, the day that you receive back the information, and it keeps everything clear. Read all contract documents because the contract will give you all the guidelines for the handling of all requests for information. And in some cases, you have to consider the cost for the RFIs to all parties involved. Each may cost up to $1,000 to administer. So they try to keep those questions to, or those requests to a minimum. But if it's needed for clarification, you do need to request. Next, how to write a request for information. The best practices for that. And without the guidelines for creating and submitting a new request for information, contractors may be confused on exactly how to create an effective one. So use clean and simple formatting, follow a consistent format, and naming convention, the way you're going to name things. Make sure all abbreviations are used by the same parties, meaning the same thing. Ask one question or request very specific information. Provide complete and accurate context of the situation or question, and provide any documentation, images, video, whenever necessary. Okay, so what happens after the request for information is answered? Typically, if the response answers the question that was answered, then there's a record and there may be a change. So in most cases, it's a delay in the response, and the delay in the response typically is about 25% of the requests for information don't get a response. So always make sure you keep up with that and apply or comply with the timelines for the request for information. Tips with dealing with RFIs. Thoroughly read the contract. And the contract will have accurate guidelines on how you deal with them in terms of how much time it's going to take to get a response back and how to properly submit them. Address any request for information as early as possible. Depending on the delivery method for the project, it may be more difficult. Anytime you have a design build type of project, those are the most difficult to deal with requests for information because you receive plans at the time that the project is designed, which means, and a lot of times there's a lot of questions to be answered. So that delivery method, in that case, you usually have a lot of requests for information because a lot of things are missing and a lot of things don't make sense. And so address the request as soon as you think it's necessary or as soon as you are asked information, make sure you answer. In any of the other integrated delivery methods, meaning integrated labor delivery, a lot of times the contractors themselves are directly involved, and so they have more insight on the project, so you have fewer requests for information. And then last but not least, use some kind of document tracking so you can know when you received it. It's all documented. Everybody has a copy of when everybody received everything and when everything was sent. And last but not least, there's a sample request for information in this presentation, and all of the video discussions go hand in hand with all of the live classes. So this is an addition to the live class for you to review. So review the sample request for information. The first part of any of the request for information is record keeping. Record keeping information for internal needs and uses. And so it's always an automated number. Make sure you know what company you're specifically sending it to, the dates that you send it, and the name of the project and number of the project. And the rest of the document, is a detail about the information that you request. So again, this video discussion presentation goes with the live class that you should have attended. And if you have any additional questions, please make sure you sign up for online office hours on our homepage. Again, this is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services, and I will see you in the next class.
Welcome again to OSHA Live, where every Monday at noon, we're going to present some free OSHA content to our friends here on the internet so you can stay safe. So we have a couple of classes beginning this week, and so we might as well start with the same thing that we're going to start with when we have our live class. And let's see if we got everything straight. And we start our very first class with the introduction to OSHA. And so intro to OSHA, it typically is an hour class, and we cover some of the history of OSHA, the mission, and the OSHA standards. And that's really like the most important, reason why we
we have OSHA. And it's like, why even have OSHA? And basically, in the 70s, when Nixon was president, there were more people dying at work than during the Vietnam War. And so Nixon and our government came up with, through the Department of Labor, came up with OSHA, the Occupational Safety and Hazard Health Administration and Hazard. It avoids hazards. The Occupational Safety and Health Administration. And so we have a little video here we're going to watch. And it really tells about some of the things that people were going through at the time. OSHA was created in the 70s and during the 80s. And, you know, basically the reason why we have OSHA is kind of, you know, for basically, I mean, really to keep our employees safe, but also to keep our nation strong, right? So if there are more people dying at work than at war, there at that time there was really something wrong, you know. So for every injury in a family, right, that disturbs the family, the livelihood, the way of that they live, their everyday life, the kids, everything, and so it is our duty as employers to make sure we keep our employees safe. Okay, every life, you know, needs to stay intact. So when we talk about injuries on the job, there are direct costs of an injured person. There are direct costs related to the injuries, and then there are also indirect or hidden costs that are related. And so when I give the class, I try to ask my students, you know, give me an example of the direct cost, right? Well, medical payments, right? That's a direct result of a employer or employee getting injured, right? We have new medical costs. Shoot, you might even have indemnity payments for an employer, right? You have to, if your employee gets injured on the job, you have to pay them just like you have to pay anybody else you injured. And so their direct cost is an indemnity. A workers' comp claim, usually, if it's bad enough, right, usually sometimes ends in a lawsuit against the employer because they were probably negligent or didn't have the OSHA training program, or they didn't have the hard hat on, or they didn't have fall protection. So, you know, it's fun until somebody gets hurt, right? And then the family's affected, and then you start to get sued. And so direct costs, legal fees, definitely direct cost. So what are some of the indirect costs or some of the hidden costs that they can basically really exceed the direct cost by 2 to 7 times, right? So we're talking about stuff like no, the company profit, right, there's a reduction because the workforce is reduced or affected in some way. Okay, now the cost related to indemnity sometimes aren't even covered by insurance, depending on it. If it was based on negligence is never covered under or penalties basically aren't really covered or have never covered under insurance. And so that's an indirect cost that the employee would have to pay depending on the incident. You know, the cost to punish you, that's not covered under insurance. So that's an indirect cost. Now you have to pay overtime, right, because people are injured. And so now you have to have extra people work extra time, indirect cost, which really could be a direct cost too. And then really, in terms of employees, you know, if depending on the injury again, depending on like the severity of the injury, then you know, people walking around for 2 or 3 days talking about what happened and not working, which is understandable, right? And probably scared themselves if they do the same thing that bro did to get injured and it didn't get any better. But really, when it comes to OSHA, depending on the severity of the incident, OSHA be out there, so that's another thing. OSHA will come by and pay you a nice little visit. So, the cost to resume regular activities, that's an indirect cost. And then there are other factors, right? Family stress, mental, emotional strain, the cost, the loss of the ability to make a living. So it's always best to put people first. And OSHA was created to put employees first. So that's pretty much the history. We're going to watch this little video. Let's watch the video. Let's see if it plays as easy as I hope it will. And we'll see.
We came out on strike because of the inhumane working conditions, because people was being misused so badly.
We're fired up, can't take it no more. 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 We're fired up.
Occupational safety and health is a major social concern of the 1980s. These people are part of that movement. They are asserting their right, now written into law, to a healthy and safe workplace. This right has had a ragged history. It's not always been recognized. Work has killed millions. They've died from explosions, falls, electrocution, dangerous machinery, from breathing in poisons in the air. Millions more have been mutilated or permanently disabled at work. This year, it's estimated that up to 100,000 people will die from job-related injury or disease. Over 5 million will be injured at work. Following the Civil War, the American economy was expanding rapidly. In the closing decades of the 19th century, production rates were climbing, and millions more workers were needed. Between 1900 and 1910, nearly 9 million people immigrated to this country, looking for work and a better life. But many also found harsh conditions, long hours, low wages. The work was tough and dangerous. As the production rate went up, so did the pressure on workers and the casualties. Railway workers had one of the most dangerous jobs. Nearly 15,000 were killed between 1902 and 1908. Mining accidents were frequent. 4,700 died building the Panama Canal. In a single Pennsylvania county, 526 workers were killed in 1 year. There were few government rules covering safety and health, and workers had few rights. There was no legal protection for unions. When workers did organize against these harsh conditions, their strikes were usually broken by the company, sometimes with the aid of hired police or government troops. Outraged journalists and social reformers began to support workers' efforts to organize. Photographer Lewis Hine exposed the horrors of child labor. Novelist Upton Sinclair, in his classic work, The Jungle, described the brutal lives of Chicago's stockyard workers. He said, "I wish to frighten the country by a picture of what its industrial masters are doing to their victims." Exposés like these finally led the government to create the first agencies to protect workers. Woodrow Wilson won labor support by agreeing to improve safety in the workplace. In 1913, the Department of Labor was established. Pressure for change was often finally effective only after a major tragedy. After 361 men died in the Monongah mine disaster of 1907, the Bureau of Mines was set up to supervise mine safety. Gradually, industry began to regulate itself in what is known as the voluntary safety movement. The National Safety Council, founded in 1913, set voluntary guidelines for safety engineering and better working practices. Companies put guards around dangerous machinery, set up first aid stations, and began safety classes. But safety education stressed that most accidents were the workers' own fault. This film, made by the National Association of Manufacturers in 1911, was one of many that singled out workers' carelessness as a cause of disaster. But many terrible tragedies were not caused by workers' carelessness. The same year that film was made, a fire burned the Triangle Shirtwaist Factory in New York. Because many of the exits were locked, 146 people, mostly young immigrant women, died. Again, it was only after the tragedy that the first permanent commission to inspect factory safety was set up in New York. During the same time, industry helped establish a system to compensate workers for accidents. While this workman's compensation system gave employees a measure of financial security for the first time, it took away their right to sue the company for damages. The amount of compensation was limited, and workers were not represented on the boards that decided claims. But this growing concern for workplace safety had some noticeable results, and accident and death rates fell. In fact, many industrialists thought the safety problem was solved. This safety film ended with an idealized picture of a steelworker's life.
The Safety and Health Committee can be one of the most important committees in the plant.
Workers today, like these at a Chicago steel plant, know the safety problem isn't solved.
And we know, all of us working in that plant, that there's just a myriad of problems out there in safety and health that we've got to begin to do something about.
One thing is for sure, if we got a record, a backlog of safety and health grievances and good, well-attended meetings where people bring out specific problems, we're going to be in a much better position to negotiate those kind of health and safety provisions that we need, because they're going to be based on something real.
I've got a list here of 26 accidents that I've heard about. Many of them serious. A guy got 200 stitches.
200 stitches?
200 stitches. Another guy got shocked with 2,200 volts.
There was a burner killed in the 34th. He didn't pick up his card at the end of the turn. They found him. They went out to look for him a few hours later, and the blood was already dry and everything. He was under several tons of steel.
The one case I think some of the people here are aware of is this case of Jesse Bustos at the 30-inch.
When I finished unscrewing, I had no idea that this piece of steel was supposed to drop on the generator. When it dropped, when I finished unscrewing, when that piece of steel dropped, it grabbed the tip of my glove, and I got caught. These two fingers. I was stuck for 45 minutes. They couldn't do nothing until the doctor got there. He got there, I think, in about 20 minutes. I got the morphine shot. It took him more or less 45 minutes to get me free. The foreman there should have told us what the job was exactly gonna do, what it was supposed to do, and they should have never let me do that job by myself. I was an apprentice. They didn't tell me what was supposed to happen. They didn't give me no safety tip. That is their job.
Management must provide safety training before the man is put to work on that job.
You have a union, something that we didn't have at the beginning. You have your union, strike the net and fight. That's the only thing you can do.
The most important thing is policing this thing, and nobody else is going to police it but us.
That's right.
Like workers today, workers in the past faced not only sudden death or injury from accidents, but slow death from fumes, dusts, and poisonous gases. Doctors were slow to investigate these industrial poisons and the diseases that could result from them. The first major American study was not until 1910, when a young doctor, Alice Hamilton, investigated the effects of lead poisoning. There were further government studies into health hazards, but few industries applied their findings, and workers' health was virtually ignored by industry until the 1960s.
Okay, what we're going to do now is a test that tells
Bob Samuel has silicosis, resulting from 28 years exposure to silica dust.
I started working in 51 as a labor, and then I went to shipping. And I shipped for the rest of my time until 1978.
try to get all the air out of your lungs, okay?
I first noticed I was getting sick back late 60s. And I started getting short of breath.
Push more, blow, keep blowing, keep blowing.
Then I went to the doctor, and the doctor taking x-ray, but they didn't tell me what was wrong. So we decided we would call in the federal government. So after they come in there, they found out I had silicosis. But the company themselves have never told me that I had it. I had to find this out through, doctors. The company knew all along because you had guys that was dying from it.
In the 1930s, hundreds of men were hired to dig the Gauley Bridge Tunnel in West Virginia. They, too, were ignorant of the risks they ran. Desperate for jobs during the Depression, they worked with virtually no protection in a tunnel thick with silica dust. 476 men died here from silicosis.
My name is Walter Kincaid. I worked in the tunnel 4 or 5 weeks. Every day I hear of someone dying with silicosis. I worked until I got sick, and the doctor told me that it was silicosis. And he also told me that anyone that worked as much as 24 hours would not be living 15 years. I think something should be done for our wives and family after we are gone.
Once again, after the deaths, there was a public outcry.
I personally believe that 2,000 men are doomed to die as a result of ruthless destruction of life by American industry.
The next year, 1936, the Walsh-Healy Act was passed. Although it only applied to contractors doing business with federal agencies, it was the first time the government directly imposed health and safety standards. One of the areas the rules covered was the use of respirators. The respirator is one of the oldest protective devices in history, and for years, workers' health continued to depend on respirators alone to keep poisonous dusts and fumes out of their lungs. But respirators often don't fit properly. They leak or simply don't filter out enough of the poisons. Today, government strongly favors cleaning the air in factories through ventilation and other devices. But through the 1930s and 40s, industry continued to rely on ever more elaborate respirators.
Today, thanks to the cooperation of safety men in many industries and government departments who supported and helped guide the development development of respiratory protection, the menace in the air is removed for those who wear respirators. For where men once died, we who wear respirators can now live safely. And life for us, like the air we breathe, is good.
That respirator is not going to do you no good. I wore it for 28 years, and it didn't do me no good. My lungs is filled with that dust. I can walk about maybe block and a half. That's about the best I can do. It's pretty rough when you're trying to go up a flight of steps. When you used to run up there, and I can't do that now. And a lot of nights I get up. I have to get up all through the night and be coughing. I still spit up that dust, and it's still all in the pores of my skin. Can't get clean. You don't know, tomorrow, next week, next year, you might go. You just can't sit and think about it, but you just have to go ahead on out and try to, enjoy yourself. Do the thing that try to do the thing you've been doing, but don't worry about it. Made my wife sit down and talk. Told her once never would come, but just come by. Just try to do the best I can. A lot of lonely nights, you can't sleep. You know you just dying day by day.
The 1930s, the Depression, years when you were lucky to have a job at all. But Franklin Delano Roosevelt began New Deal legislation to help people during the Depression. He introduced jobs for the unemployed, Social Security, a minimum wage, and the 40-hour work week. Although most of these laws did not directly affect safety and health, they permanently raised the level of government concern about working conditions. The National Labor Relations Act made it a legal right to unionize, and in the 1930s, industrial unions organized and sought the right to represent all workers in an industry. In the automobile industry, for example, the United Auto Workers struck at Flint, Toledo, and Detroit, and won the right to collective bargaining. Labor was emerging as a powerful force that would be better prepared to deal with later health and safety issues. Then came the war. Health and safety on the job suddenly became an important issue, largely because preventing accidents meant saving work days for the war effort.
Save a day to keep them rolling. Save a day to keep them flying. Save a day that Americans of tomorrow may live in a land of peace, in a land where freedom reigns.
Safety supervision was stepped up in federal war plants, and the need to keep workers healthy led to some advances in industrial engineering and medicine. The Public Health Service laid down its first standards, setting maximum levels for dangerous air pollutants at work. But these first standards were often far too lenient to clean the air effectively, and they could only be enforced in plants with federal contracts. For the rest of industry, they were only voluntary guidelines, so many workers' health still depended on the goodwill of the company. With the end of World War II, the workplace itself was changing, as an explosion of technological inventions and chemical discoveries brought a new slew of dangerous dusts, fumes, and gases that threatened workers. Workers usually did not know what they were handling, or whether these synthetics might cause cancer years later. But in the 1950s, research into the health effects of these chemicals
was minimal. It was not until the 1960s that a new revolution in occupational safety and health began, supported by two parallel political movements. The environmental movement began to question the long-term effects of chemicals on our health, and the civil rights movement made people more aware of the rights of each individual. These movements created a climate of reform which encouraged other groups, including workers, to demand more control over their lives, including their safety and health.
We're going to help shape a better future for the working people of this country and for their families. We are pledged to bring safety to the workbench and to bring safety to the job site.
Labor leaders worked with the Johnson administration to propose a new government agency to enforce health and safety rules.
This year, I asked the Congress for a workers' safety bill to protect you.
But once again, the law was not passed until after a major disaster, when 78 miners were killed at Farmington, West Virginia in 1968.
I think all of us have been at fault in not taking aggressive action to preserve 20th century safety and health standards for the workers. Now there's a revolt in the mines, and the workers are going to get the kind of conditions that they deserve and should have had.
Within 1 year, the Federal Coal Mine Health and Safety Act was passed. And in 1970, Congress passed the Occupational Safety and Health Act. This confirmed in law the right to a healthy and safe workplace and established the Occupational Safety and Health Administration, or OSHA. The Act says that employers have the primary responsibility for providing a safe and healthy workplace. OSHA is responsible for making safety rules and enforcing them. Workers have a right to talk to their supervisors, their union, or OSHA, about safety and health problems. Jim Belrose suffers from failing eyesight and severe skin discoloration. These job-related problems affected both him and his father, who worked at the same plant.
I worked 24 years in the plant. They made silver nitrate. I take silver bullion and turn it into a liquid form. Then we would put heat under it. As it started reacting, you'd get the yellow poisonous fumes off it. When they weighed silver crystals up, there used to be a real strong dust that came off of them. That there helped turn the skin dark. My father worked there for a while. His eyes discolored when he was there. His complexion was dark too.
He was real old-fashioned type person. As long as you got a job, you just do it, shut your mouth, and get your pay at the end of the week. And if it hurts your body, it hurts your body. Don't worry about it, you know. And it's the same with a lot of the older guys. They wouldn't ever say anything.
But I think one of the things, too, that they were always told it was never harmful.
Unlike his father, Jim was skeptical. He and his co-workers called in medical investigators from Mount Sinai School of Medicine and asked management to make changes.
We were told if we didn't like the way they operated, that we could go for a walk. And that's what started the whole thing. And so our walking was right to OSHA. The first day they were there, they found 52 violations in 10 minutes. The 4 or 5 guys that really started the whole thing, they were afraid of losing their jobs. But they came to the point where it was a difference between your health or the job. So we took a choice of our health.
I was afraid he was going to lose his job, Because they said, well, if you don't like it, you don't like the way I run the company, leave, And we had 4 little kids at that time, smaller children. And I wasn't working, so I thought, oh my goodness, here we go. So yeah, I was for him, because I know that he didn't feel good a lot, and like our family life wasn't what it should have been because of it.
I sued for our eyes. and we fought the case. Just a little while ago, I got my final settlement. They didn't want to pay it because they said it was just a hazardous occupation, and those things just came naturally. People shouldn't have to endanger their lives just for the pleasures of other people. Get OSHA in there. Make an effort.
Today, there are 20,000 chemicals in the workplace that are suspected of being toxic. About 1/5 of all cancer cases are associated with exposure to chemicals on the job. And OSHA is working to reduce these dangers by setting more comprehensive rules. In addition to OSHA's presence, the unions are spending more time and money on safety training and devoting more contract language to health and safety. Workers are demanding the right to see their own medical records, to be told the names and properties of the chemicals they work with, to know the level of risks they take on with the job.
We have been trying to get the company to give medical examinations for over 2 years. And so far, they haven't complied with any of OSHA's orders.
OSHA had ordered the company to give comprehensive medical examinations to its workers, some handling the toxic chemical DES. DES is a female hormone that can cause sexual malformation.
The people at that time were working without respirators, and if they used respirators, they were dirty, they weren't clean, they had no training program. People were very ill. Some of the guys grew breasts.
All I did was mix these little packets of pure DS into some liquid, and I was exposed to this, and my breast enlarged and itched, and I had a lot of trouble. And I was becoming impotent.
He got the contamination so terribly bad that he finally had to have surgery. And they had to cut him. They had to open him up breast to breast.
My life now is just... I got a divorce in 1976. My ex-wife got married again because she didn't think I was good. I don't know what the story was, but anyway, that's what happened. The big wheels of the company, they didn't care if you had to go get an operation or anything. They just figured, what the heck? Them, not me. They're doing the right thing by being on strike. They probably shut the place down, but it's probably the best thing for all people ever going to work there again. The reason why I took the DS job in the first place because it was more money. And right at that time I was in the process of getting married. And I thought it'd be better for me and my wife if we had more income coming in.
The dangerous job is cutting on the saw. These saws was placed right in front of the ice house, and they would keep the ice door open, so the people's hands would get so cold they weren't able to know if they was cutting the chickens or cutting their hands.
Limited job opportunities for process and plant workers.
By several men got 3 or 4 finals cut off.
Excellent pay scale, life and hospitalization.
Girl got one of her breasts cut off.
Paid holidays and paid vacation.
You only had 3 times a week to go to the bathroom. If you couldn't do what you had to do in your clothes, then you would be suspended. You would break out in, we call it chicken rash. And it looks like chicken pox all over your body.
As the workers have said, treats the chickens in his plant better than he treats the human beings who work for him.
The permission of going to the bathroom, you asked him, please, now, so let us go to the bathroom, and he wouldn't let you go. A pregnant woman, 3 months pregnant, asked to go to the bathroom, and he wouldn't let her go. Within 5 hours, she a miscarriage. To the workers of that is not misusing human being, that is taking a life.
We are very sure that this is the right thing that we're doing, striking and making it better for our children, because we have already won. We've never been so free in our lives.
We are beginning to change our attitudes, to protest about dangers that used to be accepted as part of the job. We are moving from haphazardly protecting workers or compensating them after the fact to trying to prevent hazards from happening at all. Workers themselves are making history by questioning their working conditions, finding out the risks they run, and claiming their legal right to safety and health.
Okay, that was crazy, but it just shows you over the years, it's either no law, there's a law, but they won't enforce it. I mean, so 1970, we ended up with OSHA. I'm almost certain companies in the South today probably don't follow any of the standards. I'm almost certain of that. And so, that is the history of our country, pretty much in a nutshell, right? Just, man. So you have to make sure that you protect yourself. Workers have rights. You have a right to, well, the owner's responsibility. Okay, we already know, to provide a workplace free from hazards, to provide training. Okay, so they have to provide training for you. Okay, to keep records if there are injury and illness at the job. They have to provide medical exams when required, and we'll find out that they are required when you have to wear respiratory protection. You have to get a medical exam. You have to get fitted for that. You see those poor people. Can't discriminate against workers who exercise their rights. Okay, we have whistleblower protections in OSHA where, it's just, we just don't, why we want to keep repeating the problems of our past is beyond me. You have to post OSHA citations if you get them. And you also, most importantly, have to provide and pay for PPE, personal protective equipment. And as far as the workers' rights, of course, we have the right to be safe and healthy at our workplace. We have to be made aware of the hazards and conditions. So we will cover something called health hazards in construction. Know about injury and illness in the workplace, what chemicals cause what injury, that kind of thing. And silica dust, silicosis is still a problem today because you have people out there, drywall, that's silica dust. You finish in that drywall and you don't have a proper respiratory mechanism, you're going to end up with silicosis, period, even in 2022. So, training. Okay, you got to train them. Expose hazard exposure and medical records. Okay, you have to. There has to be. You have to have medical records and the hazards and exposures and medical records for your employees that are related. You have to have those on file related to any hazard exposure that you've exposed your employees to. Okay, so the workers have the right to have that information. You have the right to file a complaint, of course. with OSHA and to participate in the OSHA inspection. And you have the right to be free from retaliation. Now, workers also have responsibilities. Okay, and according to Section 5B of the OSH Act, each employee shall comply with the occupational safety and health standards and all applicable rules, regulations, and orders. That's just about the size of it. That's about it right there. You have to comply to all of the standards as you know them to be, and your employer has to make sure you know of all the hazards and provide you with all the personal equipment you need. So now we will, I think this is one of our audio presentations where you'll be asked to answer a couple of questions. But as far as the OSHA standards, what are OSHA standards? The OSHA standards are basically laws that OSHA has created to keep workers safe under certain circumstances. And so for every aspect, we study construction, our standard is the Code of Federal Regulations 29 is the book assigned to the Department of Labor, and there are a set of standards designed as follows. For general industry, which also apply to construction, the book is 1910. For the construction industry, the book is 1926. And for maritime, it is 1915. So when we say the book, all the laws, like every law in our country, has a number associated with it. And so for the laws associated with the construction industry for OSHA, they are 29 CFR, and then there'll be either 1910, those that apply to both general and construction industry, dot something, or 1926 dot something. Okay, so I have some handouts that we will give to our students. Feel free, if you have access, to go ahead and print those yourself. And next, we're going to talk about the inspection process. Only way that OSHA can enforce the standards is through inspection. And there are certain levels of inspection that take place depending on the level of hazard, or in certain years, OSHA chooses certain industries to target, basically. So let's look at the OSHA inspection process real quick.
OSHA's mission is to ensure the health and safety of America's workers. Enforcement plays an important role in the agency's efforts to reduce workplace injuries, illnesses, and fatalities. This video describes the general OSHA inspection process and the reasons for an inspection. OSHA conducts inspections based on imminent danger situations, worker fatalities, hospitalizations, amputations, or losses of an eye, worker complaints, referrals, targeted inspections aimed at specific high-hazard industries or individual workplaces, and follow-up inspections. Compliance safety and health officers, or compliance officers, are experienced, well-trained industrial hygienists and safety professionals. Once the compliance officer arrives on site and enters the facility, the inspection begins with the presentation of credentials. There are three basic parts to any OSHA inspection: the opening conference, the walk-around, and the closing conference. At the opening conference, the compliance officer will explain why OSHA is inspecting the workplace and describe the scope of the inspection, walk-around procedures, worker representation, and the need for worker interviews. The employer is asked to select a representative to accompany the compliance officer throughout the inspection. During the walk-around, the compliance officer will consult privately with
individual workers. Common questions may include, how long have you worked for the company? Have you or anyone else been injured or had close calls on the job? Does the employer provide personal protective equipment? How often does the employer provide training, and what is the training composed of? Is there anything you would change to make working conditions safer? After the walk-around, the compliance officer holds a closing conference with the employer and designated representatives to discuss the findings, possible corrective procedures, and reasonable timelines for correction. The compliance officer also discusses potential courses of action an employer may take following an inspection, as well as available consultation services. Following the OSHA inspection, the compliance officer will put together a report based on what was discussed or apparent violations. The information is sent to the area director, who determines whether or not a citation is issued. If a citation is issued, the employer has 15 days to take action, such as requesting an informal conference with the area director to discuss any issues and address the penalties, or contesting the citation. A safe workplace benefits everyone. OSHA uses both enforcement and compliance assistance to achieve this shared goal. Ensuring compliance with OSHA standards is an integral part of the agency's mission to keep workers safe and healthy. That's why OSHA is working to give employers the knowledge and tools they need to comply with their obligations and provide safety information to workers. OSHA's on-site consultation program offers no-cost and confidential assistance to small and medium-sized businesses. The program helps businesses identify workplace hazards, provides advice for compliance with OSHA standards, and assists in establishing and improving safety and health programs. OSHA Training Institute education centers also offer training courses designed for workers, employers, and managers on safety and health hazard recognition and abatement at convenient locations nationwide. For more information about OSHA inspections and compliance assistance resources, please visit OSHA.gov or call 800-321-OSHA.
All right, so inspections. Okay, so it says that there are about 2,400 inspectors for over 7 million workers. And so they target the most dangerous workplaces first. So definitely if someone calls in, that kind of thing. And you never want to fight an OSHA inspector, guys. Okay? You just don't. Because, if they're there for a reason. Okay? And you need to make sure you keep your workers safe. So why was OSHA created? The intro to OSHA? Well, OSHA was created after 70 years of workers dying, us trying and then not doing it, government officials not caring enough, like most things, right? Which is ridiculous, to keep all Americans healthy and safe when they're at work. So by 1970, they got their act together with President Nixon, and they created the OSHA Act through the Department of Labor. They have things called OSHA standards, which are the laws in which we're going to go through in very good detail. We know that the owner has responsibilities and the workers have rights. Here is a link to OSHA Gov. It is a government agency. So, and as you can see, when OSHA was first created, they made it a law. It was first only for federal employees, right? Just like everything's good for the feds. And then we get it. And then eventually, yes, we ended up with OSHA for individual employees. So if you're a student, for $5, if you're watching this, $5 Starbucks card take the test, pass it, and I'll email you some Starbucks for your for your time. And so, what will we study after we know why OSHA was created? Well, we're going to go back to. I hope I can. I hope I can. No, I can't. Oh, you know what? Oh, that's right. I'm actually on my work site. So let's go back to this one. So now we will go on to study the next topic, and what we'll cover next week is the focus 4, right, or fatal 4, the 4 most deadly things or reasons employees are injured, dead, killed, injured, whatever. So we'll do the focus 4. That'll be next. But then, yes, we study all of these, and eventually, if you have access to this site, all of these links will be active eventually for you, so you can go through each one and look. But yes, so we'll be covering OSHA 10, of course, covers 10 hours of study. We do have mandatory, which is pretty much these right here are the mandatory ones. Right here, pretty much right here. And then they get to choose from all of the others. So, and I do always recommend a leadership class for one person in the company to be the local trainer for the company. Now, also too, at any time, OSHA could walk in and ask you for any of the following forms. Are you ready? And we will have links to each of these, a little video for each of these that say the reason, how you fill them out, what you need them for. But yeah, you need all your forms. Okay, so that is OSHA Live on Monday. And if you have any questions, please don't hesitate to email me at education@sfjohnsonconsulting.com. Otherwise, I will see you next Monday for free, but look all through the week for active links. And on the 15th, we will be, for our subscribers, have a drawing for free certification where you'll join other students and get your certification. Have a good and fantastic rest of the week. See you later.
Hey friends, this is Stacy with SF Johnson Consulting and Construction Services. Just wanted to give you a little short video on the differences between OSHA and ANSI. In a lot of the OSHA regulations, you'll see an organization like here, for instance, when we're looking at the personal protective eye and face protection, especially when it comes to talking about the gear that you'd be required to wear. It has to be ANSI certified in terms of like the glasses. They protective eye and face protection devices must comply with any of the following consensus standards. So consensus standards, meaning this is an organization that is a nationwide, even maybe worldwide organization where they, in terms of safety, everyone has agreed that the gear, the eyewear, the respiratory protection, the PPE of every kind has to meet certain standards. And so ANSI is the American National Standards Institute, and I have that here. Yes, the American National Standards Institute. So, American National Standard Institute, ANSI, is a private nonprofit organization that administers and coordinates the U.S. voluntary standards and conformity assessment system. Okay, so when you see ANSI in the equipment or whatever, I would, say look it up. Basically just an organization founded in 1918. The Institute works on close collaboration, still early, with stakeholders from industry and government to identify and develop standards and conformance-based solutions to national and global priorities. So would say that keeping you safe should be a global priority. Together, standards and technical regulations impact up to 93% of global trade. So yeah, OSHA sets its standards based on ANSI. And so if you have any questions about anything related to that, just let us know. Email us at education@sfjohnsonconsulting.com. See you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. And I just wanted to introduce you to top 10 cited violations number 3. And we're talking about respiratory protection, failure to provide. And what is the standard? Well, the OSHA standard is 29 CFR 1910-134. It is in the general standard and also in the general standard for the construction industry as well. It requires that employers provide employees with respirators that are, quote, applicable and suitable. And so what does that mean? Well, if you're going into a confined space and vapors and that type of thing, you can't just go in there with a N95 mask. Okay, so they have to evaluate the situation, as in all cases in construction. They're always supposed to evaluate the situation and give you the PPE that is appropriate for the situation. Okay, so applicable and suitable for the purpose intended when such equipment is necessary to protect the health of the employee. Now, the OSHA standard is going to tell you, it is going to be necessary for respiratory protection if you are in a situation where, and it is specific in the standard, we're not going to go into the specifics, but basically, like everything in OSHA, if there is a possibility of hazard to your health, or you may ingest through breathing, right? Respiratory is all about your breathing. If you may take in something that is dangerous for your health, where you're required to be protected from that. Okay, so there is a hierarchy of controls, and if it is determined that the type of work you do requires a respirator, then they must have a respiratory protection program. And the program requires an administrator that's qualified and knows how to train and knows when the respirators are defective, knows the different types of respirators that are needed within the different situations. And also the program requires that, of course, all of the PPE to the employee is to be provided at the expense of the employer. Okay. And so let's go over, they talk about if you can't perform engineering controls and administrative controls. So I just want to go over what that is and then go over, and this one's going to be a little longer, where we're going to go over a short video that goes over this, because this is really, really important in terms of your health. Every year when it's time to saw, cut concrete, that's the one thing you always see, right? You'll always see that silica dust in the air. So that's pretty much what we're talking about right here when we're talking about respiratory programs and protection, because that silica dust goes right into your lungs, and over time it affects your breathing. So let's talk about engineering controls in terms of respiratory protection. Well, what is an engineering control? Well, basically, it's a change in the design. So I've performed, let's say, for welders in the sparks, right? I will perform an engineering control where this is the control part, where we'll only have them welding in a specific area at a specific time, and there'll be an enclosure, right? Where the sparks can't go beyond the enclosure. Okay, so that's an engineering control as opposed to an administrative control where they will, it's more about admin. What's admin? That's more changing the times, including relief workers, exercising breaks, and rotation of workers. So we're going to move people out of the way when we have to perform this work. So that's more of an administrative control as opposed to an engineering control. Okay. And so what we want to do now is show a short video from OSHA in terms of the different types of respirators. That's what's important. And, you know, I mean, most of the time, I don't even see the gentlemen, because it's usually gentlemen that either doing the drywall, right, with the silica dust or cutting the concrete. It's all still that same silica dust. Never see them with the appropriate PPE. In some cases, with the drywall, they're covered in drywall. They're covered in the silica dust with no mask. 20 years, they're not going to be able to breathe if they do that every day. And so what I'd like to do right now is show a little OSHA video on respiratory protection. We're going to make it big. And then I may stop it every now and then to have a personal comment.
This video provides a brief overview and general information on respiratory hazards in construction and respiratory protection program requirements. The Federal Occupational Safety and Health Administration, also called OSHA, and state OSHA agencies require employers to have respiratory protection programs if their workers are required to wear respirators on the job. This video does not cover all of the things that your employer must do under federal OSHA or state OSHA respiratory protection standards. This video can be a part of the OSHA required respiratory protection training, which includes many topics like how to put on While this video discusses some of your employer's responsibilities under OSHA's respiratory protection standard, it is important to remember that the purpose of a respirator is to protect your health and safety. Gases, dusts, mists, and fumes may be present at construction work sites. Some of these can make you sick or kill you if you breathe them in. These gases, dusts, mists, and fumes are referred to as respiratory hazards. Some respiratory hazards act quickly, like carbon monoxide, which can make you unconscious or kill you in minutes. Other respiratory hazards can take years to make you sick, like asbestos, which can cause lung cancer decades after you breathe it in. More examples of respiratory hazards in construction include lead dust and fumes from grinding, welding, cutting, or brazing surfaces coated with lead-based paint. Silica dust from cutting concrete or sandblasting. Solvent vapors from adhesives, paints, strippers, cleaning solvents, and spray coatings. And isocyanate vapors from spray foam insulation and certain spray paints or coatings. When there are respiratory hazards at your job site, your employer must use several methods to reduce your exposure to them, including engineering controls, such as local exhaust ventilation, work practice controls, such as using wet cutting techniques, and administrative controls, such as minimizing the number of workers exposed to the hazard. When you and your coworkers cannot be adequately protected from respiratory hazards through use of these methods, then your employer must provide you with an appropriate respirator to protect your health. Respiratory protection must be selected based on the hazard you will be exposed to on the job. Not every respirator will protect you against every hazard, so it's important for your employer to select the right one. For example, filtering face piece respirators may protect you against particulate hazards such as dusts. However, a filtering face piece respirator will not protect you against gas and vapor hazards like solvent vapors. If you are exposed to gases and vapors, you will need a different type of respirator. For example, you could use an air purifying respirator with chemical cartridges or an atmosphere supplying respirator, such as an airline respirator or self-contained breathing apparatus. In addition, atmosphere supplying respirators are the only respirators that will protect you against hazardous atmospheres, such as carbon monoxide and lack of oxygen. Selecting an appropriate respirator is your employer's responsibility. When respirators must be used on your job site, your employer must have a respiratory protection program. This program must meet the requirements of either the federal OSHA or your state OSHA respiratory protection standard. The standard requires your employer to do the following: develop and implement a written respiratory protection program. Evaluate the respiratory hazards in the workplace. Select and provide appropriate respirators. Provide worker medical evaluations and respirator fit testing. Provide for the maintenance, storage, and cleaning of respirators. Provide worker training about respiratory
All right, forgot my mic's not on. You may have a little difficulty with some of the sound for 2 or 3 minutes earlier, going between the desktop audio and the mic. Okay, so I wanted to stop it there on the medical evaluation. So this is why this is the third highest violation, because really you can go to any job site where they're cutting concrete and chances are they're not using the water source to reduce the amount of silica dust, or they're just not wearing anything on their face, or they have scarves or something else on their nose. Okay, so that's probably, it's real easy to find, because you have to have something in a proper way for all of the dust and the particles. But you see there are so many different kinds and types of respirators, and yes, they most do require, especially the ones that require you the scuba gear and all that stuff, the ones where you wear the air on your back, that's actually like you're going underwater. Well, those are used in the most extreme cases where the air is just so contaminated that you can't take it in as a human, and you don't have to be underwater. Okay, so it's important that medical evaluations are performed. So you see why there's a lot of violations, because if you have to use this gear, it's a lot of expense to train you, to get you fitted. You have to actually be fitted for the proper gear. Every face is different, right? Everything is different. And so that's why you don't put your life and your family's livelihood in jeopardy because somebody doesn't want to give you the proper PPE for the job. So we'll keep it moving.
Hazards and proper respirator use. Evaluate workers' use of respirators and correct any problems. And provide you with access to specific records and documents, such as a written copy of your employer's respiratory protection program. Some of these requirements, such as training and fit testing, can be provided by an outside party, including a union, an apprenticeship program, a contractors association, or a past employer, provided they were conducted within the last 12 months. However, it is still your current employer's responsibility to ensure that all of the requirements of the standard have been met. Because each workplace is different, it is very important that your employer's respiratory protection program address the conditions found in your specific workplace. For example, workplaces may differ in the following ways: the types and amount of respiratory hazards present, the people who manage the program, the policies and procedures for tasks such as respirator selection, maintenance, and use, and other methods for controlling exposure, such as using wet cutting techniques to reduce airborne dusts. Since construction work settings change over time, the written program must be updated as necessary to account for those changes in workplace conditions that affect respirator use. For example, changes in workplace conditions could include new work processes or techniques, such as introducing sandblasting into an area, the use of new or different building materials or chemicals, changes in the amount of a respiratory hazard in the workplace, or changes in the types of respirators being used. Notify your supervisor if something changes in your workplace that conflicts with or may not be covered by your respirator training or established workplace policies or procedures. Your employer's respiratory protection program must be managed by a qualified, trained program administrator. This person must monitor the program and make sure that you and your coworkers are adequately protected. The program administrator will know a lot about your workplace respiratory protection program and should be able to answer any questions you may have about respirator use. The program administrator must know about the requirements of the OSHA Respiratory Protection Standard and must periodically evaluate the program and make any necessary changes. This video has provided you with a brief overview of respiratory hazards in construction and respiratory protection program requirements. There are many other things that you must know and do before you can safely use a respirator in a hazardous work environment. While this video may be a part of your respiratory protection training, your employer must also provide you with additional training on respirators, including worksite-specific training. Remember, if you don't know if a respirator is needed for the task you will be doing, or if you are unsure about how to properly use a respirator or which filter or cartridge to use, talk to your supervisor before entering the hazardous area. For more information about respirator use in your workplace,
Okay, so I think that's pretty complete. Violation number 3, failure to provide respiratory protection and program. So remember, just about anything, if you're at work and you're performing an operation, you can smell something that's not like food cooking. That's like the only thing that's okay to smell at work. Then chances are, or stuff flying through the air, right? Or fumes or anything like that, chemicals that are being used that are going through the air, chances are you need respiratory protection. And so make sure you, take heed of everything we show here. And of course, join our program. We teach OSHA 10 and 30 every day of the week. And we'd love to help you complete your safety education. Any questions at all about this, please don't hesitate to email me at education@sfjohnsonconsulting.com. And I never ask, I'm supposed to ask, I'm new to doing this, even though, I should not be. But if you like this, please say so and subscribe. Thanks a lot, guys, and I'll talk to you soon. Hey, guys. This is Stacy with SF Johnson Consulting and Construction Services. And in this presentation, we're going to show our students how to look at a demo sheet and kind of go through the process of what we do when we perform a demo takeoff, pricing, and completing a professional estimate. So our takeoff class that we present each of the scopes of work. So whether you're having to do your demo estimate or a flooring estimate or a framing and drywall estimate, we will show you how to measure your takeoffs, or your takeoffs, remember, is a professional construction, if there is such a thing, term for measurements. So we show you how to take your measurements, and then of course the measurements from there, we price the measurements. And remember, everything in construction is like everything in the medical industry. There is a code associated with it, and with that code, there is an amount of time that the construction industry states that it takes to perform that scope of work. So construction industry knows, excuse me, how long it takes you to frame a wall, how long it takes to install drywall. And so you take our measurements. That's part one. Part two is to go through our cost book, and we show you what amount of time goes with pretty much everything that you could possibly do. And the third step is to go over our professional Excel spreadsheet that's designed for each of the scopes of work. So in this class, we're going to go over demo. And so we're going to, this is a 4-H center that's going to be modified. So the first thing that when you are, of course, you're going to read your specifications, right? Specifications is going to give you everything about the project, all the details you need to know. Remember, the specifications is also the industry standard that we use in North America to help us communicate in terms of the means and methods and material we use in construction. And so you're given a set of specifications along with the construction documents, and the good estimator or the good project manager will read the specifications first and take notes related to each of the scopes of work, and then line that up with what we read and what we see and what we measure on in the construction documents. And so for demo, we know that it is demo because anything that is to be demoed or demolitioned or taken out is always shown with a broken line. And so this tells me, okay, I'm probably taking out walls as well as the partitions, or really I need more detail because these may be partitions, these may be partitions with tile on them, or the typical bathroom partition, which is just attached to the wall, like when you go to McDonald's and go to the bathroom, those kind. So the first thing we do is measure or count. In our case, we're going to be it looks like demoing a lot of doors and some showers. That looks like that's a shower. And so again, we're going to make all the measurements, do all the counts, and from there we're going to jump to how long does it take to do each individual thing and do the math. So if the cost book tells us it takes an hour to demo a window, then if we have 20 windows, bam, we have 20 hours. So one thing about windows, and when you take the class, we will go over in detail how each of the items here, what type of measurement, how do we need to measure that item in order to line it up with the cost book, in order to line it up with how long it should take. So for windows, whether we're cleaning them or demoing them, it's always per square foot of glazing. And so, yeah, you have to have some kind of elevation view so you can determine the height of the window, so you can determine how many square feet. So that's just one thing. But when it comes to the doors, we just count how many doors, because it takes a certain amount of time per door. And if it's a partition like the kind in a bathroom at McDonald's, that takes a particular time, as opposed to demoing a interior partition. How long it takes to demo an interior partition depends on the thickness of it. Is it 6 inch, 3 5/8? Is it concrete? Is it a concrete wall? Also, with concrete, when we demo concrete, we're not only having to determine how many square feet of concrete we have to demo. If we have to demo, say for instance, this is probably this right here. Say for instance, they want us to probably take out the concrete in the building. Well, the first thing we have to do is cut it out, and then we dig it out. So we always have to have a takeoff number for our saw cut, because we typically cut it and then we demo the concrete. Those are two different scopes of work, two different man-hour totals, two different takeoff totals. So that's important. Okay, and so always make sure you know what your scale is, because the scale is used to make sure you're accurate with your measurements. And so this is a really good demo plan. We're demoing a lot of doors and walls, partitions, toilets, showers, and so we do all those counts and measurements, and then we come up with numbers. And from those numbers, we're going to go to our cost book and see how long the construction industry states it takes to do each operation. So that's a little small overview of a demo takeoff when we're preparing a demolition estimate. Each linear feet, and we need some kind of elevation view, especially if we're demoing walls, right? We need to know the height of the wall, not only the thickness of the wall, but the height of the wall. Same thing when we're building them, have to know all of that. So we'd love to have you in one of our classes, and any questions at all related to construction, you can always ask me. And our website is S as in Sam, F as in Frank, johnsonconsulting.com, and have a great week. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. Just wanted to review something very quickly on, a few people have asked me, what exactly is OSHA 10? What's in the class? What's required? And how do we now with COVID take the class? Well, last question first. With the COVID, we can now take all of the classes or teach all of the classes online. As long as we have 3 students at one time, then we are able to do that. We just need to let OSHA know ahead of time. And now, what is OSHA 10? Well, the 10 and the 30 refer to how many hours of instruction, and it doesn't include breaks, and it doesn't include testing and things of that nature. So it's always usually a little more than 10. It's all of the industry standards, which are the laws, of course, established by the Occupational Safety and Health Administration, a department, part of the Department of Labor, right? OSHA was established in 1970 to keep employees safe at work, right? So that's what this is all about. So OSHA 10, it's 10 hours required. So let's go over just some stuff here. And let's see. All right, so what is OSHA 10? How does Fed OSHA differ from Cal OSHA? We'll talk about that. What classes are encompassed or a part of the program? What classes are mandatory? And what are the elective classes? Well, Fed OSHA is the set of standards that's good for all 50 states. And Cal OSHA, some states like New York, California, there are quite a few others that have additional standards that they try to make a little more strict than the Fed standard. And so in most cases, the Fed standard is appropriate unless your company wants you, or the government asks you to do the, in our case, Cal OSHA, in addition, or to have that. Okay. And so that's how that differs. Now, what is a part of the program? And we'll just go over that. Next slide, please. Okay, so OSHA 10 is a 10-hour workplace safety program developed by the Department of Labor in 1970. We feel that anyone in the field of construction, whether you work in the office or out in the field, you should have an OSHA 10 certification because it helps you to be aware of the hazards in construction. So whether you're personally related or a coworker of yours, you can assist the office, the company, in maintaining a safe work environment for your coworkers and office staff and all of that. So there is a difference between 30 and 10. Of course, 30, you're going to do 20 more hours. We recommend that the 10, again, is for anybody in construction, whether you are actually a carpenter or work in the office. And 30, we recommend for anyone in the management position because there are a lot more classes. I mean, you should take 30 if you're in construction, period, as far as I'm concerned. I'm a nerd. I love to learn. So, but 30 is really company-wise if they want to, in terms of cost effectiveness, right? 30 is more for managers. And the only difference is in that you have a lot more classes, of course, more detailed classes. So we'll go over that. Where are we? Here we go. All right. Now, OSHA has designed the plan with a set of mandatory classes, and another set called electives. So the mandatory classes, of course, are mandatory. Whether you have OSHA 10 or OSHA 30, you have to take those sets of classes. And then the electives, you can choose from a variety of classes based on the work that they do. So if you are a company that works with cranes, well, you'll take that as opposed to one that doesn't and has no need to have safety standards related to cranes. But if you are a general contractor, of course, you need to have the OSHA 30 on top of it and make sure you have all of that. So that's pretty much it. And so mandatory classes introduce OSHA and focus on actual injuries experienced by the workers and how to protect them from those. So basically, mandatory classes focus on what is OSHA, why was it established, and then workplace injuries covers that, and owners or employees' responsibilities, employers' responsibilities, and then it focuses heavily on the focus for or fatal for hazards, health hazards, and PPE. Everyone's heard of PPE because of COVID. It's your private personal protective equipment, so headgear, feet gear, respiratory, that kind of stuff. Okay, and these are the mandatory hours that must be no less than 6. And so all of that you got to cover in 6. But each of these individually, like the focus 4, you have to do an hour of this, hour of that. You have to have at least 30 minutes of intro to OSHA. So there are set standards where we have to make sure you are in class, face to face, even online. You have to your face has to show on your computer, and we have to make sure that you are aware and that you're paying attention. And so there are a lot of activities. And then the good thing about the breakout rooms, that's always a lot of fun. So we do that. That's how we help the students become interactive and kind of take a real active part in the class. And so that's what we do. So that's a little bit about, now let's see, I think on the next slide we have there we go. So the elective courses. Okay, so 6 hours of mandatory, and then the remainder can be these. And so 30 minutes in length, cranes, derricks, hoists, elevators, and conveyors. These are your electives that you can choose from. Okay, so excavations, material handling, storage, use, and disposal, scaffolds, stairways and ladders, tools, hand and power. So those are your electives that you can choose from for the remaining time. So if you have any additional questions or would love to join OSHA Live, which is our ongoing OSHA class that we have for our students, where we teach all this stuff on an ongoing basis. And so with OSHA, if you have up until 6 months to take your classes to get your certification. And so our OSHA Live class is a live class where you join with us and we go over everything that's required for either OSHA 10 or OSHA 30. It's a monthly plan and it's not expensive at all considering what we do and what we help you learn and retain and achieve. So any questions, please email me directly at info@sfjohnsonconsulting.com. Otherwise, I will see you on the next video and then the one after that and the one after that. And look for OSHA's 10 most cited violations. I think we have that coming today, and today is Monday, September 12th. So that'll be showing up real soon this evening, probably at the end of the evening Pacific time. So thanks a lot, guys, and I will see you soon. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we are going to review the scooter's electrical plan, just in short review prior to doing the electrical estimate and the takeoff and putting everything together. All right, so what we're looking at right here is E0.01, which is the electrical site plan. And if we pan in really quickly, they give you kind of a quick overview of it. There's a drive-through, and this is typical of any drive-through, where they'll show you the menu loop, where you drive over it so they know you're there, and then the speaker and all of that. And then that is connected underground to the power of the building and to the service loop, service window, all that good stuff. So that's kind of like in a nutshell, showing you each of the electrical components for the site. And this is the electrical site plan in general. So here's the building. And then here is, and of course there's always keynotes, so you have to follow each of the keynotes to see where it tells you what it tells you what to do, junction boxes. And then when we get into the electrical power plan, this is how they tell you which of the panels, panel A, and what position on the panel that piece of equipment is directly connected to. And we know it's directly connected to because this arrow represents what's called a home run. And of course, when you hit a home run, right, you hit the ball and you go all the way around. Well, basically an electrical home run is telling you to go directly from that junction box to that panel A, position 3, and then whatever 5 and 1 is telling us, we have to make sure we follow that too. And so all throughout an electrical plan, whether it's the lighting plan, site plan, power plan, you're going to have some power component, in this case, some exterior building lights that are directly connected to each other. Okay, and same thing for outlets in a room directly connected to each other. And at some point, it's going to be directly or home run to a particular panel and a position in that panel. So depending on, these are all commercial buildings. So, I mean, the smallest we have seen is a 10 position distribution panel, or you have 84 position panels. It really depends on what the power requirement is and what they're doing in the building. Okay, so this is the site plan, shows you the loops, all of the underground. Of course, it's going to be underground wiring, so they don't need to show it ... underground, which broken line indicates underground because, yeah, it's the site plan. We know just by virtue of this being a site plan that this is all run underground. Okay, and to the building itself, and then there's some other things and parking lot lights. I don't see parking lot lights. That must be coming along later or whatever. So it's all the signs for the building directly connected to a panel at some position. Okay, junction box, waterproof. Okay, so that's the site plan. And The photoelectric plan shows you how the light is supposed to be distributed throughout the parking lot and all of that, but that's not really not for us as estimators. Some specifications. All right, now this is our panel. So we have a 84 position panel, and it really, when we get in a more detailed class, you know, we can give the details of everything, but basically it's going to show every position on the panel and what is connected to the panel. And then if there is a breaker, the size of the breaker, 20 amp, 1 pole breaker, depending on the equipment, it's going to be a different size breaker. And so when we're doing an estimate, we have to make sure we count how many different types of breakers we have, and then the particular type of panel that we have. Okay, so this looks like we only have one panel for the scooters, but it's an 84 position panel, so it's a pretty big panel. And you should also be given what's called the single line diagram, which shows, and this is a single line diagram, which shows from the utility transformer, which is the power that comes from our city. It's the utility transformer. We have to bring that power into underground conduit and wire to the meter, to the building disconnect switch, and into the building to the panel. And it looks like they have a time clock that controls all the lighting and how the lights come on and off and all that stuff. So that's a single line diagram required in every electrical set to show you how the main power is coming into the building. You're always going to have a meter, you're always going to have a building main disconnect, and then directly connected to the panel, that 84 position panel, and a time clock. So it gives you more details about how the outlets in the boxes should be wired and positioned. And again, all that's going to be in the specifications. Some legal requirements, and now we get to the two plans. For electrical sets, you're going to have two plans. So one plan is going to tell you about all the lights and how they're controlled. So it's going to be the lighting plan, and that's what we're looking at here. There's a lighting schedule telling you it's calling this one light A, this is what it is, da-da-da. So when you have to go and order those, you know what you have to order. So all of these call outs and all of the symbols you'll see on the plan. And it's a small little establishment, so it's really what it has, 2, 4, 6, 8 lights, some junction boxes connecting them, the emergency lights as required, and then the conduit that connects the lights. And then those are the building lights we saw from the site plan. And then the good old home run. Okay, now some plans have it, some plans don't. On your lighting plan, it's only the lights and how they're controlled. So the light fixtures, junction boxes, occupancy switches, that dollar sign is always a sign of a switch. Electrical, you have a ton of symbols. And so as you work on these more and more, you'll get more familiar with all the symbols you have. All right, so what you won't see is the power panel on a lighting plan. And so you have to look at your power panel or your power plan, figure out where your panel is. So when you accurately measure your conduit length from your home runs, you'll know where you're measuring it to. Okay, so this is the lighting plan. It shows all the lights and how they're controlled. If this was like a larger place and we had like some rooms they wanted on while other rooms were off, it'd be a totally different configuration, and we have some videos of that as well. But this is a really small place. All the switch bank. Okay, so lights, that's one of the plans you'll get in the electrical set, and the other one is the power plan. So power plan is only going to show you where the panel is. So now if I go back to that lighting plan and I have to run all my home runs, I know I'm going to run it to right here. See, it's probably right here, but they don't point it out that that's the panel, because on the lighting plan, the job of the lighting plan is to show you just where the lights are and how they're controlled. Okay, dimmer switches, exit lights, but no call out of the power panel. So now I know if I have to connect this junction box to here, I'm going to go right there. I'm going to measure just that length plus some distance down directly to that panel at position 50. All right, so power plan is way more complicated than the lighting plan, because the power plan's job is to show you where all of the outlets are located. Junction box is required to connect other pieces of equipment. Quad outlets, meaning 4, so that's an outlet that has 4. That's an outlet that has 2. Sometimes they have outlets that only have 1, so it just be one line sticking up. But in an electrical power plan, the job is to show you every component that needs power, what position on the panel it's connected to, what it is, and also it's going to also show you where the phone special receptacles and phones and data jacks are for electrical set. The high voltage electrician will always have to provide junction boxes and conduit for all phone, computer, all that stuff based on, the specifications. Okay, so the power plan is way more complicated than the lighting plan, because its job, again, every outlet and what position on the panel it's connected to. Okay, all of the HVAC equipment, where it's connected, disconnect switches, that's going to be somewhere we need to know the value of those, because large equipment always has a disconnect switch, so we'll cut it off before it burns the building down. So large pieces of equipment always have a disconnect switch connected to it, where all of the outlets, its main means of disconnect are the breakers on the panel. Okay, so special receptacles in the CLG in the ceiling for special lights and stuff, whatever. Okay, so the electrical power plan's job is to show you everything that needs power in the building, how it's connected, what panel it's connected to, also data phone outlets, where they are, and tons of keynotes that you have to make sure you read in very good detail. Okay, so electrical set, lighting plan, power plan, single line diagram, all of those things that are needed to help the electrician properly power and light the building based on the specifications, based on the power requirements. Any other questions, concerns, please visit our website. We'd love to teach you more about this and other topics at S as in Sam, F as in Frank, johnsonconsulting.com. Thanks a lot, and have a wonderful rest of your day, week, year, and life. Talk to you soon. Hello, this is Stacy Johnson with SF Johnson Consulting and Construction Services. And in this small class, we are going to discuss the shear wall plan in the structural set. Now, the shear wall plan is basically just additional framing that we put over our load-bearing walls to shore it up and to help prevent the building from falling due to shear winds and earthquakes and things of that nature. So the shear wall plan is pretty simple. Where in this on this set, they note them as P1 and P2, and they show you exactly where they should go. So it's really simple. Where P2 goes here, just this length of the wall, that length of the wall. P1 goes in 3 locations on this side, right side, and then this wall on the left side. So it tells you the configuration of each of the shear walls. It indicates one side of the wall to receive 15 over 32 inch sheathing fastened with 8D common nails, 3-inch on center. So 8D is the size of nails, and they're just telling you to place them every 3 inches at the panel and boundary edges with 1/2 and 12 inches off center at the inner supports, and then additional 3x6 studs at the edges. Okay, so it's really simple, and P2 incorporates some LVL beams with 2 rows of 16D sinker nails at 16-inch off center at panel edges. Okay, so Shear walls really just additional framing over your load-bearing walls to help strengthen the wall. And so here on the set, this indicates a hold down. So they have A, B, and C. And so you can identify each one and, come up with a pretty good material quantities list. So shear walls is probably the easiest thing you'll ever have to determine. And the length of the height of the wall is usually the height of the building, right, or above. So you'll check the section views, and there should be a detail. It should give you a detail there. It should be a detail sheet to tell you the configuration, even more of an elevation view of the shear walls. Okay, so that is the shear wall plan. Very simple, very easy additional framing that goes over your load-bearing walls to strengthen them, to prevent the building from collapsing due to wind and earthquake shears. So if you need any additional help, please feel free to sign up at our website at www.S as in Sam, F as in Frank, Johnson, consulting.com, where we will set up online office hours for you to help you a little more if you do need it. But once again, thanks for joining, and I will see you at the next class.
Every morning, when your feet hit the floor, tell yourself today is the day. Today is the day I will be at my peak. Today is the day I will set my life up to win. Set my future up for success. Today is the day I plant seeds that will grow into greatness in my future. Today I will give my all every minute, every moment, with everyone I encounter. To live a great life, you gotta get your mornings right.
Don't just wander out of bed and throw yourself aimlessly into the drama of this world. Set your foundation for a strong day, which will lead to better habits and in time, a better life. Get up with purpose and develop a routine that works for you. Work out. Get your body moving. Create a habit that builds a strong body and a strong mind. Be grateful. Spend at least a few minutes in appreciation for all the things you do have and for all the opportunities that are coming your way today.
Thank you. Thank you for this day. Thank you I'm alive. Thank you I'm healthy. Thank you for my family. Thank you for my drive, my passion. Thank you for the opportunities coming my way today. I am ready.
Set your goals and intentions for the day. No one will reach their most sought-after destination if they don't know where their place is. What are you going to accomplish today? What miracles are you going to create today? Write them down. Believe you can do it and get to work.
Start your day with power and intention, and you will live your life with strength and direction.
This is my day. I control how I react to everything today. Today I will plant seeds for my future. Today I am alive. Today I am grateful. Today I look for the good. Today I notice opportunities. Today I execute.
Visualize what you want from this day. Believe great things are coming. Meditate. Clear your mind of all negativity. This is your day. Set your life up to win.
How you start your day often determines how you live your day. How you start your day determines your future. How you start your days consistently determines the quality of your life. You must set up a morning routine that gets you in a strong, positive mind frame, ready for anything this day will throw your way.
Ask yourself the most important questions of all. If today were my last day on this earth, how do I want to live it? What example will I set? How will I treat others? Do not let your dreams go up in smoke. You have opportunity this day to make it your greatest day ever, even if nothing comes this day. Your attitude will be better than any other day, and that alone will lead to great things. You just keep doing it every day, growing, evolving, giving your all, and you will achieve great things. I guarantee you.
The best day of your life. That day is today. Today is your chance to become who you were designed to become. To do better. To be better. Today will be the greatest day of my life. Today I am on purpose.
Show me a successful person that aimlessly gets out of bed, wanders out into the crazy world, and succeeds at a high level. They don't exist. Get yourself together in the morning. Get up early. There's a reason why so many people get up earlier than the rest. No one can bother them. The early hours of the morning are the best time to think without distraction, to create, to set goals, and to clear your mind of any doubt or negativity.
Do what works for you. Just build a strong foundation early in the morning. A strong foundation that will lead to a strong life.
The first thing I do when I get up each morning is say thank you. Nothing in this world will get you in a stronger, clearer state of mind than starting your day with gratitude. Gratitude is not for every now and then. It's for every single day. Gratitude is not for weirdos, it's for winners. Successful people are grateful people.
Stay away from social media and news. There's plenty of time to fry your brain for the rest of the day. The morning is time to clear your mind of crap and power it up with positive, powerful thoughts. If it works for you, get in some affirmations. Develop the mindset and belief of a winner. Stand like you already have it. Believe like you will get it. Know that it will come if you keep working toward it, if you keep finding out how you can get it. Prepare your meals for the day. Your body is your temple. Don't get stuck and have to feed it garbage. Your temple deserves solid foundations. Strong food, strong body. Strong body, strong mind. Strong mind, strong human.
Today will be the greatest day of my life. Today I am on purpose. Those who live great lives know the power of the morning. The power of creating strong habits in the morning. A morning routine that will set you up for an unbreakable day.
Hello, this is Stacy with SF Johnson Consulting and Construction Services. And in this small video, we're going to discuss the door schedule and some window elevations. Now, everything in the construction set is very important, as is the door schedule. And so we'll take a look at the schedule. This one also includes some details for the door jambs and some other things and some other exterior details, but we're going to focus on the door schedule. Now, in any project, every door is listed on the door schedule, even if it's the exact same size, regardless of where the door is, if it's a small door, if it's the storefront doors, if it's interior doors, exterior doors, they're all listed on the schedule and by the size, the door type, which they'll give you an elevation view of the door type. So those are the different door types, A, B, C, D, and E. So if you have to price them, then you know the exact type, and hopefully from a material supplier or a cost book you'll be able to get a pretty good price for that door. So it gives you the height and, well, the width is the first number. Height, of course, is the height of the door. And if it is a pair of doors, it'll let you know. Okay, and so the type, the frame, depends on, each of the different doors may have a different frame type. That's SF is most probably a steel frame and a hollow metal frame. And in commercial construction, most of the frames are hollow metal frames. And so to give you information about, well, some do about the finish on the door, how it's painted, and then all of the lock set and all of the hardware that's associated with each of the doors. So that's the door part of the door and window schedule. And then, of course, the window schedule is going to give you an elevation of the windows or the view of the windows as if you're standing in front of the window. So you can determine the height and the width of each of the windows as well and how they're uh, looked at. And two, who would need this? Of course, whoever's installing the doors and anyone doing the caulking around the doors would find this useful so they could determine how many linear feet of caulking you need for the doors. So the door and window schedule is pretty simple. It just shows you all of the doors. And again, even if they're all the same size, which many of these are, they still have to list it. The type of door, let's move that. The type of door, the frame for the door, all of the framing details, and that points us to a detail that's probably on this sheet. That gives us the framing detail and a whole lot of other information. The stop, the threshold, the closer, the lock set, and water stripping, everything involved in the door. And again, the windows are going to give you all of the elevations of every window. Now, the difference between doors and windows, if you need to know the number of windows, then you have to look on the exterior elevations and count. Where if you need to know how many doors, they're all listed here, regardless if they're the same, they're all listed here. So we know that this project only has this many doors. But as far as the windows, again, we'd have to go count via the exterior elevations and count the different types of windows. I think there's probably 2 of these and 2 of those and whatever. But you got to look at the exterior elevations in order to determine the number of windows, where on the door schedule, it gives you the exact, you just count, it's there. For windows, again, you have to look at the exterior elevations and like for a high rise or for an apartment, chances are they're marked A, B, C, D. So you use a counting tool, count all the A's, all the B's. Then again, you'll know how many windows you have. Okay, so this is Stacy Johnson, SF Johnson Consulting and Construction Services, where we teach classes of every kind. This is part of the basic plan reading class where we're looking at the door schedule and the window elevations. Feel free to contact us at info@sfjohnsonconsulting.com on questions on this or any other class. Thanks a lot, and we will see you next time.
Hello, and thank you for joining me. And this is your teacher, owner, and operator of SF Johnson Consulting and Construction Services. And in this small snippet, we are going to discuss the ceiling plan for our series of our study of the plan reading basics. Okay, so now we're looking at the ceiling plan. So it's from the plan view, the view from above. And the ceiling plan is going to tell us all about our new ceiling construction. And so for commercial, the typical ceilings are going to be acoustical ceiling tile, which is represented by these lines that represent either the 2x2 tile or on this side, the 2x4 tile. And each of the rooms, it's going to have a ceiling tag or room tag, ceiling tag that's going to tell you 2 things. It's going to tell you the type of ceiling finish, and it's going to tell you the height of the ceiling. Not necessarily the height of the stud, so don't confuse the two. It is the height of the ceiling. And so on the ceiling plan, we're going to see everything that's going to go in the ceiling. Not only the ceiling finishes, but then we're going to see all of the HVAC supply grills represented by the X, all of the lighting fixtures and where they're represented, because the ceiling finish person needs to know, okay, we'll have 1, 2, 3, 10, 12, 15 less 2x2 tiles, because why? We have a grill in there, or we have a few of the tiles that need to be fitted for casings for the lights. Okay, so when you see the ceiling plan, you're going to see everything that's on the ceiling, that's represented on the ceiling, and it's typically for reference only for this whoever's installing the ceiling finish. So ceilings, again, for commercial, will have a 2x2 acoustical ceiling tile, 2x4 acoustical ceiling tile, and then we'll usually have some some gypsum or drywall, right? So this is saying that this is a drywall ceiling, and the height of the ceiling is 8 feet above finished floor. Okay, now, always have to take a look, because here on our ceiling plan, we also have a section view marker. And what is that? Well, it's telling the ceiling contractor, whoever's installing the ceiling components, that there is some other view you need to look at, because the construction of the ceiling is a little different. And so we're always going to take a look at that. So we're going to look at image number 1 on A103, which this is page A103. And now this is image number 1. So in terms of our framing, because this is for our framer would need to know this information. So you would have to break this ceiling construction down in the most practical way in order for you to make measurements and to determine a cost for this. So we're basically just looking at the menu board that's represented here, and it's basically a wall coming down from the ceiling joist as opposed to the floor plan where the walls come up from the ground. Same concept, just coming down from the ceiling. And then here on the right, this is the bulkhead. That is basically 2 walls, right, coming down from the ceiling, and then in between you have a flat surface like a ceiling. And so you would break it down in those 2 ways. And so how we would break it down, anytime we have a wall, we need 2 dimensions. What's the height of the wall? What's the length of the wall? And then we can determine the ceiling framing for this set or this section of wall. We know the height is 4 feet 10 and a half inches, and the length corresponds to the menu board, which is from the plan. We can measure here. That's the menu board length, and I think that's about 20 feet long. So 20 feet times the 4, whatever, how many square feet of that menu board framing you'd have to construct. And so you break it down to the framing, and it looks like you have the top plate. That would be that same 20 feet, right? The bottom plate, same 20 feet. And then you break this one down the same way. And so basically what you have is 2 walls that are 3 feet, 10 inches, whatever. Excuse me. You can combine that and say you have 7 feet worth of wall times what's the length of the bulkhead, right? The length of the bulkhead is this length, whatever that is. I think I can. Oh no, we have to change the scale. The scale is different. And see, when you're looking at a set of construction documents and it's trying to tell me that that's 4 feet, that's obviously not 4 feet, right? 5 feet, 4.9. So that tells me, something's wrong with the scale. But yeah, I was using the scale to measure this, right? And this scale is for every 3/4 of an inch, it's 1 foot. But I should have had it on this scale, which is much different. And so, yeah, the measurement's going to be different. Where the scale for this is, for every 1/4 of an inch, it's 1 foot. So I have to make sure I change the scale, and that's important, or else you'll be measuring stuff wrong. All right, now we can go back and see what's the actual length of that bulkhead length right there. If I click on it again, it's 15 feet. That makes a way more sense, right? So we can round that up to 15 feet times, well, we say 2 times these lengths. So now you see these lengths have changed because the scale has changed. And so scale is very important when you're looking at a set of construction documents, that it is correct, because it's obvious the menu board bulkhead is not 12 feet. Okay, that makes sense. All right, so ceiling plan tells us all about our ceiling construction. If there's a section view there, you need to follow that section view so you'll have a good idea of the construction of that. And you see it can become complex, very much so. But when we're talking about framing, all we need are 2 dimensions. What's the length and what's the height? And for the ceiling plan, we're typically going to get areas. So we know the area of this bathroom area is about 200 square feet for the bathroom. And we cut off the area for this, so we would determine that area, plus the wall construction here, wall construction there, wall construction there. That would be the ceiling in terms of our framer. And then if we're the acoustical ceiling tile person, we're going to measure the area of all of this, of the two different types. Okay, so this is the ceiling plan. It tells you all about the new ceiling construction. If we're the framer, we're looking for any drywall construction or that bulkhead construction. If we're the acoustical ceiling tile professional, usually they don't do the same thing. So if I'm doing the drywall, I'm usually not doing the ACT, or I might. It really depends. But we always break that down separately, of course. Okay, but the typical framer is not going to do the acoustical ceiling tile. Okay, so it shows us everything on the ceiling for reference. So we know if we are installing the acoustical ceiling tile, we know we have a couple less tiles because we're going to have a supply grill for the for the HVAC system, and a couple, a few have to be specialty made for the can lights that are going to be coming through that. Okay, so that's pretty much all you need to know about the ceiling plan. All new ceiling construction, each room is going to have a ceiling tag that tells you two things: the ceiling finish and the height of the ceiling. If you have any questions about any of the information, please make sure to visit our website, www.sfjohnsonconsulting.com, and fill out our online office hours, and we'd be happy to set some time aside for you to go over this one by one. But again, thank you for joining, and I will most definitely see you at the next class. Take it easy. All right. Thank you, everyone, for joining us today. This is your teacher, Stacy Johnson, with SF Johnson Consulting and Construction Services. And we are going over electrical estimating and the power plan and what we need to look at and review for our electrical estimates. Now, the power plan is a little more difficult because we need to focus in on everything on the power plan to make sure we are really paying attention to detail, and also that we are looking at every one of the keynotes marked here 2, 8, 18, 6, 7 to make sure we understand what we need to supply the electrician in terms of everything that's on this power plan. So the power plan is going to tell us everything that needs power. So all of the outlets and how they are connected to each of the power panels. And remember, this class, we're not going to go over how we are doing the wire runs. Okay, that's going to be a separate class. But yeah, each of the duplex outlets are going to need to go to, or going to need conduit and wire that goes to a particular panel at a particular position. And when we get into that, we'll know that we can run some of the panels in tandem because they are all going to the same position on the same panel. Okay, but as far as our estimate, we just have to be very accurate in counting everything that's on here. So in this instance, these are symbols for black is for a telephone or voice. White can be for data, but here it's saying a telephone outlet. There's a notation of C, so that could mean it's probably in the ceiling. Okay, so it's really important to look at all of your symbols. Make sure you understand everything when you're doing your counts. And again, all we have to do is make sure we have an accurate counting tool so we can click on a thing, click on something, and know that we have counted it. Okay. And two, you got to make sure you pay attention to all of the keynotes. Okay. Integrated ground in the ceiling. Okay. So, with the electrical trade, there's little quirks here and there, but the main thing you have to understand is when you're looking at symbols, say for instance, this one and this one, they look the same, but they're not, right? Because this, both have the prongs, right, coming out the right. This one has prongs coming out the right, but this one has prongs coming out the left, where this one does not. And so the biggest issue, because what you're trying to do is count all of the individual wiring devices. That's what we're looking at, all of the outlets, all of the everything, switches, if they apply to our power components, like this switch. Okay, So we have switches that are on our lighting plan to turn on our lights, but we have motor controlled switches on our power plan to turn on our mechanical equipment, such as fans, and this is probably a fan in the office. Okay, so it's very, very important. Until you get the hang of it, you need to make sure you print all of your symbols, because you'll have to count a switch, a motor rated switch. That's what that is. And read note 22 to make sure you understand if there's anything that goes with that you need to supply. Our whole point in doing a takeoff, right, is to make sure we count everything accurately that the electrician needs to produce his estimate. Okay, so these are symbols for special receptacles. Okay, and it's telling you the kind, NEMA 1530. Okay, so that's different from the regular duplex receptacles. Okay, so for the electrical plan, and this is a restaurant, different equipment requires, of course, as we did in the basic class, different equipment may require different wire configuration, right? And so it's important for you to find what that is when it comes time to run the wires, okay? Because as we know in commercial, most of the wire configurations are number 12, right? 2 number 12s and 1 number 12 ground. That's what we'll run for the typical outlets. But anytime we see a special outlet or any of the mechanical equipment, or if we look at the breaker, the panels, and we see that any of the breakers require a 3-pole breaker, chances are it's going to be a different wire configuration to run our wire. But again, wire is later. Okay, so for your power plan, for our takeoff, just start counting. It's really important that you have a good counting tool, so when you've counted this one, it's counted, there's a mark on it, you're not going to overcount, when you've counted each one. And it's very, very important to, where are our keynotes? Okay, so you don't have to read them all crazy, but you do need to make sure you note for anything you need to add to our takeoff, right? Okay, 3-pole 30 amp NEMA disconnect. Okay, so the disconnects are different than the breakers. Okay, so we need to make sure we note that. So anywhere we see the number 3, that's what we have to provide. So it's really important to make sure we look through everything for what we as the electrician have to provide. Okay, NEMA 4X stainless steel enclosure mounted on the face of the hood. Provided by the hood manufacturer. Okay, so what does that mean for us? That in this case, we just need to determine the labor to install that. That's why it's very important that you go through the keynotes and make a list of the things you need to include based on your keynotes, the things you need to include that are not specifically on your plan. Okay, so here for a restaurant or anything, is going to tell us all of the equipment, right? But then it's also going to tell us the wire configuration, right? Because most of it is number 12. But then we need to know if we need more. See, here's some number 10s for the microwave. It's going to be hardwired, right? So that's a number 10 wire. And so we'll know when we do our wire runs, wherever D20 is on the plan, D20 notes that it is the microwave. Okay, D20 is right here. Okay, so we have to do the physical run to panel A, position 3941, because we have, we've got, whatever, 4 number 10s or something. Okay, so that's up to the electrician, okay, how you connect it to the panel. All I know is, I know from my panel schedule that I need number 10s for that. So I'm going to do an accurate physical measurement that I need, 4 number 10s for the microwave. in a 3/4 inch conduit. Okay, so our goal for our takeoff is count, 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 count. Okay, count accurately. Make sure you know the differences between integrated ground. I always let my clients know, okay, we have some dupes that are duplex outlets that are normal, whatever. And then we have some that they note as integrated ground. So they'll know, okay, well, I have to, for their expertise, they need to know that, right? I don't need to know it, but my job as the estimator is to, break down this with precision. So they'll know, okay, I need 8 of these, 6 of these, 12 of these, whatever. Okay, and yeah. So that's the power plan. That's part 2 of our takeoff, okay? And again, if you need help, if you're in our estimating class, you get the 5-week, 6-week one-on-one class, but you also get a year of shadowing where I will review your stuff with you to make sure you're doing this stuff correctly for a full year. Because, a year of doing this one-on-one and the way your companies work you, okay, you're doing a lot of big work, okay? So we're going to make sure you know what you're doing, all right? So thanks a lot. This is part 2. The next part, we're going to go over probably the single line diagram, what to look for. We're going to leave the wire and the conduit stuff for last. And one thing I want to make sure we know, and we'll note that on the data and telecommunications plan, is that we're the high voltage electrician, right? So we only are concerned with high voltage. We're concerned with powering up everything and providing lights. Okay, we're not concerned about data, phone, but as the high voltage electrician, we do have to provide the junction boxes, okay, that the phone, computer, Comcast, all those people, they provide their outlets, but we do have to provide the junction box. Okay, so we make sure we have to count that, and usually it's a 3/4 inch conduit connected to the junction box to the right above the ceiling. So that's a little rule of thumb. You always got to make sure you account for that. All right, so that's going to be it. I wanted to make sure I added that. Look for the next class. Remember office hours. And again, your awesome teacher, Stacy Johnson, owner-operator of SF Johnson Consulting and Construction Services. Don't it sound like we have fun? We do. Talk to you guys later. Hi, everyone. Thanks for joining for this class today. In this electrical estimating class, we're just going to go over a brief overview of the lighting plan and what you should be thinking about when you are preparing your estimate for and in terms of looking at your lighting plan. Of course, the lighting plan is going to show us all of the lights in the project, where they're located, may give us some information about the branch circuits, the wire configuration for the branch circuits. It may may already be there, but as you see, a number of the lights, the fixtures, there is no wire configuration, so you don't really know how the wire is going to run. So you really need to be thinking about, when we go over how to run the wire, because there'll be a separate little class for that. Okay, so we'll be going over that separately. But in this class, we'll really be going over, what do I need in terms of the lighting plan, in terms of the items that are there, and we'll do, again, the conduit runs separately. Okay, so what do we need to look at, or how do we approach the lighting plan when we're doing the estimate? Well, really the only thing we need to do is to make sure we have a proper way of identifying between the different types of lighting fixtures. Okay, so these lighting fixtures, they are called LL4. Okay, and it's really important that when you're counting your fixtures, some are NLs, night lights. So you want to make sure you distinguish between, in this case, the LL4s that are regular, and then the LL4s which are night lights, because in terms of the electrician, they will have to get special adapters for the night lights and run them, different. And just a brief overview on why do we have the lowercase alphabet on some of the light fixtures, okay, as opposed to, in this case, having them connected to an uppercase slash number. Well, that's how the wires are configured, or how the lights are configured, or how they are powered. And remember, when we directly connect a fixture to the switch, that is a direct connection. So that's a representation of a toggle switch. So that light is directly connected to the switch, meaning when the switch is on, the light is on. When the switch is off, the light's off. And that's how those are represented. As opposed to when we have the lights that have the lowercase alphabet. So some are A lights. In this case, we see one has a D light. So those are controlled by lighting controls, right? And so when it comes to running the conduit between the fixtures, because we don't see it here, so we're going to have to use our imagination on how the electrician would run the conduit. Well, all of the D fixtures are all run together because they're all controlled by the D lighting control. All of the A fixtures are run together because they are controlled by the A lighting control, and so on and so forth. Okay, and the C lighting control, see, that should not have been connected to that because that's an A. And oh no, these are A's. These are light C, light we call C. So uppercase is how we identify the fixture. Lowercase, in the terms of the lighting plan, tells us how we are going to, what lighting control circuit the lights are going to run. LL2 right here is going to be controlled by the E lighting control, A lighting control, and so on and so forth. So when we're doing our estimate for our lighting plan, we just have to make sure we have a simple way of counting all of the individual lights. We don't care ABC, but how many LL1s, how many LL4s, how many LL2s, and so on and so forth, and make sure you always signify between the night lights and the regular lights. Okay, so you want to make sure you look at the keynotes in the event there's something you need to add in terms of your lighting. And in this case, emergency exit light doesn't have a notation, meaning it doesn't tell you what type of light it is. So in this case, there are two scenarios. In this case, it may already be existing, but if it is, it should be a light. It should be gray, not black. So I have to think in terms of, okay, sometimes these lights, they don't give a notation to, but they are on the lighting schedule. Okay, so you just have to name it. Where this one, see, this is different from that. It has the EM, so you have to make sure when you're doing your counts, you count these two would not be counted together. And it's very important on all of this stuff. If the note or if the fixture isn't exactly the same, then it's not the same light, so you would not add it in the same. And that's where most estimators make the mistake. They'll count this one along with this one, but they're not the same. That's an EM, that's an emergency light, where that's just, it's not wired in a different way, so you wouldn't add them or say that they're the same fixture. So for the lighting plan, the only thing we're doing is trying to count all of the different types of fixtures, how many of each. We're going to count, do we have junction boxes? Okay, and pretty much that's all you have on the lighting plan. How many switches do we have? And so the key to this is to make sure you have some type of tool to accurately count so you don't miss something or that you don't overcount. Okay, so that's the lighting plan, and the only thing we're going to cover here is the fixtures themselves, because we're going to have a separate video for how we determine the wire runs. Okay, so again, lighting plan shows us all the lights within the project. The one thing we have to make sure we do is get an accurate counting tool so we can make sure we don't miss anything. And also make sure if a light, in this case, excuse me, this is a night light, so we're going to count these separately because it does make a difference. So not too difficult. Just make sure you have an accurate counting tool. You pay close attention to detail. Okay, if the fixtures are not exactly the same, then you don't count them together. Okay, so pretty simple. So we start with the lighting plan because that's the easiest thing. And our next class is going to go over the basics of what we need for our takeoff for our power plant. And we shoot. If you have any questions on anything, remember that we have online office hours every day, Monday through Saturday, from 7 a.m. Well, really, the online office hours we like to have from 7 a.m. to 10 a.m. But we will schedule those at your convenience. So you just go to our homepage at S as in Sam, F as in Frank, JohnsonConsulting.com. On the lower right, you'll have a tab where you can sign up for online office hours. Give me your availability, and we will definitely set a time to give you some extra time, okay? So look out for the next class. It's going to be our details, what we need to look for when we do our takeoff for our electrical power plant. Hello, and thanks for joining me. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this class, we are going to discuss the roof plan in our multi-plan review of our plan reading basics class. And so we have the roof plan. Now, when we talk about the roof plan in the architectural set, we're only talking about the roof finish. We're talking about roof finish only, not roof framing, right? Because roof framing is part of the structural set. And so the finish is what we are discussing. And so when we look at the roof plan, we're looking at the roof from the plan view, right, from above. And really it reflects everything that makes a hole or a penetration within the roof, right? Because the roofer's job is to waterproof the roof, to put on the roof finish, and to make sure any openings within the roof are waterproof. No moisture goes through the roof. And so, as a result, the roof plan shows everything that has a potential to leak through the roof. So here we see all of the rooftop units, because all of the ductwork, right, is going to go from the rooftop unit into the building. And also same thing with the exhaust fans. The exhaust fans themselves, the hoods, are going to go from the interior of the building to the roof. And then all of the piping for the plumbing system for the vent to roof, all of that's going to go through the building. And so again, it's going to show all of the penetrations within the roof. And there will be detail sheets to show the roofer, how to in more detail on how to make sure that that's done. So some is here on this sheet where it shows the roof curb, and the rooftop unit sits on the curb. Within all of this is the roof joist, and doesn't give a good clear picture of the ductwork and all of that from this perspective. But here's another one that shows the vent pipe. Okay, and so the roofer knows how to put all of those, the pourable sealant, the membrane, how it's supposed to lap over, and everything else to make sure that no moisture goes in here. Obviously, you can tell from that it's pretty good. No moisture is going to go in. All right, so a couple of things specific to roofs when we're talking about a roof. We are always talking about the pitch of the roof or the angle of the roof, because all roofs have an angle. So all liquids and water and snow, right, run off of the roof into whatever kind of gutter system that they have available. And so what you'll see is the pitch represented on the plan. And so what this one says is for every foot or 12 inches it goes forward, the angle is 1/4 of an inch. So this is almost next to a flat roof, but it has a slight pitch. And the arrow's always going to point in the direction of the water flow, or the direction of the gutters or whatever. So we know that there's some kind of gutter system this way. Okay, so that you always see the pitch, and the pitch does make a difference when we're talking about the material for the roof, especially when we're talking about shingle roofing, right? Because it's not butted up against each other, it's lapped over, so pitch becomes real important because of the additional amount of material that you're using when you're installing shingle roofing. So pitch, that is one thing specific to the roofing trade. Another thing that's specific to the roofing trade is the measurement of those. Back in the old days, you get the shingles in bundles of 100 square feet. And so for roofing, we use the square, and we it's abbreviated capital SQ period square, and that's representative of 100 square feet. And so when we talk about roofing material, we typically talk about the square, or we price it by the square, which is, again, 100. It represents 100 square feet. So if we have a 5,000 square foot roof, right? They say, we're so cool. We say it's 50 squares. Hey, all right. So just know that's specific to shingle. Anything, even siding, they'll go by the square, which again is just representative of 100 square feet. All right. So the roofing plan, all of our roof finish shows you all of the roof penetrations, and it will give the roofer details on how to close in those penetrations, right? The pitch is specific. It shows the angle of the roof. And then we also have something called our crickets. And a cricket is just additional framing that's built over our flat framing when we have really flat areas. So it makes like a tilt. It makes an angle to where, again, all liquids can flow off of it. So usually when we have flat areas, this is a cricket that's built here, where this is the ridge of the cricket and this is the valley. So if water were to flow this way, right, in the direction of the pitch, it would flow this way. Well, it would stop here, and then it would flow down the valleys and into the overflow and the roof drains. Okay, so that's what a cricket is. It's just additional roofing that gives that area an angle where it would tend to be very flat. Alrighty, and there's a little cricket right there. Okay, so that's the roof plan. Roof plan view from above. Now, it's going to give us some section views here, but it's really just more so, the intersection of the parapet. Do we have flashing over the parapet cap, that kind of thing, So you got to always make sure you take a look at that, and that is exactly what that is for. It's flashing over the parapet cap. So let's go real quick to 3 over A425, and then it'll send us somewhere else. 425. 3 over 4. Do we have everything? There we go. 426. 425. 3. Okay, so we are the roofer. Because we are the roofer, we only care about things from the roof up. Okay, so we are the roofer. Now we know we have a roofing membrane, right, over 3-inch rigid insulation, then the cant strips and the riglet, and then we know we have all that good stuff. And now we have a call out right here. And so, we always have to follow the call outs if we think our scope of work is involved. Okay, so we also have a call out here. Okay, membrane flashing top parapet. So yes, that's our scope of work for the roofer. And then, we got to follow the call out. This is a call out. What is it doing? It's calling out whatever's in the circle. So if my scope of work is reflected in the circle, which pretty much is
Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and this is a episode for finishers only. And what we're going to be talking about in this video are the finishes, FRP. We're going to be determining some wall base lengths, cove base, and then it looks like we're going to seal concrete. Chip XPL system, probably some kind of coating as well. And remember, I always look at these for the first time in detail when I record them, so I don't rush through them. You know, when you're so familiar with something, you're going to rush through it, but that's not the purpose of the video. So we're not rushing. And so we're going to paint some stuff too. And the good thing about this, if like I will be doing, if I'm doing the takeoff for the finishes, then I'm also doing the takeoff really for construction cleaning, which is good because I have a client where I need the construction cleaning takeoff totals because, you know, for the finishes, they put them in, everything's still dusty and everything. So the final or construction cleaning has to go through and clean basically the same surfaces, the same linear feet, you know, and that's how that's priced too. It's like how many square feet of flooring are you mopping, or mirrors are you cleaning, or storefront glass glazing are you cleaning? You know, you multiply that by 2, you know. So when you do the takeoff for the finishes, it kind of helps you out because you're doing the takeoff for the final cleaning too. And so this is the plan view for the floor finish plan. And you know, what we'll need is the plan view for, you know, to get our linear measurements, right? But we need to know how many square feet of FRP, right? We need the height of the walls. And so we'll typically look at the interior elevations, or if the heights are all 9 feet or whatever, we'll look at that. Or worst case scenario, we can look at the reflective ceiling plan, because let's go to that real quick, because the reflecting ceiling plan is the purpose is to give us the ceiling height. And so, you know, worst case scenario, we can assume that the height of the finish on the wall is 6 inches above the ceiling height. Worst case scenario, if you don't have interior elevations, because you do want to get as close measurements for your wall paint. You know, there may be a portion of the wall, like in bathrooms, where it's tile 7 feet and then painting the remaining 2.5 feet or whatever. So you always want to have interior elevations, and this one does. So here's the interior elevations, and so yeah, it's a 10-foot height. So we guessed that pretty well. And so what's this? And what is that? I don't know what that is. And so sometimes the interior elevations aren't the best. It says open beyond. Open beyond. I don't know what this is. But okay. And so we can take our FRP totals really, and we just do the whole wall, and we have to paint the doors. And so we know the door square footage is this times 2. And then we also have to paint the frames. And so you have to measure the frames times 2. So, and then the wall base one here, and I don't know what 3 is. Let's see what 3 is. Floor sinks. Okay, we don't have to worry about that. So that's in the floor. They're trying to show that. That's okay. That's not cute. All right. And then 8 conduit. Okay. So for our FRP, everything has to be to scale. And I know all my plans are to scale, so I'm not really worrying about checking it. But you are supposed to check if you have because this is 10 feet, right? So let's get our dimension tool, like our ruler, from hash mark right in the center to hash mark in the center. Yep, 10 feet. So I know my plans are to scale. And so now I can just use the interior elevations. FRP, FRP. But we won't include the door, which we actually could, but we're not. And see now, this is the wall base. I like to be accurate, so I'm not going to include that. And we won't include the door. Give it a little extra for that. And so that wall is 146 square feet. So we do that for the whole thing. And then, of course, we have our cost book. Let's see how much FRP is. All right. That's ugly. Let's take my name off of there. That's ugly. Take the name off. Okay. Where's our search? Where did it go? Let's bring that up here. FRP paneling. So here we go. Here we go. So that's the typical almond or white $1.13 a square foot. Let's get that off of there. FRP wall and ceiling paneling, fiberglass reinforced plastic, textured at 0.09 of an inch thick, class C, flame spread. Oh, that's the flame spread is the class C. So we'd have to look if that is what they want for our project. It may be class A. If it's kitchen, it may be a higher rating. Who knows? But this is what the cost book is telling us the price is for this one. Spread 24-inch by 48 panels, includes fasteners, adhesives, and a 5% waste. So for that is what's included in the $1.13. So, and that's the man hour total, meaning that's how much of a man hour it takes to install one unit. One unit's 1 square foot. So we do all, if we have 1,000, then we say it takes what? 1, 2, 3 zeros, right? So we move 3 zeros to the right. It would take 32 hours, right? 32 man hours. So what? You would have a couple folks doing it, so it would take you a day. You knock it out in less than a day, right? Ta-da. Okay, so let's go back. Excuse me. I always got to cough. It's like, why can't you cough before you start recording, ding dong? I can't because I'm always recording. All right, so we do that for that. And then, these are windows, right? That represents windows. And so we might have to paint the window frame. So we want to designate window frames from door frames. Okay, and then the wall base, I'm going to go back to the floor finish plan for the wall base, right? And then the doors, I just know how many doors. And then the wall base, let me make sure this is to scale. And again, when we do this for the finishes, we're basically doing it for the final cleaning too, because we have to wipe down, clean down all this stuff. So now we know all of the FRP is 10 feet. So I can measure, let's just do it this way. FRP. It's all FRP. But we're not, we can go through the door and then we can delete however many square feet the door is, right? Because we know it's all FRP. And then if the wall bases are different, now we'll do that separately because the wall base doesn't go through here, right? Wall base doesn't go through the door. But see, you got to make sure too that you measure both sides, right? Measure both sides of that door for the FRP. And then it's all FRP. FRP. Da, 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 dun, dun. And we just gonna do that. That's probably corner guards that go over there, but that's okay. We want to make sure. So let's go from here and back all the way up, and then we'll look at the section view if we wanted to. It's typical, whatever, 2 over A 5.2. Let's go look at that. 2 over A 5.2, because you always want to look at your stuff. 5.2, what page are we on? 5.2. 5.2. All right. All right. So it's just telling us about, I don't know which one I looked at. Okay. Conduit, floor base, FRP. And we got this here. And then we have a sealant. So we know how our, at our floor, what it's supposed to look like. And then at the ceiling, of course, yeah, we typically go 6 inches above. All right. So yeah, that's good for that. And floor finish plan. So I need to do, I mean, they even have FRP in the bathroom. So, and so altogether we have 146 linear feet. So times 10, because we know it's pretty much all 10 feet. 1,460 square feet of FRP. And then basically, let's see, wall base 1. Is it all wall base 1? Because we could really subtract this length, this length. Is it all wall base 1? Yeah. So we know wall base 1 is the same length minus, oops, look, boop, boop. Da, da, da. Almost forgot that. Let's add this. And then we really know that wall base 1 is the same length as the FRP minus 2 times the door, right? And that door. So let's just call this deduct WB1. And then we good. We saved us some time. So we'll go from like here to here, do actual lengths from here to here, and then here to here, and everything else is wall base 1. Probably just do also at windows. We'll just give it the benefit of the doubt. Just say on the estimate we've included wall base 1 at the windows. All right, so we deduct basically 9.5 feet. So 10 feet will deduct. And then we know wall base 1. And then the doors are painted. We know we have 1, 2, and we just look at the door schedule really. And we know the amount of that caulking in between is the same length as the wall base. Pretty simple. Oh, and then the sealed concrete, because the whole floor is sealed concrete. Let's see. SC1. I think that's everything. Right? SC1. Oh, yeah. SC1. SC1. So that'll be real easy. Yeah, everything's SC1. So we just say concrete area or floor. Let's say floor, because we do a lot of takeoffs. It's like concrete. What is this? The foundation? What are you talking about? Cover. That way we really know we're not talking about the foundation. But what I will do is I'm just going to include all the walls. Well, no, I won't. Because it's always fun to do this. We won't include the walls, right? Ooh, let's see if it'll not mess me up. Watch. Here we go. Sometimes it does its own thing. Let's go back. Tighten it up a little bit. Watch my perfect wall. Bam. Because we are experts. New section. And let's take care of that old bathroom. Or is the bathroom? No, bathroom's concrete too. They're not really spending a lot here. There we go. Bam. All right, so we know our area, which is our area of the ceiling. If it's all acoustical, let's look at our reflective ceiling because that's a finish too, right? That's a finish. We need to know our reflective ceiling plan from our, if we have any gypsum board, which we don't, so our 2x2, I'm sorry, 2x4 ACT is the same as our floor pretty much. Our concrete floor, which is 604 square feet. So that's the same square footage. You might give or take for the lights and for the supply grills and the return grills. We don't care about that because they still have to adjust it. So anytime it's less than 2,500 square feet, they charge a little more anyway because of all of these that have to be adjusted for the size of the building. So same thing. All right, so let me see. I think we got everything for our 4 finishes only. Our paint, right? Let's go to our, where are we? Let's go to the interior elevation. Ta-da. All right, so we call this door area, and then times 2, right? Because we have to do both sides of the door. So, I mean, we could just, because we have 2 doors, we don't have to do it, but I like to show the kids. All right. New section. Where's that other door at? Here it is. Here's my friend, the door. All right. All right. And they say I shouldn't go longer than 10 minutes on these things because you guys get bored. But this is, you can't get bored when you're learning. All right, kids? All right. So let me stop that. And then our door frame. So we're just going to say times 4, right? Because 1 on the other side is 2. This one, 3, 4. So, I mean, we already know it's the height times 2 plus like 3 feet, whatever the width of the door. But let's just measure it. And we'll call it door frame times 4. Remember that. But then if we have like a zillion, then we'll have a different procedure to do this. We only have 2. Okay, that's close enough. So that's what? 17 feet usually. All right, 16.9 feet. So 17 times 4, because you price when you paint, right? The labor to paint something that's per linear foot, because that's how you paint that. It's a different labor rate than when we're painting something that's obviously a larger area. It takes more precision, so the labor rate on painting anything that's linear like that is more. So we always want to separate when we paint the wall paint, if we were painting the walls, we're not, from the ceiling paint, because ceilings you have to go up higher, so of course the labor is going to be more for that. And for linear, that's a higher labor rate. So I think we got everything covered for this one. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please give me your comments below and enter and subscribe to enter. I like giving away stuff. I also have a nonprofit, so giving's in my bones. We every month starting the 15th of October, we're going to give away a $100 gift certificate for Starbucks. I'm going to be giving away some free construction training of your choice by to all of our subscribers by entering, and if you so choose, or somebody you know, and uh, for companies that listen, we will be giving away $1,000 in free estimating credits for any of the trades that you see us teaching about. So, thanks a lot for joining, and I will see you next time. Okie dokie. We're going to get started again. Take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So
it's just the site and the shell building. Makes it real easy. And so now, this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing. So we won't break down the individual pieces of, say, like the foundation until, we're ready to win and do the work and get an actual pricing. Foundation assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree. That's how they base, either putting it in or taking it out. Okay, so that's important to know, and if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side. This is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is really attached to something, just like maybe this is. I don't know, but what's the scale on these plans? Scales in a funny place. There we go. 1 inch. Oops, cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. And in the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced, because that's how we price it. It's priced different if it's reinforced. So we're going to go like this. There we go. Come on, don't fail me. One and two. Yeah. Okay, so there's a lot of protect. So we just going with what we see remove and see. That's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. Alright. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just said. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Reveal an 8-inch sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Get into. Not our problem. Protect. Now the protect part, we can do some protect. Go into the specifications on how they mean protect, and we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels, probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. All right, let's go back. Let's get this one. All right, so what do we say that was? The panels are 16, 17 is curb and gutter. Okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. Then we'll just 17. All right, and panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. If those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. So 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. There's a separate one. I guess you just gotta go out there and see if you find some boulders, because they're not marked. So wherever the boulders are, get rid of them. That's extra. So all those are things to note, but nothing to really be able to determine because they're not shown this or anything. So that's like removing a tree, depending on the size. So that's that one. All right, so we go all the way down. The striping plan, really, we just now they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a 3 to 5 foot sidewalk. So let's see. We're going to do it both ways this afternoon when we come back together. So we are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right. So scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 inch. 6 foot, not even 6 foot. I go by 6 feet because it's closer. But then you got to make sure they're all 6 feet. See, that's 6 feet. D. Now that don't look 6 feet. See, that's 5 feet. 6 feet. What's that? Is that a special? That's a special kind. That's a curve right there. So, can we use all 6 feet? Or just measure how many linear feet? You know what? I'm going to use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk instead of doing it by the square foot, because that's we're going to do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're going to just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's the patio area. I'm going to make that different. And do we do all D though? Yeah. Alright. So that's the sidewalk. And then C was parking pavement. We're going to do that by square foot. We'll call that parking. And then we'll go by cost book wise, what it tells us. So we're just going to include all of that because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Oop. Oop. Going to Nilly Willy. Okay, let's just cut it off halfway right here. Cut it. Because I like to be as precise as possible. Alright, let's cut it off right here. this and this small little curve. Let's go. We're just going to add that. Very like surgery. Forgot I'm recording. I'm like, hey, it's still quiet. Except for the clicks. Alright, there we go. See. Let's see. Yeah, then we gotta come through and do the more annoying curves because we're a little bit. Ooh, look at me. Look at me. Alright, see? Alright, so striping plan. Why don't you call it the concrete plan? The heck? See, they broke it up in phases, but we don't care. Let's hope we're not asked. Alright, we got some arrows, so we do those separately, but in the meantime, what is B? Sidewalk. No. Did I say what? I said B. Drive aisle pavement. 5 inches. Then 9.5, 9.5, da da da. We'll look at the specifications, but I mean, we could go on, right? And what's G? We'll do G. Let's just know what it is. We got 5 minutes for this session. Oh, good. No. Landscape. That's good. That's where the flowers are going. Flowers, flowers. What's M? Bike racks. That's nice. Let's see. It's going to be flowers. Okay. Because that's still in this area and not in this area that we didn't include in the sidewalk. And you see right here, it's a little thicker. Right there. So we're going to say that's probably a, let's see. We don't have to guess. Well, what is this one? 4 inch. Okay, well that's the smaller one. So let's delete that one because we said they were all inch feet, not inches. So let's do this. This is still our 6-foot concrete up until we get to there. Then it's a 4-foot. 4-foot sidewalk. From here, right there, let's go over a little bit. From there to there. Okay, and then, yeah, we'll fill all that in the, while you're gone. And then A, we'll fill that in while you're gone. And then G's the landscape. It's A.